Introduction to Java. Java is a popular programming language. It was created in 1991 at Sun Microsystems by James Gosling and his team while working on a project called Green. They named the programming language as Oak programming language at that point in time. Oak is a tree name, and it signifies at that time there was another programming language called Oak. So they have changed the name to Java. Java is a coffee seed name, and if the logo will see coffee cup symbol. Let's uncover some important or key points about Java. Number one, Java is a simple programming language which is similar to C and C++. Number two, Java is an object-oriented programming language. Also known as hooks. Java is secure, and Java is portable, easy to move from system location other. And Java is also platform dependent. What does that mean? For example, you have written a program called test.java. Once you compile this Java program, that dot class is created, which is essentially bytecode equivalent of the Java program that you have written. And this bytecode test dot class can be moved to Windows and can be executed in Windows. It can be moved to Linux and it can be executed in Linux. It can be moved to Unix and it can be executed in Unix. Can be executed to, it can be moved to Solaris and executed without any issues. Can be moved to macOS and get executed. For this reason, Java is portable and platform independent. There is also another principle in Java, which is write once and run any number of times. Now let's look at two popular categories: programming languages. One is statically typed programming language. Second one is dynamically typed programming language. What what does this mean? Example, in your program, you wanted to use a variable called x, which is an integer. So before using x, you need to define the data type. We will uncover data types in a moment. But if you have to define the data type before you can use a variable, that is a statically typed programming language. And if you just declare the variable and assign a value without declaring the data type, but the programming language will assign the data type based on the value it gets assigned, then that's a dynamically typed programming language. So what is a popular statically typed programming language? Otherwise also known as SEPL. Java is a popular statically typed programming language. And dynamically typed programming language, also known as DTPL. The popular DTPL or dynamically typed programming language is Python. Now let's uncover data types, Java. Data type represents the type of the data that we use in program. Let's see some examples. int weight equal to 81, double height equal to 5.8, string name equal to boolean as equal to true, etc. In the above example, weight, height, name as are variables and int double string boolean are data types. Int is a number, double is a fractional digit which allows fraction values. String is a group of characters. Boolean is either true or false, only two possible values for Boolean data type. And we will try to understand these data types using example program called employee management system or EMS. We will have certain details in employee management system. First one is employee ID. Second one is employee name. We'll have email ID, and we will have employee salary. Then gender, whether the employee is married or not. Then address of the employee, then employee designation, then employee mobile number, etc. So now we have to get the data types for these fields. Employee ID will usually be a number. Name can be string, which is group of characters. Email ID will also be a string, which is a group of characters. Salary might have fractional digits, so it can be double or decimal point. And gender is a single character, M or F, so it's a character data type. married is yes or no, so it's true or false, it's a Boolean. Address is again string, then designation will also be string. The mobile number will it be number? No, because for example, int a equal to 10, int b equal to 20. A plus b is valid. But for example, we have a mobile number like it like this, or maybe just say 800, 700, and 6,000. So do we add the mobile number? No. Do we add one to the mobile number or two to the mobile number? No, we don't. We don't add or use addition operation of mobile number, mobile numbers. And some people, if you ask people to enter mobile numbers, they might enter in this format, which is a valid mobile number. But if you declare it as number, these hyphens will create errors, and some people might enter mobile number as this format. Or you can imagine any format that any person can enter their mobile number. And for this reason, we cannot declare it as number, just declare it as string. There is another reason why why we will declare mobile number as a string. Because, for example, you want to pull employees whose mobile numbers, which are ending in 00, or are ending in 01, or which are maybe starting with some area code, let's say 602, let's say 901. So you can pull up the employee details based on which location their mobile numbers are. So there are some string functions which we can use to pull these details. So for that reason, we will declare mobile number as string. Let's see some notes about Java. Note number one. In Java, we have both primitive, and primitive is essentially fundamental data type, and non-primitive or objects data. Primitive data is fundamental data types, and non-primitive data is objects data type. We will slowly uncover as we progress in this session. Note to most commonly used data and programming is string. String data type is 0 in Java, 80 to 90% we will deal only with strings. There is another note here about primitive and non-primitive data types. In Java, we can convert primitive data into objects and objects into primitives. Primitive primitives into objects is called autoboxing. Objects into primitives is called autobox. Another note on primitive data types. O3 is for every primitive data type we have an object representation, also known as wrapper class. We will cover this in the next session. So far, we've covered introduction, Java, department, or viewpoints about Java. Then we have our introduction data types. Of Java session 101. See you in the next. In the last session, we have uncovered introduction to Java, important or key points about Java, introduction to data types. We have also covered what is statically typed programming language and what is dynamically typed programming language. And we have also discussed a sample employee management system and why mobile number should be a string and not a number, and how we can pull the employee details whose mobile numbers ending in certain numbers or starting with certain area codes. And we have also discussed that we have two kinds of data types, primitive and non-primitive in Java, and converting from primitives to objects and objects to primitives. So let's discuss more about primitive data types or fundamental data types. Following are the basic fundamental data types Java. Number one, integers. And they can be from negative infinity to plus infinity. Number two are real values, which are in the form of x, y, where x and y are integers again. Then we have characters, which are ASCII code or Unicode. We'll discuss what these are in a bit. The fourth one is Boolean, which are essentially truth values, either true or false. What is ASCII code? ASCII stands for American standard for information in the image. C and C++ uses ASCII, and its range is 0 to 255, and it includes English alphabet. Unicode is universal code. It includes all languages in the universe, and Java uses Unicode, and its range is obviously more than ASCII code because it includes all the languages in the universe. Now let's see some rules or principles how we can choose the data types. Let's say I have an integer a and its value is like 1, 2, 3. I have an integer b and its value is like a big number. So let's answer some questions here. Question number 1. A and b are integers. Yes or no? Yes. Question 2. Which variable or container takes more space? A or B? B is the biggest one, so B will take more space. And which variable or container takes more time to access? A or B? Obviously, B is the bigger one. It takes more time to access. So here's the question. For example, we have 3 members in a family and they live in a 2 BHK, which is good or recommended. Say another family with again 3 members lives in 5 BHK, which is allowed or okay, but not recommended. Why? Because there is a waste of space. Similarly, based on the space constraints, data types are further divided or segregated for optimal use of space or memory. In other words, so integers is divided into 4 types. Byte, which is the smallest. If it is bigger than byte, then you go for short. If it is bigger than short, you go for int. And if it is bigger than int, you go for long. We will see how big are these data types in a while. Now, next one is real values. And they are divided into 2 categories. Smaller ones, float, and bigger ones, W. Then we have characters, and character is just single type, which is char. Then we have Boolean, again, it's single type, Boolean, either true or false. So in Java, we have full 8 primitive data types. What are those? Int, byte, short, int, long, float, double, char, Boolean. So let's see what are the wrapper class for these primitive data types. In the last session, we discussed about wrapper class. For each primitive data type, there is an equivalent wrapper class. The first primitive data type is byte, and its wrapper class is uppercase B byte. B is uppercase since it's a class, so short, its wrapper class is uppercase S short. Then int, its wrapper class is uppercase integer. Then we have long, and it's uppercase L long. Float and uppercase F double, uppercase D double. Char, uppercase C character. Then the last one, Boolean, uppercase B, Boolean. So for every data type, we need to understand some special properties. What are those? Data type name. Then what is the keyword for that data type? Then wrapper class. Then size of the data type. Then range. and what's the default value of that data type. So these are the properties which we need to understand for each of the primitive data types, which we will discuss one by one here. The first one is byte data type. So byte data type, the data type name is integers and keyword is byte. Then the wrapper class is uppercase byte. Then the size is 1 byte or 8 bits. Then range is -1 to 8 plus 1 to 7. And default value is 0. So let's try to understand how we got this range. We have 1 byte or 8 bits. So the lowest can be 0, 0, 0, 0, 0, 0, 8 zeros. And the highest can be all ones. And this is called as most significant bit. So what does that mean? For example, if the most significant bit is 0, then it's a positive value. And if the most significant bit is 1, then it's a negative value. And but the lowest or lower range number we need to take the most significant bit as 1 because the lower will have negative. So then now let's rewrite. The most significant bit is 1 and the rest of them are zeros. This is the lowest value in the range, and this is the highest value in the range, and the most significant bit for highest value should be positive, which is 0. So if I have to rewrite the highest value, then it should be 0, 1, 1, 1, 1, 1, 1, 1. Now let's calculate this. This is 2 to the power 0 into 1. This is 2 to the power 1 into 1. This is 2 to the power 2 into 1, 2 to the power 3 into 1, 2 to the power 4 into 1, 2 to the power 5 into 1, 2 to the power 6 into 1. And we need to add all of these values. Let's see here. 2 to the power 0 into 1 is 1. Then 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. So let's add until here. 10, 20, 21. It's 31. Then we have 2 to the power 5, which is 32, plus 2 to the power 6, which is 64. Let's add this, which is 6 and 9. So let's add 96 to this 31, which is 7, 12, and the most significant bit is 0, which is positive, and this is the highest value. Now let's calculate the lowest value based on this. So for most significant bit 1 and all others are 0. 1, 2, 3, 4. Yeah. So most significant is 1, which is negative. We need to do 2's complement. And 2's complement is 1's complement plus 1. So let's do the 1's complement first. We don't consider the most significant bit. So what's the 1's complement of 0? 1, 1, 1, 1, 1, 1, 1. And then we need to add 1 to this. So it's going to be 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. So we have this as the low value. So 2 to the power 0 into 0, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, all into zeros will become 0, and this is 2 to the power 7, which is 128. And what is the most significant bit? 1, which is negative, so minus 128. So this is how we derive negative 128 range for the byte. So obviously we don't need to remember how we calculate the range for this data type or for the other data types which we are going to uncover, but this is only for our understanding how the range is calculated based on how many bytes or what is the size of the data type. This is how the range is calculated. This is only for our understanding. And obviously we have some methods to derive these values. We don't need to calculate manually. Let's see how that happens. So now, to get the range, we have a function which is wrapper class dot in value and wrapper class dot max value to get the range for any data type. So let's see how this works out. For example, I have the sample Java program and I want to get the range for byte and min underscore value, and I'll also get the max underscore value. Don't worry if you don't understand this program, we will uncover as we progress. For now, just let's print the min and max values for byte data type. For compiling the code, we use javac space the Java file name, and then to execute, we use Java space test. And if you see here, got the range from this program, and minus 128 to plus 127 for byte data type. Okay, now let's move on to paste this program here, and also the result for the byte data type. Now let's see what is the next data type, which is short. And the data type name is integers. For keyword, it is short. The wrapper class, uppercase S short. Then the size is 2 bytes, and it is going to take 16 bits. And range, even I don't know, let's just calculate it. We need to just change the data type name, wrapper class name, basically short, and let's compile, and then let's execute. So the range is minus 2 plus, and default value is again 0. The next data type is integer data type, or int, and it is also integers. The keyword is int. The wrapper class is integer, uppercase I. Then the size is 4 bytes or 32 bits. And then let's calculate the range for int, which is integer. Let's compile, and then this is the range for integer, -2, positive, this much. And the default value is 0 again. Let's see the next primitive data type, which is long. And the data type name is integers, and the keyword is long, lowercase. The wrapper class name is uppercase long, uppercase L long, and the size is 8 bytes, and this is the biggest one in the integers, and it is 64 bits. Now let's calculate the range for long. Let's change this to long and this to long, and save it, compile, and then execute. This is a huge range for long. Negative this much too. Positive this much. Now let's see the next primitive data type, which is float. And data type name is real values. The keyword is float, wrapper class is uppercase F float, size is 4 bytes. Or 32 bits. Let's see the range for float. Let's execute, compile, execute, and this is the range for float. And the default value is 0.0. And let's see what's the next data type, which is double. Data type name is real values. Keyword is double. Wrapper class is uppercase double. And the size is 8 bytes or 64 bits. And let's see the range for double. Compile, execute. So this is the range for double. And the default value is 0 again. So you might be wondering, what is this E in these float and double data types? This is basically a notation to save space or take less memory to save the range in memory. Let's say, for example, you have a big number. We have 23 zeros and a 12, and so to save the number like this, it takes a large space or memory. So for that reason, it is converted into 1.2 E plus 24. This takes less number, or less space, sorry. So E represents 10 to the power of 24 into 1.2. That's how this is saved. So that's how the space is optimally utilized. Let's move on to the next data type, which is char, and the data type name is character. The keyword is char, lowercase, and wrapper class is uppercase character, uppercase C character, and it takes 2 bytes for 16 bits, and its range is from 0 to 65535, and the default value is empty string or empty character, sorry. And the next data type is Boolean, and the data type name is Boolean. The keyword is Boolean. The wrapper class is uppercase Boolean. Size is not applicable because we only have 2 possible values, so it's going to take 1 bit. And range is not applicable, but the only allowed values are either true or false. And the default value is false. With this, we have covered all the 8 primitive data types. So let's see some note points. Note 1. Int age which is integer, so will be 4 bytes. Then byte age, which will be 1 bytes. Both are allowed, but what is the recommended data types for age? So int 4 bytes is too big and it's not recommended. Whereas byte is 1 byte. So byte is recommended for age. Why? Because the age value is almost all the times between 1 to 120. And this perfectly fits in the byte range. If you recollect, the byte range is from -128 to +127. So you don't need to use int for age, you just go with the byte. That's point number one. Next point is byte b is equal to 100. Byte b is equal to -128. Byte b is equal to -129. Byte b is equal to 127. Byte b is equal to 128. So byte b is 100 and byte range is -128 to 127. This is a valid consideration or example. -128, which includes byte, so it is also valid. -129 is not valid because it ends at 128, -128. +127 is valid, falls into the range. +128 is invalid. So you have to choose the data type based on your variable requirement, whether it falls into that range or not. And note 3, we've already covered, but let's just reiterate default values. For integers, the default value is 0. For real values, the default value is 0.0. For characters, the default value is empty character. For Boolean, the default value is false. Now let's go to the next node point, node 4. Let's see what are the default data types. For integers, we have 4 primitive data types: byte, short, int, long. But what is the default data type for integers? It is int. For real values, you have float and double. Default is double. For char, you only have 1, so that's the default. For Boolean, it's again Boolean. That's the default. And let's see another note. For signed negative to negative and positive values, what are the data types available? We have byte, chart, int, long, float, and double. For unsigned, only positive, and the data types are char and boolean. We will stop here, and this is the end of the Java session 102. We'll continue in the next. What are the softwares required to run Java application? Number one is any editor like Notepad, Notepad++, Edit Plus, or Sublime Text, or VS Code, etc. Then the second one is prompt. It is available by default in every operating system. Then Java latest version. Then IDEs, integrated development. That example, Eclipse, maybe intelligent idea, or NetBeans, etc. Let's see steps create a Java application. Step one, select any editor and type Java program. Step two, write the Java program based on its rules and regulations. we're going to see what are these rules and regulations as we progress in this course. Let's see some sample program. I'll just remove this and print hello world. Every Java program execution starts from the main method and it is receiving string arguments. Void signify that it doesn't return any value. Java is a pure object-oriented programming language, and if you want to access anything present in the class, you need an object. But if any method is declared as static, without creating object, you can access it. Such types of methods we have to declare as static. When it is public, that means anyone can access this method. And the System.out.println is used to print some message. It's similar to printf in C language. Since Java is an object-oriented programming language, whatever content we are defining must be inside a class. And test is the name of the class. And this is our first Java program. So let's see what all these details one by one. Class is an object-oriented concept. Test is name of the class. Public means anyone from anywhere can access directly. Static object is not required to call. Void main doesn't return any value. Main program execution always starts from here. Args are bunch of inputs for this program. String is a data type. All these inputs are of type string. And System.out.println output printing statement Java. And what is the file name? File name is test.java. And what is its location? It's in C Java folder. Step 4, open command prompt and move to the location where we saved our Java program. Then step 5 is we have to compile the Java program by using the following command. Syntax is Java C all lowercase space file name dot Java. And in our example, the file name is test.java. So compile, we need to run Java C test.java. I'm already in the Java folder. So to compile the code, I will execute Java C test.java. Press enter, and it's compiling. Once we come back, that means there is no error in the compilation. Let's say we want to create some error just for our demonstration purpose. I will remove the semicolon in line 5 after print line hello world and try to compile it again. So it is test.java line number 5 error expected colon on System.out.println, and it also gives the location where the semicolon is required. So we can go back and fix it and try to compile it again. It is successfully compiled without any errors this time. So step 6, we have to execute the Java file by using the following command. Syntax Java and the class name. Example, Java, and our class name is test. So now let's see what is the output to after we execute. It says hello world. That's what we are trying to print in our program. This is the output. So based on what we have learned, let's take some notes. Note number 1. Java is case sensitive programming. Language that is lowercase and uppercase letters are treated different. For example, test.java, it's a valid file name. Basically, the first letter is an uppercase letter. It should start with an uppercase and rest of the letters should be lowercase. Then, for example, test.java all uppercase, it's not allowed, it's invalid. All lowercase is also not allowed, it's invalid. Mix and match is definitely not allowed, it's invalid. So always begin with an uppercase, then lowercase letters. That's the standard. Note why file name and class name are same. Is there any rule in Java? The answer is no. Just to avoid confusion and naming conflicts, we have framed this rule or best practice by worldwide Java developers. So there is no rule, no such rule like file name and the class name must be the same, but just to avoid the naming conflicts and confusion for the developers, it's framed as a rule or a best practice But let's demonstrate that this is not a rule. It still works. Say, for example, our file name is test.java and class name, I will take it as production. So let me change the class name to production. This is the program. And the file name is test.java. This is the file name, and this is the class name, and this is the program. Let's try to compile the code. Let's say we are trying to use production.java. It says file not found. There is no file like production.java. We know it. So let's change it to test.java. It's compiled now. Compile now. So let's try to, execute using Java test, which is not our. Did I not save? I saved it. That still got executed. That's it still got executed. Let's see. I think I have another test.java in the same location. Let me delete all the. I've cleared all the other files. Let's try to execute, compile code and try to execute Java test. Now it says we not find or load the main class test because the class name is changed here. So let's try to execute. Actual class name, which is production. Class name is production. So class name is production is now executed. So if you have noticed, just because the file name and class name are not same, I have faced this confusion. So that is the reason we have framed this rule, or this best practice is followed by the worldwide Java developers. The file name and class name must be same just to avoid confusion or naming conflicts. Let's move to note 3. We can clear multiple main methods in one Java program, but we can only execute one class. Say, for example, we have class A. Let's say this is A class main method. Then we have class B, and this is B class main method. Then we have class C, and say class C main method. Let's save this, and let me execute this. Let me compile this test.java file. It's compiled. So let me execute class A. The A class main method is called. Let me execute class B. B class main method is executed. Let's execute class C, and C class main method is executed. But we cannot execute more than one class at a time. For example, A comma B comma C. Could not find or load main class A comma B comma C. Let's save this program here, and then the output of this program. And now let's move on. Note 4. Public and static are modifiers in Java, and we can take these modifiers in any order in the program without any issues. what does that mean? Let's change back the program to just one class. And so what does that mean is we can change static to here and public to the second static public void main. This will work without any issues. Let's compile the program. It is successfully compiled, and then let's execute the program. It is successfully executed without any issues. Let's move on. To node 5. We cannot interchange void at main because the return type always comes first, then the method name. So we cannot interchange these two like main void. This is not allowed. Node number 6, we can replace main with any name. There is no problem. But during execution, JVM, which is Java Virtual Machine. We will uncover JVM as we progress in this course. We'll always search for main method. If it's not found, we will get error. What does that mean? So let's say instead of main, I name it as D and try to compile this code. The compilation is successful, no errors at all. But let's try to execute it. And then it will say main method not found in the class test. Please define the main method as public static void main string arguments, or JavaFX application class must extend JavaFX.application.application, which essentially says that you need a main method in the program. So we don't have any compilation errors, but during execution, it fails. End of Java session 103. I'll see you next. In the last session, we have uncovered software required for Java programming, steps to execute Java program, and various conclusions related to Java program based on what we have learned so far. We'll see setting the path for Java. So path should be in C program files, Java, then JDK commits mine.o.4 slash bin. This is the path for the Java. We can set the path for command prompt in two ways. One is temporary path setting. Two is permanent path setting. So to set the temporary path setting, you will go in the command prompt and execute this path equal to and give the path like this. Then the temporary path setting is completed. This temporary path setting is only valid for that command prompt section. Once you close this terminal, and next time you have to set it again to be able to execute Java programs. It's temporary. We're setting the permanent path. You need to add the lim path to the environment variables in the path. This will permanent and it works every time in command prompt when you execute Java programs. I've already set the path permanently. That's the reason I'm able to execute the Java programs. Next, we will see Java editions. What are all the editions available under Java? Java mainly divided or segregated into three editions. One is standard edition. Two is enterprise edition. Then three is micro edition. Let's take a look at one by one. Number one, standard edition. It is also called as J2SE, Java to Standard Edition, also known as Core Java. The next one, it only covers fundamentals. It is used to create standard or standalone applications. For example, maybe calculator application or paint application or any desktop application, etc. The second one is enterprise edition. It is also called as J2EE, Java to Enterprise Edition, also known as Advanced Java, and it is used in distributed applications, web applications. It is used in client server architecture. Examples like maybe Gmail application or online ticket reservation, etc. Then the third one is micro edition. It is also called as J2ME, used for microprogramming, and it is made for mobile-based applications. This is not up to the mark because Android and iOS are dominant in mobile applications. So Java is mostly core and advanced Java, which is essentially used for standalone applications, and Enterprise Edition is used by large organizations to create enterprise grade applications. Mobile applications, it's not that much used. Micro Edition was created, but it's not that popular. Now let's see Java versions. Java has so many versions. The first version was 1.1, created in 1996. Then we have Java 1.2, then we have Java 1.3, then we have Java 1.4, then we have Java 1.5, then we have Java 1.6, then we have Java 1.7. Then from 1.8, they started calling it as, and from then we have Java 9, then we have Java 10, then we have Java 11, then we have Java 12, then we have Java 13, then we have Java 14, then we have Java 15, then we have Java 16, then we have Java 17, then we have Java 18, then we have Java 19, then we have Java 20, which was introduced in March of 2023. Then we have Java 21, which was introduced in September of 2023. Then we have Java 22, which was introduced in March of 2024. Then we have Java 23, which was introduced in September 24. Then we have Java 24, which was introduced in March of 2025. Then we have Java 25, introduced in September 2025. Then we have Java 26, which was just released in March 2026. Regardless of what version or what version you might be on, it's pretty much standard. Only new features will be added in each release, which you will be exploring on your own based on the need. So let's uncover important Java core Java are applications of core Java. We can create desktop applications. We can create web-based applications. We can create enterprise applications. We can create mobile-based applications. Embedded systems, etc. Now let's see how Java program internally works. We have three components in Java. The first one is JDK, and the second one is JRE. The third one is JVM. Let's see what these are. JDK stands for Java Development Kit. JRE stands for Java Runtime Environment. Then JVM stands for Java Virtual Machine. So when we install Java, we have these components. We have JDK, and inside JDK, we have some libraries, dependencies, whatever it is. We have also JRE. And inside JRE, we have libraries, dependencies, and other stuff. And it also has JVM. So these are the three components which we will have inside JDK when we install Java. So let's see one by one what these components are responsible for. So if you are a developer and you are developing Java applications, you must have JDK. And if you are just a client, uh, then you just need a JRE to run the Java applications. So JRE will have its JVM plus some libraries. Then JDK will have JRE plus some tools which are needed for developing Java applications. Now, you have already learned that Java language is platform independent. Now let's look at Java software. If it is platform independent, is it platform independent or dependent? It's dependent. The Java software will change for Windows, for Linux, for Mac OS. So it changes based on what operating systems you are using. So it's not platform independent, it's platform dependent. Likewise, JDK is also platform dependent. It changes for each OS. JRE is also platform dependent. And likewise, JVM is also platform dependent. All these changes based on what platform or OS it should be running. Only Java language is platform independent. Once the bytecode is generated, once we compile, say we wrote s.java and then we compile, then bytecode equivalent is generated, something like test.class. This is platform independent. It can run any operating system or any platform, but software itself is not independent. It depends on what OS you are using. This is the end of Java session 104. In the last session, we have uncovered path setting, Java editions, Java versions, important core Java applications, components of Java like JDK, JRE, JVM. Let's begin session 105. In this session, we will uncover keywords in Java, identifiers, comments, and naming conventions. Keywords are the words which are already defined in Java library are called predefined words or reserved words, or otherwise also called as keywords. In Java, we have total 53 keywords. There are some unused keywords like go to and constant. These are used internally. And there are reserved literals like true, false, null. Except these 5 keywords, all remaining are pure keywords in Java. Class is a keyword, static is a keyword, public is a keyword, void is a keyword. So class, public, static, void, and say int, byte, short, long, char, boolean, float, double, etc. All these are keywords. All these keywords are written in lowercase letters. All the keywords in Java are written in lowercase letters. And remember, Java is a case sensitive programming language. We will explore these keywords as we progress. Let's look at identifiers. What is the major difference between keywords and identifiers? So keywords are system generated and identifiers are developer or maybe say user generated. That's the major difference between identifiers and keywords. Identifiers are used for identification purpose. It can be variable name. It can be a method name. It can be a class name. It can be an enumeration name. It can be an interface name. It can be a package name. So for identifiers, there are some set of rules we have to follow. For example, let's begin with rule number 1. Rule number 1, is the only allowed characters are lowercase letters A to Z, uppercase A to Z. Then you can use underscore, and you can use $sign, and you can use numbers 0 to 9. You cannot use any other symbols apart from this. Rule number 2, it should not start with a digit. For example, ABC 103. This is valid. Underscore ABC. This is also valid. Let's say $ABC. This is also valid. Let's say uppercase ABC. This is also valid. But let's say 8ABC. This is invalid. It cannot start with a digit. Also remember, dollar is used to represent inner classes. We will see what are those as we progress, but remember it's used in naming the inner classes. Now next rule, rule number 3, is it cannot be a keyword. Cannot be a keyword here. So you cannot use keywords and names or identifiers. Rule number 4, remember Java is case sensitive programming language. Hence, identifiers are also case sensitive. For example, John. Or John, or John, or John. These are all treated completely as different. Now, rule number 5. Faces are not allowed in the middle. Like, for example, student, mother, name. This is invalid. Not have spaces in between. So what we can do, we can just use maybe underscores. Student underscore, mother underscore, name. This is valid. If you don't want to use underscore, you can use something called camel case. Like the first letter is lower, first letter in the first word is lower, and all the other words, the first letter will be uppercase, like student. This is something called camel case, and this is actually lower camel case. We will see what that means as we progress. Then rule number 6 is if we want, we can take predefined class names as identifiers. What does that mean? For example, system is predefined class name and string is predefined but can be used as name of the identifiers. So int string is equal to 10. I can definitely use it. This is definitely valid. And Boolean uppercase system is equal to false. This is also allowed. I can use it. It's valid. So these are basic thumb rules. We covered. Now let's move on to comments in Java. Comments, what are comments? Comment is a description, maybe about some code or code snippet. It improves readability. Of the program. And comments are automatically ignored while the program is executed. There are three types of comments in Java. Number one, single line comments. Number two, multi-line comments. Number three, multi-page or documentation comments. Well, let's see how single line comments looks like. For example, you have these are lines of code that support in any program. So, for example, I need to have a single line comment. Let's say This is a single line comment in the code, the program. You have to begin with two forward slashes. And whatever you write right after two forward slashes, that's treated as a single line comment, and the compiler ignores these lines when the program is executed. So now let's see multi-line comments. For multi-line comments, say for example, we have some program with so many lines, and I want to ignore maybe line 200 to line 01, 202, 203, 04. I want to ignore all these lines. So how do I ignore them? You have to start with a forward slash, then a star, and then you have to end with a star and a forward slash. So whatever is in between these two will be ignored by the compiler when the program is executed. This is how you will declare the multi-line comments. Now let's look at the third type of comments, multi-page or documentation comments. These exactly start with the same thing, except that you will have star on each line. So these are multi-page comments. So these can extend into multiple pages. So that's all about comments. We will see as we progress. If you just want to see one example, I'll write one with single line comment here. This is a single line comment. And you can see the color, it's changed, and it will be ignored by the compiler, and only the other lines of code is executed during the compilation. Now let's look at Java naming conventions. We have definitely certain rules. Rule number one is variable names. For variable names, starts with lowercase letters, and if contains more than one word, every word will or should start with uppercase character or letter. Examples, say for example, int ABC is equal to 10. Double student attendance percentage is equal to 90.56. And some people might just simply say percentage as just PER 90.46. This is okay, but not recommended. Worldwide, Java developers will prefer this kind of names for the variables, which clearly says what this variable is about. Student attendance percentage. This PER might be allowed, but it's not recommended because it doesn't make any sense or doesn't signify or doesn't say anything about that particular variable. You have to be really creative about the names of the variables, or for that matter, anything should be readable, and that's how it's preferred. Rule number 2 about method names. Method name starts with lowercase letter, and if it contains more than one word, every word starting character should be uppercase. Example, void main or void parse int, etc. Let's move on. Rule number 3. Class names for interface names. Starts with an uppercase letter, and next word starts with uppercase letter as well, and so on and so forth. For example, demo, test, or maybe student, then demo, or maybe array, index, out of bounds, exception. Every word has an uppercase letter, etc. And rule number 4, constants. All constant names must be in uppercase letters. For example, min underscore value or max underscore value. Rule 5, package names. For package names, all package names must be in lowercase letters only. For example, Java package, Arm is a package, Lang is a package, etc. I'll stop here. This is an Java session 105. See you in the next. So far, we have covered introduction to Java, Java editions, path setting, steps to execute Java program, Java keywords, Java identifiers, Java comments, Java naming conventions, and data types in Java. Let's uncover literals in Java. Let's say int x equal to 10. So what is int here? It's a data type and it's also a keyword. X is a variable for identifier equal to is an operator. We will uncover it as we progress. And semicolon is also an operator. Also known as terminator. And what is this 10? 10 is called as literal. Any constant value which can be assigned to the variable is called as literal. So in Java, the following are the different type of literals. Number one, integer literals. Number two, floating point literals. Number three, character literals. Number four, Boolean literals. Number five, string literals. Let's try to uncover each one of these. Integer literals. So what are the data types present in integer? Byte, short, int, long. Byte
There is no explicit way to declare star. Also, there is no explicit way to declare int. We can declare int as decimal, octal, hexadecimal, and binary. Long must be suffixed with lowercase l or uppercase L. Let's go for an example. Public static void main string arguments. Say, for example, int a is equal to 10. Then int b is equal to 0, 1, 0. If it is starting with 0, it is binary. Int c is equal to 0x. Let me put some notes here. Binary should be prefixed with 0b or 0 uppercase b. Then octal should be prefixed with 0. Hexadecimal should be prefixed with 0 lowercase x or 0 uppercase x. Decimal, there is no representation. So int a equal to 10, int b equal to 0, 1, 0, then this is a binary. Int c equal to 0x, this is hexadecimal, and int d equal to 0, b, 1, 0, which is binary. Int b 0, 1, 0 is octal. Int d 0, b 1, 0 is binary. Now let's system out println a, then print b, then print c, then print d. The output for line 9a, it will be just 10 as is. The output for b 0, 1, 0, it is octal. When I say octal, how do we calculate it? Let's get the pen. well, this is octal, so the first prefix 0 signifies octal and the number is 10. Octal base is 8. So 8 power 0 into 0, then 8 power 1 into 1. This is 0, this is 8, the total is 8. So println B, the answer is 8, then print C is hexadecimal, and I forgot to mention the number, so let's print hexadecimal 10. So the base for hexadecimal is 16 and 10, 16 to the power 0 into 0, 16 to the power 1 into 1. 16 to the power 0 is 0, and 16 to the power 1 is 1. If we add it, then the answer is 16. Print C should give us 16. Then D0B is a binary, and 10, the base for binary is the base for binary is 2, 2 power 0 into 0, 2 power 1 into 1. This is 0, this is 2. If you add it, it's 2, then the answer is 2 for print LND. It's gonna be 2. Let's save this program and try to execute it. Compile. Code is compiled and executed. Let's check the answers. The print A is 10, print B is 8, print C is 16, print D is 2. Now let's take one sample for long. For example, long mobile number is equal to 800, 700, 800, 900, 600, or 6,000. And try to print mobile. And remember for long, we need to suffix the number with lowercase l or uppercase L, which is lowercase L here. And we can also try uppercase L long balance equal to, let's put some good dollar amount without any symbols, obviously, and uppercase L, save this program, and let's compile and run this. Okay, I think I have taken a little too long. Really? Did I take too long? Okay, this is compiled now. Let's execute it. Okay, I didn't print the balance. Didn't print the balance. Compile again. Execute. Let's save this example and also the output of this example. So we have got the exact same number, and when we define long, we need to use lowercase or uppercase L. Let's move on. The next literals we have is floating point literal. Floating point literals float and double. Float should be suffixed with lowercase f or uppercase F. Double should be suffixed with lowercase d or uppercase d, or no suffix is also fine for double. Okay, let's look at float examples like float a is equal to 95.5 and lowercase f. And let's define another float, say b 95.6 uppercase F this time. And then let's define double C is equal to 12.34 without anything. And let's define another double D 12.34 maybe this time we'll put lowercase d, then double E, and 12.34 uppercase D. And let's try to print every variable. So A, B, then C, D, then E. Let's try to execute, compile, then execute. So we have printed all the variables without any issue, regardless of which uh, format we used, lowercase f, uppercase f, lowercase d, uppercase d, and no d at all is also fine. Let's put this in the notes. Let's move on to the next type of literals, which is character literals. Anything which is enclosed in between single quotes are called as character literals. Single quotes like H as in hotel, then escape characters like new line, then ASCII code we have covered in previous sessions. The range is 0 to 255 directly. Then Unicode, the range is 0 to 65535. We have covered earlier in the hexadecimal format, like XXXX. So note these values. For example, ASCII value of lowercase a is 97, and ASCII value of uppercase A is 65. Then ASCII value of 0 is 48. And ASCII value to convert difference or to convert from lowercase a to uppercase A, you need to add plus 32. And if you want to convert from uppercase A to lowercase a, you need to add -32. So based on this, let's see a simple example on character literals. Let's say char ch1 is just a simple p. Then let's see char ch2 is a new line, and char 3 is 65, char 4 is 97, char ch5 is 48, and char ch6 is U0041. Let's try to print ch1, ch2, ch3, ch4, ch5. Like I was mentioning, it will just print P, and this new line is nothing but new line. It will print new line. Then 65 is uppercase A. Then ch4 97 is lowercase a. Then ch5 is 48 is 0. And let me print ch6, which is Unicode in hexadecimal format, which is, in other words, 1 into 16 to the power 0, then plus 4 into 16 to the power 1 plus whatever into 0, then whatever into 0 is equal to anything to the power 0 is 1 into 1, which is 1 plus 16 into 4, 64, that is 65. Now, what is the 65 equivalent? It is going to be uppercase A again. Let's try to execute this program, compile and run. P, the new line, uppercase A, lowercase a 0, and then an uppercase A. Now let's move on to the next type of literals, which is Boolean literals. The only allowed values for Boolean literals are either true or false. That's all. So let's take a simple sample Boolean. B1 is true. Boolean B2 is false. And let's try to print B1 and B2. It is simple, straightforward, true or false. Compile, execute. That's a simple example for Boolean literals. The last type of literals in Java, string literals. If we are providing any data within double quotes, for characters, single quotes, for strings, it is double quotes, then it is treated as string literals in Java. Let's take a simple example for string. Say string S1 is double quotes A, B, C, D, E, A, B, C, D, E, F. Then let's define another string S2. Let's say A, B, C, 1, 2, 3. That is also allowed. Then let's define another string S3. This time let's take some symbols inside this string. That is also allowed. Let's print S4. Let's take all the numbers this time. That is also allowed. And let's print all S1, S2, S3, S4. Oh my God. I was just editing in the notes file itself. Okay, let's take the Boolean sample back from here and put it back and take this string sample and put it here, save it, try to compile it and execute it. So it's able to print everything here. So these are called string literals. We'll stop here. This is the end of Java session 106.
In this session, we will uncover typecasting, or it's also known as type conversion. The process of converting one data type into another data type is called as typecasting or type converting or type conversion. Let's say we have student percentage and it's 97.14%. Then we want to just show it as 98%. Or let's look at maybe gas price is $4.67 per gallon. So we just want to round it up and show it as $5. Or just say credit card bill, say $6,700. We wanted to show it as 67 with a decimal point one. So $6,700.0, $6,700.0. So in this case, we go for typecasting. There are two types of typecasting in Java. Number one, implicit typecasting or automatic typecasting. Second one is explicit or manual typecasting. Let's look at implicit typecasting first. Implicit casting automatically lower data type will be converted into higher data type. Automatic, it's called as automatic casting or implicit casting or widening. It's also called as widening casting. And there is no loss of information. We will see what this means in a moment. So to remember from previous sessions, we have byte, which is 1 byte. Then we have short, which is 2 bytes. Then we have int, which is 4 bytes. Then we have long, which is 8 bytes. Then we have float, which is 4 bytes. And then we have double, which is 8 bytes. So the implicit typecasting follows this arrow direction. For example, byte can be converted to short, it can be converted into int, it can be converted to long, float, double. Likewise, short can be converted to int, long, float, double. And int can be converted to long, float, double. And we also have char, which can be converted to int. Let's see some examples so we understand this concept clearly. So let's say I have a byte b is equal to 10 and int I, and if I try to assign b to I, then we're trying to convert the 1 byte into int 4 bytes. So this is implicit casting, so it will be automatically converted. Let's try to print system.out.println print b, and then let's print I as well. Let's see the Java C test.java. Code is compiled Java space test. So it is able to print both 10, both B and I. Example. Let's take another example. For example, char ch is a, and we have int I, and then we try to assign char ch to I, which is char 2 bytes converted to int 4 bytes. Now let's try to print char ch and int I. Compile the code and then execute the code. Java space test. So if you notice, you see the first println ch is printing the character itself. When we print I, it is printing the ASCII equivalent value, which is 97, which we have discussed in the previous sessions, into the console. I'll put the result in the notes here. Now you have seen long, which is 8 bytes, can be converted to float 4 bytes. So let's see some examples related to that. For example, long L is equal to 10 and float F. Then let's try to assign L to F, which is converting from long to float. Let's try to print L and F and see if it is working. Compile the code, then execute the code. So we have successfully converted long example into float. This is 3, this is 2, this is 1. Let's move on and see one more example before we see the explicit typecasting. let's say I have a boolean b is equal to false, then int I is declared and try to assign b to I. This is not allowed. Let's try to compile this code and execute it to see what will be the error. So when we try to compile something which is not allowed, it says incompatible types boolean cannot be converted to int, and it also showed the location where the error occurred. So we cannot convert boolean into int. Okay, I'll paste the error here. Now let's explore explicit casting. This is also otherwise known as manual casting. The process of converting data from higher data type into lower data type is called as explicit casting. To perform this operation, the formula we need to use is something like P space A is equal to Q of B. So what are these actually mean? Let's say where B is variable of type higher than P, and where bracket is cast operator, and Q must either be the same aim as P or lower than P. Let's see some examples so we get clarity. Let's say int I is equal to 10. And if you want to convert it into byte, you need to declare byte p is equal to byte of I. This is how convert int into byte. Let's see some examples. Short s is equal to 10 and byte p, and try to assign b with short s. Then we have to explicitly mention byte and then give the variable name s and try to print System.out.println of short s and also print B. Compile, execute. So we are able to successfully compile and execute the conversion from short to byte. Let's see another example. For example, int I is equal to 100 and try to convert it into byte. So byte B byte of I, and let's try to print I and B. And when we are converting from int to byte, we have to make sure the value is in the range. For byte, it is -128 to +127. So the value 100 is in the range of bytes, so we'll not see any issues. Execute. So we will get the result as expected. Now let's try to do another conversion. Like for example, int a is 100, and then char b, and then b is equal to char of I, or a in this case, and then print a and print b. So print b should get the ASCII equivalent of 100. Let's see. Execute, and then compile and execute. So this is how int to char conversion works. Example 3. We will see one more example before we finish explicit casting, which is example 4. For example, I have double a equal to maybe 12.345, and then int b. Then I want to convert int double a to int b. So I'll do b is equal to int of a and try to print a and b. Let's try to compile and then execute. We have successfully converted double into an integer, and the result will look something like this. So we have covered typecasting, implicit typecasting, also known as automatic typecasting, also known as widening casting. We have covered explicit typecasting, also known as manual casting or narrowing casting. We'll stop here and see you in the next. In this session, we will try to uncover input and output statements in Java, or also known as IO statements. There are two types of data in Java, or in general in any programming language. One is static data, which is essentially fixed. Second is dynamic data, which keeps on changing. So as part of programmers' requirement, sometimes we need to handle dynamic data to perform some basic arithmetic operations, and or maybe logical operations. To perform these operations in Java, we have two types of statements available. Number one, input statements. Number two, output statements. Input statements, these are used to read dynamic data from the user. Buffer, reader, console, scanner class. We'll see what these are step by step. And we have output statements. There are three types of output statements in Java. Number one, system out print. Number two, system out print ln. Number three, system out printf. Let's begin with system out print. It is used to print in given objects content on console and row remains same line. Let's see some examples. Print Amy. Print Andy. Print Mike. I'll just add spaces after Amy and Annie so that you will understand why I added that. That is for better readability. Let's compile, execute. So the names will be printed in the same line. For that reason, I've added spaces. Let's say, for example, I need to print these names in a new line. I will just add new line character right after the first two names. Let's compile this. And execute. Program now prints each name in new line. This is about print, System.out.println. Let's move on to the next output statement, println. It is used to print given objects output content on the console, and the control will transfer to the next line automatically. Let's see an example, print ln. Let's print a print ln EBB print line CCC and try to compile. Execute. The output is printed in new line for the each entry. Let's look at printf, the third output statement. It is used to print the content in C language format. Let's take some examples. If they're printf and I have to print an integer, I'll use slash and %d and give the integer value. Then I have to print a floating point. It's slash n %f, then say 45.678. then slash n percent C to print a character, then slash n S to print string. Let's compile. I have not changed the println statement and all the sentences. Control S and compile it again. I need to compile it. It is giving previous one. Now execute it. That's how the printf statement gives the output. Let's see some more examples for printf. For example, I have character and character T, and if I use uppercase C, then it will be printed in uppercase. If I use uppercase character, if I use lowercase s, it will print lowercase mic, and if I use uppercase mic, then it will print in uppercase string format. And let's say if I have Boolean b lowercase and do true, and then use uppercase b, print the value, it will be printed in uppercase. Let's try to run this program. Compile, execute. Let's see one more example for integers. If I do lowercase %d prints an integer, if I do lowercase o and try to print, then it will print the octal. If I do lowercase x and print 10, it will print hexadecimal lowercase. If I print uppercase x, then it will print uppercase hexadecimal equivalent of ASCII. And let's try to run this program. This is the output. Oh, let's see one last example for floating point number. Say, for example, I have 10.1, 2, 3, 4, 5, 6, 7, 8. And I will repeat it like 5 more times. So when you print floating point number, it will print 6 digits after the decimal point. So here the 7th digit is 7 and it's more than 5, then this will be converted to 7, or it will be 7. And if you want to print 1 position after decimal point, then you will use 0.1. If you want 2, then you will use 0.2. If you want 3, you will use 0.3. If you want 4, you will use 0.4. If you use 0.5, you use 0.5. For 0.6, it's default 0.6. You don't need to mention. Let's compile. Execute. So the first one is printing 6 digits, and then the second one, 1, 2, 3, 4, 5, and the 5 one, if you see the 6 is more than 5, so this is incremented by 1 and printed. Let's summarize the printf. Personality is integer value and decimal. Then percentile O is integer value in octal. Then percentile X is an integer value in hexadecimal. Then percentile uppercase X is hexadecimal uppercase. Then we have percentile C to print error value. Then we have uppercase percentile C or percent C, the carry value in uppercase. Then we have lowercase s to print string value, and uppercase S to print string value in uppercase. Then we have B Boolean value, and we have uppercase B to print Boolean value and uppercase. Stop here. And continue in the next. In this session, we will try to uncover the input statements. The first input statement that we have is buffer reader class. Buffer reader class is used to read dynamic data from the user. And it sets the data in the form of either character or string. So not integer, not double, or not any other data type. It only accepts either char or string. This is a predefined class present in java.io package. So if we want to use this class, we must import this package into our program. There may be chance of exceptions, hence we must handle the exceptions when we use this class. So what is the syntax for the buffer reader class? It is buffer reader br. Br is a variable name, is equal to new buffered reader of new input stream reader of system.in. This is the syntax to use the buffer reader class. So let's see what each of these mean. System.in from the input device, we are reading the data. What is the input stream reader? This is a way of reading dynamic data from the user. And what is the buffer reader? It will store the data in a buffer. Why? Because whatever input data we are reading, it will not submit the data to Java directly. When the user submits data, it will, or it may take some time to read the data one by one. And finally, after reading, it will submit it to Java. After collecting the total data, then it will submit. For this reason, it uses the buffer concept. So there are two functions in the buffer reader. The first one is br.read. This reads single character in the form of ASCII code. And then we have buffer read line, which is used to read single line in the form of string. So if you want to read either character or string, you have two functions. One is read, another is read line, and these two functions are present in the buffer reader class, which is present in the java.io package. And if you want to use this class, you have to import this java.io package in your program. So let's see some example program. So if we have to use buffer reader, then we have to import java.io.star. And let's see. So buffered reader br is equal to new buffered reader of new input stream reader of system.in. Then let's print some line for the user to input the data. Let's use print System.out.println enter any character. And then to read the data from the user, int data equal to br.read is for reading the character. And then let's print the output to the user. Print ln. And let's say the character entered is comma or plus data. So let's compile this program. Okay, there is a compilation error. It says throws exception. I have told we have to handle the exceptions when we use this class, so we have to declare throws exception. And that's the error. Let's save this and try to compile it again. It's compiled successfully. And let us execute. Enter any character. Say for example, I entered A, and the character entered is 97 in the ASCII format. So let's get the actual character which we have entered. For example, entered in ASCII code. 97 is the equivalent ASCII code for A. So let's do entered. Let's do entered in character format itself. Remember, we were doing typecasting, so we have to do the typecasting here. To do the typecasting for character, we just put the char in front of the variable name, and let's compile and then execute. Let's enter A again. So the character entered in ASCII format, ASCII code format is 97. The character entered in character format is A. Let's save this example in the notes. And also get the cancel this. Okay. Let's move on. Let's see some example for reading strings. So what we have to do, we have to get the string. For example, let's enter your name. And here, when you're reading the data, declare it as string, and maybe I'll change the variable name to read. And then we have to use br.readLine. Then I'll just remove one System.out.println line. Let's say hi, then space, then name. Let's try to execute this. Compile. I have used lowercase s here. Should be string, uppercase. Compile. And execute. Enter your name, John. Hi, John. For example, I enter first name space last name. That's still okay. It will give the right output. Save this example. Also this output. So this is first input statement, which is buffer reader class. And the second one, or the next one, is console class. This is the second type of input statements that are available. So console class, it is used to read dynamic data from the user. And it accepts the data in the form of strings like username and passwords. And it is also present in the java.io package. So for us to be able to use this class, we must import the java.io package. So let's look at the syntax. How does the syntax look like? Console C is equal to system dot console and C dot read line of string and if you have to read the passwords, read password of string. Let's see some example for console class. We must import java.io and then console C is equal to system dot console and then string name is equal to C dot read line. And we don't need separate System.out.println to ask the user or give some string to the user like enter username. It will directly print it for the user and take the input from the user. And for password, let's define a character array, which we will uncover as we progress. But for now, password just use the character array. And for reading C dot read line, read password. And then you can give the user some string message like enter password. And then we can system out the username and password. Let's do System.out.println username is plus name. And then let's do the password. Obviously, we are not printing the password. Let's see what happens when we do this. Let's compile. Code is compiled and execute. For example, I'm giving the username as admin and I give some password here. It is not showing up the password which I'm typing. Obviously, we can use maybe like star 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 or dot 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 dot. Maybe in future we will explore that. For now, we'll stick to just this empty string. You will not be able to see it in the console. But here the password is printing something. You don't need to think that I gave this as the password. It is the actual array name. It just gives the array name. It doesn't give the actual password. So Let's save this program in our notes. Also save the result. I'll put some notes here. Is not actual password. It's just the password array name. Okay, the last input statement that we have, or input class we have, is scanner class. It is also used to read dynamic data from the user. It is used to read all types of data. It is the most commonly used input reading method. This is the most commonly used uh, reading class or method. It is present in the java.util package. And we must import this package to use this scanner class to work in your program. And it is present in three forms. The first one is, let's see the syntax. First one is scanner SE is equal to new scanner of string format. The second one is scanner SE new scanner. You can read it from file. And the third one is scanner SE new scanner, and you can read it from System.in input device. We will explore each one of these as we progress, and I'll stop here. This is end of Java session 109. In the last session, we have uncovered input statements, buffered class, and then control class, and then the scanner class. We will continue to uncover scanner class, and let's begin with the methods available in scanner class. Let's look at the methods one by one. First one is se dot next byte, which is used to read byte. Then we have se dot next short is used to read short. Then we have se dot next int. Then we have se dot next long. which is used to read long. Then we have sc dot next float, uppercase F float. Then we have sc dot next double. Then we have sc dot next boolean. Then we have sc dot next, which is used to read single word. And then we have sc dot next line, which is used to read multi word or single line. And note that there is no explicit method to read character data. Also note that there is another method called dot has next. This will return true if next element is present, else it returns false. Let's see some examples so we get more clarity on what these methods are. As we have discussed earlier, we have to use java.util package to use the scanner class. So let's define a string variable called data, and I will write a sentence something like 2 coffees and 3 straight teas cost 40 point maybe $5-6, which is, let's say, Boolean true. And let me read using scanner class. Scanner se is equal to new scanner of data. Try to print each word. System.out.println and sc dot next. The first one is a number, so I'll use next int. Then the next one is a word, I'll use sc dot next. Then I'll use another next for and, then I'll use next int for 3. Then I'll use next for t's, next for cost. Then I'll use next float or double for 40.56. Then I'll use next for dollars. Then I'll use next for next boolean for true. This is just to demonstrate how scanner class works. Let me compile this program, then execute this program, and I've got all the values for this program in the output. Let me paste this output notes. So Now let's try to see what happens if I add another, say for example, text int. In this case, there is no integer after true, but let's see what error we will face. It's compiled, then we run it. So it is able to print all the values until true, and it throws an exception saying no such element uh, when we try to read the number which is not available. We'll paste the error here so that we have it in our notes. So now if we have to go with this approach, we need to keep track of how many words or how many strings or numbers are available and then print accordingly. To avoid this issue, what we can do is we can use a while loop and see sc dot has next is true, then print that to the console. System.out.println and used sc dot next, which is used for both words, strings, and integers. So we are good with that. So let's try to compile and run this program. So we have got those many words that are there. So this while loop is used to just avoid the exception that we have faced in the earlier example. I'll paste the result here. So in the scanner, we have now tried the scanner string. Now let's explore how to read it from a file. So I have one input text file and I have some strings in this file. So let's read the data from the input file. So, and this input file will be present in the current working directory where we're executing the code. And below is the content of the input file. So now let's remove this string. We don't need to read it from string this time. We just need to read it from the file, say input 111.txt.txt. For some reason, I saved it this way, but that's fine. And try to compile the code and execute it. I have compiled the code. I executed. So if you see, we just got the name of the file, but not the contents of the file. So we have to fix that. How do we do that? So here we have to use new file of input file name, then we can paste this one, then compile this time. To be able to use the file, I need to import java.io package. Let's compile it again. And execute. And now we got the contents of the file which we have saved. And there is one problem here. If you see in the input file, line number 2, the name is John Doe, John space Doe. But when we executed it, we got in separate lines. So whenever we use next, it is reading it word by word. So to avoid this issue, we can just use next line. So now it will read line by line. Let's compile this one and execute. This time we got John Doe in the same line. So we can use next line instead of next as required. Now let's try to see the third type, which is scanner, SC new scanner, and get the output, get the input from the system.in. And we don't need IO this time. We are not reading it for a file. So public static void scanner SC new scanner system.in, and then we will system out something like System.out.println. Maybe you take some two integer values and add those two values and give the output for the user. Essentially like a calculator. And then it's going to be int a and sc dot next int. Then we'll get another value, say enter p value, and int p is, and we don't need this while which we used in the earlier program, so we'll reuse the print out print line, and this time we'll just print a plus b. Save this program and compile, execute. enter A, maybe 5, then B, 6, then the output is 11. Let me save this program and also the output. And this time, let's see a string example. For example, scanner sc new scanner system.in System.out.println, enter your name. And instead of end, we take string name, and instead of next int, we'll just take next and remove this and say, maybe we'll say I plus name. Let's compile this and execute. I'll put the name as John. I'll get the response as hi John. Let me try to give my full name like John Doe, and it still gives John. So to avoid this, what we can do is just read next line. Try to save it, compile the code, execute the code, and enter name John Doe, and I'll get the entire name. So you can read the next word or you can read next line using next line method. I will stop here. End of Java session 110. See you in the next. In this session, we will try to uncover operators in Java. So what is an operator? An operator is a special symbol in Java which is used to perform operations on operands. So what are those symbols? Like plus, minus, dollar, division, semi. Let's take one simple example. A plus B. In this example, the symbols we have is plus, then what is the operation? It's an add. Then what are the operands? A and B. Let's take another example. Like for example, if I have A plus B minus 5 into 2. So here, let's write down symbols we have in this operation. Plus, then we have minus, then we have multiply. And what are the operations? Plus is for addition, then minus is for subtraction, then star is for multiplication. And what are the operands? We have here A, comma B, comma 5, comma 10, 2. So these operators can be categorized into two types. Category 1 based on number of operands, all the operators are divided into 3 types. Number 1, unary operations or unary operators. Number 2 is binary operators. Number 3 is ternary operators. The other category is category 2. It is based on type of operations. All the operators are divided into the following. So number 1, arithmetic operation or arithmetic operators. Number 2, we have assignment operators. Number 3, we have string concatenation operator. Number 4, we have relational operator. Number 5, we have equality operator. Number 6, we have logical operator. Number 7, we have increment or decrement operator. Number 8, we have conditional operator. Number 9, we have bitwise operator. Number 10, we have special operator. Number 1, arithmetic operators. Let's explore first. If we want to perform basic arithmetic operations on two operands like plus for addition, minus for subtraction, into for multiplication, then division for division, then percentile for modular division. We will explore what these in one sample program. I will also remove this import, we don't need it. So let's say system dot out dot println now 5 plus 2, and let me do 5 minus 2, then let me do 5 into 2, then let me use division operation, then let me use the percentile modulo operation. So 5 plus 2, it should print as 7 here. 5 minus 2, it should print at 3 here. 5 into 2, it should print at 10 here. 5 divided by 2, it should just print the integer of the division, not 2.5, just 2. Then modular division will print the remainder or remainder. So let's try to execute this program, compile, and execute. So we have 7, 3, 10, 2, 1. This is exactly what we expected. Then, for example, we don't want just the integer of the division. We need the actual value, for example, 2.5 in this case. So how do we do that? So what we can do is we can use five dot zero, then it will give us 2.5. Or we can try 5 divided by 2.0. That will also give us 2.5. Or we can do both 5.0 and 2.0. That will also will work. Let's save this and compile and execute. The first one, we got the integer division value, and the rest of them we got the exact floating point, which is 2.5. Now let's look at the second type of operators, which is assignment operators. Equal to is used for assigning values. Equal to is called as assignment operators in Java. There are three types in the assignment operators. First one is simple assignment. The second one is compound assignment. The third one is chained assignment. So let's say, for example, A equal to 10 and B equal to 20 and C equal to A plus B. And then let's say 6 equal to D. A equal to 10 is a valid assignment operation. B equal to 20 is a valid assignment operation. C equal to A plus B is also a valid operation. But 6 is equal to D is not a valid, it's invalid assignment. This is not allowed. So on the left hand side, you should only have variables. On the right hand side, you will have variables as well as values or expressions. So now let's see one simple example. Let's take int a equal to int a, then a equal to 34, and let's try to print a. Which will be 34. Now, let's say I have assigned a equal to 999 and try to print a again. This time I'll get a 999. Execute, compile, then execute. So I have got 34 and 999. So if you do not want the a value to be changed, you can declare it as final and try to execute and see what happens when we try to assign 999. It says variable might already have been assigned. So if it is defined as final, you cannot assign a new value to that variable. Let me paste the output here. Now let's move on to another example program. Let's say I have an int a equal to 10. Then I just want to print an a, which will be 10. And so we'll look at the compound assignment. The first two examples are simple assignments. So for the compound assignment, let's say, for example, I have a is equal to a plus 6. And if I try to print a again, it will be 16. But if I have to use a compound assignment, then I'll say a plus equal to 6, which is essentially means a equal to a plus 6. This is called compound assignment. Let's try to take this example and run this. Compile and then execute. We got 10 and 16. Now let's move on to the third assignment, chained assignment. Let's take an example. For example, we have, say, W equal to 444, and we have let's declare the variables first. W, X, comma, Y, comma, Z. And say, for example, W is 444 and X is also 444 and Y is also 444 and Z is also 444. So instead of doing this, what we can do is we can just put W equal to X equal to Y equal to and Z equal to 444, and we don't need to add these separately, and try to print W, X, Y, and Z. X, Y, and Z. And everything will print 444. And this is called chained assignment. Let me comment this. Java C test.java to compile, and then Java space test to execute. Now let's move on to the third type of operators, which is string concatenation operator. Okay, plus operator is called as overloaded operator in Java because it has more than one task or more than one use. Plus operator perform multiple operations based on what operands it's gonna use. Let's see some examples to get clarity. For example, I have simple print line with 10 plus 20. So the result should be 30. So in this case, it's adding two numbers. Let's compile and print the result, 30. So what if I change the integer values to some string like A, B, C, then D, E, F. So now the plus operator will work as a string concatenator, and result will be A, B, C, D, E, F. Let's compile and execute. And for this reason, plus operator is called as overloaded operator in Java because it has two or more than one use. So now let's say we have a combination. So for example, I have int a equal to 10, then int b equal to 20. So for the first time, I will just add a plus b. So my expected output is add these two numbers, which is 30. And the next, what I will do is add a result, like concatenate result equal to plus a plus b. Then my output would look like result equal to 10 and concatenate 20. So it is considering 10 and 20 as strings. But to avoid this issue, we have to use parentheses around the integer value. So whenever we declare something in parentheses, the first thing Java evaluates is inside the parentheses, and this time the result will look like result equal to 30. Let's try to run this program. Java C space test.java to compile, and then let's execute it, and this is how the result looks like. It's exactly as expected. The next type of operators is relational operator. It is used to check the relationship between a variable with variable or a variable with a value or a value with variable or a value with a value. Let's see some examples. So the output of these relational operators is always Boolean, either true or false. And the following are various relational operators in Java. Less than or equal to, greater than or equal to. So if we see some examples, we get clarity what we have uncovered so far. For example, I have 10 less than 20. Will give us true. Then let's say 10 less than or equal to 20, which is also true. Let's say 10 greater than 20, that's going to be false. And 10 greater than or equal to 20, that is also going to be false. Let's try to execute this program. True, true, false, false. Let's see some other example like 10 less than 10, 10 less than or equal to 10, 10 greater than 10, 10 greater than or equal to 10, 10 less than 10, we will get a false. 10 less than or equal to, we will get true. 10 greater than 10 is false. 10 greater than or equal to is going to be true. Let's compile, execute this. Yeah, we got false, true, false, true. The next operators we have is equality operators. We can apply equality operators to check whether two things are equal or not. We can apply equality operators for all primitive and objects. The output of these equality operators are also Boolean, either true or false. So we have equal to operator, then we have not equal to operator. These are the two types of equality operators we have. Let's see some examples. So for example, if I have 10 equal to and then 10 not equal to, then we have 10 equal to 11, 10 not equal to 11. 10 equal to is true, not equal to is false. This is false and this is true. Let's run this program. Compile and execute. We got true, false, false, true. So let's take one more example. Like for example, I'm equating true equal to true, then true equal to false, then false equal to false, and false equal to true. Now let's see. True equal to is true. True equal to false, and false equal to false is true, and the false equal to true is false. See. So the first one is true, second one is false, third one is true, fourth one is false. So we have got as expected. The next operator is increment or decrement operators. Increment operators is used to increase its value by one unit. Decrement operator is used to decrease its value by 1 unit. For increment, it is plus plus. For decrement, it is minus minus. And there is also another concept called A plus plus. Is post increment. Then if we have plus plus A, then it's a pre-increment. And similarly, if we have A minus minus, then it's post decrement. And if you have minus minus A, then it's a pre-decrement. We'll see some examples how this works. So for example, let's say int x equal to 10 and print line x, then the result will look like 10. So let's say x plus plus, and what will be the result this time if I print x? It should be 11. Let's execute this program. Compile, execute. So we have 10 and 11. Now this time I'll do pre-increment and try to print what happens. it is still the same. Even if it is pre-incremented then printed, then it's still 11. So if you want to see what's the difference between pre-increment and post-increment, let's take another example. Say, for example, a equal to 5. Then I want to do a plus plus. Then I'll be printing 6 here. No, a plus plus, I'll be printing 5 here because the printing operation happens before plus plus because it's a post increment. Let's do the printing again. This time a has a value 6. Just let's print another empty line so that we differentiate. Int b equal to 5. Then this time I'll do plus plus b, which is pre-increment operation. So this time I'll print 6. Then the, the second line I'll print b and try to print another empty line. And the second time when we print b, that is also 6. Let's try to run this program. Compile and then execute. So a is equal to 5, then print a plus plus. So first operation is print here, so it will print 5, then increment it, so it will be 6. Then the second line print a, this time a has 6 in it. Then in pre-increment the operation first, it will increment, then do the printing. So that's the reason we see 6. And if we print b again, we will get the 6. And that's the reason we see 5, 6, and then 6, 6. That's the difference between pre and post increment. So now let's look at next operator, which is conditional operator in Java. It is used to check the condition based on the result decision will be taken. So the syntax will look like result equal to parenthesis condition and question mark, and then a true block, else false block. This is the syntax for conditional operator. Let's look at one example. Let's say I have int a equal to 6, and then I will do System.out.println a personile 2 equal to 0 question mark, then say even number, else odd number, then close the parenthesis. So let's try to run this example. 6 is an even number. For example, I've changed it to 5 and rerun the test. I have to compile it. It says odd number. So I'll share some examples to understand this conditional operator. So given number is single digit number or not, whether to check how to check this. For example, n is greater than -10 and n is less than +10, then single digit number. Else, no. This is one example. So let's say, for example, max of two numbers. How do we evaluate this? For example, a greater than b, then question mark. And if it is true, then it's a. If it is false, then it's b. This is how we can find the max of two numbers. We'll stop here and Java session 111 and continue in the next. In this session, we will try to uncover the rest of the operators, logical operators. So these are used to merge or combine more than one condition. So for example, if we want to find out max of two numbers, like say a greater than b, if this is true, then a is the maximum of the two numbers. And if it is false, b is the maximum of two numbers. For example, if we have maximum of three numbers, so then we have to combine more conditions. Like for example, a greater than b and a greater than c, then a is the maximum of all the three numbers. If this is not true, then we have to check if b is greater than c, then if it is true, then b is the maximum of three numbers. Else c is the greater of maximum of three numbers. So we have logical and the symbol is double and. Then we have logical or, which is double pipes. Then we have logical not, which is a not symbol. And will return true if all conditions are true, else false, and or will return true if any one condition is true, else false, and not if the input is true, then output is false, and vice versa. So let's see some examples on these logical operators. For example, I have true, logical, and true. Then let's take another System.out.println line with true and false. Then let's take another example, something like false and true. And finally, take both false. So with the logical and, we have to see both are true, then it's true. And then one is false, then it's false. And here also one is false, then it's false. Then here both are false, then it's false. Let's see. Let's compile and see how the result looks like. So first is true, the rest of them are false. And this is for an example. Now let's change this and to logical or. So like we discussed, if one is true, then logical or is true. So only this falls in the last case. Let's run this example. So all of them are true except the last one. This is an or example. Now let's see the not example. For not, if it is true, then it's gonna be false. If it is false, it's gonna be true. So this is gonna be false. This is gonna be true. Let's execute, compile and execute this. It's gonna be false and true. Now let's move on to the next operators, that is bitwise operators. It is used to perform basic manipulation operations on number. The first operator is bitwise and the symbol is single add. And next one is bitwise or, which is single pipe. And next one is exclusive OR. And the symbol is cap. So we will discuss what are these. So bitwise and return true if both arguments are true, else false. Now, bitwise OR will return true if any one argument is true, else false. And bitwise exclusive OR cap return true if both arguments are in different state, else false. We'll see with examples to get a better understanding. So let's begin with bitwise AND. So true and true, it should be true, and true and false, it should be false. False and true should also be false. Then false and false should also be false. We will see the difference between logical and bitwise and in a while. For now, let's execute this bitwise and. It's going to be true, false, false, false. Let's take an example for OR. Let me change this to or, 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 or. And it's going to be true because at least one argument should be true and rest, both of them are false and this is false. Let's execute this. It's going to be true, 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 false. Let's see example for exclusive OR. Change this to exclusive OR, exclusive OR, exclusive OR, exclusive OR. So both of them are in the same state that it's false. Both of them in different state that it's true. Both of them in different state that it's true. Both of them in same state that it's false again. Let's execute this example. It's going to be false, true, true, false. So now what's the difference between bitwise and then logical and? So for bitwise, say for example, we have condition 1 and condition 2 and condition 3. Then bitwise, it evaluates all the conditions. But for logical and, condition 1, logical and condition 2, logical and condition 3, if at least one condition is false, then stop evaluating the rest of the conditions. If one condition is false, then it will stop evaluating the rest of the conditions. Let's see one simple example to understand this difference a little better. Let's say I have an int x equal to 10 and y equal to 15. And I have a condition, say for example, if plus plus x less than 10, and this is a bitwise and plus plus y greater than 15, then x plus plus else y plus plus. So let's print System.out.println x and System.out.println y. So since this is the bitwise and, it will evaluate all the conditions. So your plus plus x is a pre-increment, which is 11 less than 10, and plus plus y, which is 15 plus plus y is 16 greater than 15. So 11 less than 10, which is false, and 16 greater than 15 is true, but the final condition is false. This evaluates to false. So x plus plus is not evaluated, y plus plus is evaluated. So now, right now we have 16 in the y, then plus plus 16 would be 17. Now let's print x is having 11, and then let's print y, and y is having 17 in this result. So let's execute this example. So compile, oh sorry, I need to comment this out. Compile, sorry, compile, and then execute. So the answer is 11 and 17. In case of bitwise, 11 This is example bitwise and. Now let's change this to logical and like I said, if one false is evaluated, then it will ignore all the rest of the conditions. For example, in this case, x is 10 plus x is 11, which is less than 10. This is false. So the rest of the condition is not evaluated and directly go to y plus plus. And in y plus y, we have 15 and y plus plus will be 16 in this case because plus y is not evaluated because it is a logical AND. So the output should be 11 and 16. Let's execute, compile, and execute. This time we have 11 and 16. This is the difference between bitwise and logical AND. Uh, let's see one more or few more bitwise operators. First one is left shift, which is like less than, double less than. It is used to shift the bits towards left direction. Let's see one example. For example, if I do System.out.println 5 left shift 1. So for the left shift, the formula is n into 2. So if it is one time, then we do n into 2 one time. If it is 2 times, like left shift 2 times, say for example, n left shift 1 time, and the formula will be like n into 2. If it is left shift, say for example 2 times, then the formula is n into 2 into 2. That is 2 times. Let's see in this example. For example, 5 shifting 1 time, it's going to be 5 into 2, which is 10. Let's run this quickly. Compile and then execute. So it's going to be 10. For example, if I left shift 2 times, then it's going to be 5 into 2 into 2, which is 20. Let's run this. It's going to be 20. Likewise, we have right shift. with two greater than or double greater than symbols. And in the right shift, the formula is, instead of multiplying, we have to divide the number by 2. And if it is one time, we divide it by one time by 2. And if it is 2 times, then we divided it by 2 times. And we just put the integer value out there. Let's see the example to get the better understanding. So for example, 5 greater than or right shift 1 will be 5 divided by 2, and the answer is 2. And if it is 2 times, then have to divide it by 2 times, and our answer will be 1. Let's run this example. It's going to be 2 and 1. Next operator is complement, which is going to be like, for example, the formula is, if I have to see the complement of n, then the answer is negative of n plus 1. For example, I'll take twice complement, then our answer should be negative of 5 plus 1, which is negative 6. Let's execute this program to validate the formula. It's going to be negative 6. Then we have some special operators. Let's take one example first. If we have let's say 4 plus 3 into 2, the answer will be 4 plus 3 into 2 is 6, and then 10. So we have to follow some precedence before we calculate the answer. So the special operators precedence order will be like this. The first priority will be given to parenthesis. Whatever is inside the parenthesis, it will be evaluated first. Then the next priority is for increment and decrement. Next priority is for complement, and then not. Next priority is for multiplication, division, and modular division or percentile. And then next priority is given for plus and subtraction. Then the next priority is given for less than or equal to, greater than or equal to. And the next priority is given for equal to, or not equal to. And the next priority is given for bitwise and. The next priority is given for bitwise exclusive or. Then the next priority is given for bitwise or. And the next priority is given for logical and. Then the next priority is given for logical OR. The next priority is given for conditional operator. Then the least priority is given for assignment operator. With this, we have finished uncovering the operators in Java. I'll stop here and see you in the next. In this session, we will try to uncover control flow statements. So what are control flow statements? Generally, the flow of execution in any programming language is always sequential. If we have a program like this, with so many lines, the program execution is sequential. So if we want to interrupt that flow of execution, then we should go for control flow statements. So for example, I have certain lines of code, and say, for example, I have a condition A and condition B. So I need to execute these lines of code when condition A is true. And I want to execute this block of code when condition B is true. For these kind of statements, we call it as selection statements. Now let's suppose I have another set of programming lines, and say I have so many lines of code. In this block, for example, I need to repeat this block of code. Then I need to go for iterative statements, otherwise also known as loops. Now let's see the third variety. For example, I have another block of code, and at this point, I've decided that the execution is complete and I don't need to execute all these lines of codes. Then I need to go for transfer statements. So in selection statements, there are different subtypes or categories. First one is a simple if, and then the second one is if else, and the third one is else if, and the fourth one is nested if, and the fifth one is switch case. Likewise, in iterative statements, we have different types of iterative statements. The first one is while loop. The second one is a do while loop. And the third one is for loop. And the fourth one is for each loop. And in the transfer statements, we have different categories. We are going to uncover break, and we're going to uncover continue. So let's begin with selection statements. And I'll pick the first one, which is the simple if. So how does the syntax look like? It starts with an if and a condition, and maybe some lines of code, and then if block ends. So when the program is executed, first we will evaluate some condition. If the condition is true, then if then the true block, which is inside the if statements, are executed. Let's see one simple example. Say, for example, double salary is equal to $45,000. And I have, since it's a double, let's put it as decimal point, and character gender is equal to female or F. Then let's do system out line. Let's print the initial salary is salary. Then let's put an if condition, and gender is equal to female, then salary is equal to salary plus salary into, let's say, 5%, 5% raise. And then close the if block and then try to print the updated salary. Let's try to compile this code and then execute. So if you see here, the gender is female, and for that reason, we got a 5% raise. Now let's change the gender to male. Let's save and compile, execute. The initial salary and the updated salary is same. This is a simple if example. Now let's uncover if else. So the syntax will look like if condition, then we have if block and then close the if else, we have else block and some lines of code or block of code. This is how the syntax for if else would look like. First, we will evaluate some condition. If the condition is true, then if block is executed. If the condition is false, then else block statements will be executed. Let's take a simple example for if else. So let's say double salary is 45,000 and character gender is male, then print the initial salary. Then if the gender is F, then the salary is salary plus 5% raise, and else salary is salary plus, let's say, 10% raise. And try to print the updated salary in the end. So let's try to compile this code. and execute it. So the gender is male, and for that reason, we got a 10% raise. Let's try to change the gender to F and execute, compile, and execute. So for gender female, we have got 5% raise. This is how we can use if else. Let me copy the console output. Let's look at another example. For example, we need to take an input from a user. We need to take a number as an input from user and find out whether that number is an even number or non-number. So for that, we need to use scanner class. For us to be able to use scanner class, we have to import Java util dot star and scanner SC is equal to new scanner. We need to take the input from the user system.in, close the parenthesis, then should ask the user to enter any value. I'll just use print. Then we need to assign the int n equal to sc dot next int, and if n percentile 2 or modular division 2 is equal to 0, then let's print n is even number. Else n is odd number. We don't need this. Save this program, put it in examples. Let's try to compile. I missed semicolon. Compile, then execute. Enter in value, I'll enter 56, 56 an even number. Let's try to enter 7, 67 is an odd number. Okay, let's summarize the conditions or if and simple if and else if blocks. So what is the concept, and then the number of conditions we use, and then the number of true blocks, and then the number of false blocks. So first one is a simple if. We have only one condition, then we have only one true block, and we do not have any false blocks in simple if. Now let's look at if else. So we have one number of conditions, we have one true blocks, we have one, then we have one false block. Now let's move on. Oh my God, I was just putting it in the program itself. Just remove this. Okay, now let's continue to explore third statement, which is else if. So when should we use else if? If we want to evaluate multiple conditions, then we should go for else if. Let's look at the syntax. If condition one, then execute a block of code, then else if condition 2 is true, then execute some block of code, and else if condition 3, then execute a block of code, then so on, so forth, and one last else without any condition, which is kind of default. This is how the syntax looks like. Let's see some examples using else if. So let's try to write a program to take user inputs for 3 numbers and find the biggest of all. So we should use the scanner class to take the user inputs, and let me try to say enter a value, then assign int a is equal to se next int, and then do the same thing for B, enter B value, int B is equal to SE next int, then enter C value, then assign C is equal to SE dot next int. So now let's build the condition. If A is greater than B and A greater than C, the System.out.println A is biggest number. Else if B is greater than C, then B is the biggest number. Else C is the biggest number. Let's try to compile this code. SC, variable SC is already defined. I copied multiple scanner SC. I don't need all these. I just need declare it one time. Now try to compile and execute. Enter A value 243. 6344 is the biggest. Let me try with some more. $84,027 is the biggest number. Let me take the console output and then paste it in the notes. Now let's add the summary for else if. So number of conditions, we can put n number of conditions. Number of true blocks, we can put n number of true blocks. Number of false blocks, we will only have one false block. So the next statement we have is nested if. And if condition within another if is called as nested if. So let's take one simple example. Scanner SE is equal to new scanner system in, and let's try to enter age of a person. And int age is SE dot next int. And then, for example, if age is greater than or equal to 1 and age less than or equal to 100, then let's write another if condition: age greater than or equal to 18, and then system.out.println, let's say eligible to vote. Else system.out.println not eligible for vote, and else not a valid age. Let's try to compile this code. I think I've missed one flower closing if block, and save this, compile, execute. Enter age of a person, let's say 56, eligible to vote. Let's test again. Let's say 15, not eligible to vote. Let's say 345, not a valid age. This is how a nested if else or nested if block will work. Example for the nested if. We paste the output for nested if. So now let's summarize nested if. We can nest any number of conditions, and we can have any number of true blocks, and we also can have any number of false blocks in nested if. Now let's look at the switch case. Before we go to switch case, let's look at some conclusions. Curly braces are optional in if statement. but without curly braces, we can only have one statement. If you want to have multiple, then you have to utilize curly braces. So let's look at switch statement. For example, let's take a program where if you enter the day number, then you should tell the day. For example, if you enter 1, you should say it's a Monday. And else if you enter 2, then it should be telling us it's Tuesday. And if you enter 3, it should be telling us it's Wednesday. So on and so forth. So this equal to operator, we have to use 7 times, which increases complexity. For that reason, we have switch case. Let's look at the same example with a switch case. So let's take the user input and let's say enter a number and try to take a as next int, and instead of if, we just use switch lock, and we should use the day to find out which day it is. So let's say case 1, then System.out.println, just print Monday, and you have to use break for each case. Monday, Tuesday, Wednesday, Friday, Saturday, Sunday. Day 2, it's Tuesday. Day 3, it's Wednesday. Day 4, it's Thursday. Day 5, it's Friday. Day 6, it's Saturday. Day 7, it's Sunday. This is how a switch case example looks like. Let's try to compile this. Compile, execute, enter the day number, Friday. let's say 7 Sunday. Let me enter something which is not defined. So it doesn't give me any result if I enter something which is not in the list. So for that reason, we can set a default case and say invalid day number. Let me save. Oh, I was doing it in the notes. Let me put it in the program. Save it and then compile, execute, enter day number. Let me enter 6. It is a Saturday. Enter day number. Let me enter 67. It says invalid date. Let me put this in the notes. Sorry, this is in the program. So let's look at some conclusions on the case, switch case. Duplicate case labels are not allowed. For example, if I reuse one, try to execute or compile, it says duplicate case number. So we cannot reuse or we cannot use a case number, duplicate case numbers. And another note is case labels must either be constant or constant expressions. It cannot be variables. Let's also look at the allowed values for switch case arguments. Byte is allowed. Short is allowed. Int is allowed. Long is not allowed because long is a big number and we cannot use those many switch cases. Next, float is also not allowed. Double, obviously not allowed. And char or char is allowed. Boolean is not allowed. So let's summarize the switch case. Number of conditions, you will have only one. Number of true blocks, you can have a number of true blocks. A number of false blocks, you can have only one false or default block. I will stop here. see you in the next. In this session, we will try to uncover the iterative statements or loops. The first iterative statement is, or first loop is a while loop. We use while loop if we don't know the number of iterations in advance. So let's say, for example, we have a database and we need to pull the number of employees, or we need to pull the details of all the employees in the employee database. So we do not know how many employees are present, so we have to go for a while loop. Let's see how the syntax will look like. While the condition, and if it is true, then we execute a while block of code. So until the condition becomes false, the statements inside the while loop will be executed. Let's take an example. For example, we take a user input, a number, any number, and we have to give the sum of all the digits in that number. So let's write a program to calculate the sum of the digits in any given number. So the first thing we need to do is to use a scanner class, scanner SC new scanner system.in, so that the user will enter any number. Then let's say int n is SC next int. Then let's also define int d for digits and s for sum. And let's initialize sum to 0. Then use the while loop. And n not equal to 0. And then inside a while loop, d is equal to n modulo 10. And then sum is equal to sum plus digits, then n equal to n divided by 10. So let's see what happens when user enters a number, how the calculation happens. Let's print the final message like sum is s. For example, let's say For example, let's say the user entered 1, 2, 3. So here the n value will be 1, 2, 3. And n is not equal to 0. So this condition is true. Now digit d is equal to n percentile 10. So we have to divide n with 10. So this will get assigned to d, which is 3. Now s is equal to s plus digit. So now we have to add 0 plus 3. Now s is 3. Now n divided by 10. This is n. And divided by 10, we have 12 here. So now n is 12. Now again, while checks n not equal to 0, which is 12 here, so which is true. So now 12 divide percentile 10. This time d is having 2. The second time d is 2. And now we have s3 already. Then we have to add d, which is 5. This time s is having 5. Then we have to calculate n divided by 10, and this time we have n equal to 1 for the second time. So the third time, while loop, n not equal to 0, which is 1, which is true, and then d percentile 10, you will have one reminder. So this time d will have 1. And then s is equal to s plus d. As we have 5, then plus d is 1, which is 6. And n divided by 10, and we do not have any number here. This time n is equal to 0. So it again checks n not equal to 0, which is false. Then it would go to the print line statement and sum s equal to 6. This is how the program gets executed. Let's try to compile and execute this. Compile, execute, enter. I didn't save this program. That's the reason it's taking the last. Compile, execute, enter any number 4, 5, 6, and the sum is 15. Let's enter 1, 2, 3. The sum is 6. Let's enter 6, 7. Sum is 15. This is a simple example for a while loop. Now let's move on and try to explore another kind of loop called do while loop. if we don't know the number of iterations in advance, but minimum one-time execution is required, then we should go for a do while loop. So let's look at the syntax. Do, then some blocks of code, and then while, then condition. So it will execute these lines of code before even this condition is evaluated. So minimum one time it will execute even if this condition is false. So let's see a simple example to understand the difference between a while loop and a do while loop. For example, let's say I have int a equal to 19 and b equal to 15, and let's say a is less than b, then let's try to increment a and print it. So let's print a plus plus. So let's try to execute this program and see how the result will look like. Java C test.java and then execute. And if you see A is 19, which is greater than 15, and you don't see while condition is true, and that's the reason you don't see any result. Let's change this to a do while loop. So do while at least one time it gets executed even if the condition is false. So compile. I missed semicolon here. Compile and then execute. So A is printed and it's incremented after the print because this is a post increment. Let's try to change it to a pre-increment. This time it should print at 20. Let's compile and execute. This is how you execute the do loop at least once, even if the condition is false. So in those cases, you will go for a do while loop. Let's move on and look at for loop. So for loop, if we know the number of iterations in advance, then we go for a for loop. So let's see the syntax. for, then initialization, then conditional, then updation. Then open the loop, then we have body of the loop, then close the loop. So let's see how this for loop works with an example. For example, you need to print a message, let's say 10 times. So let's say, for example, hi, welcome to Java world. I want to print this message for 10 times. So I'll just use for loop and then int I equal to 1, then I less than or equal to 10, then I plus plus. So let's try to compile and then execute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. This is how a for loop is used. I'll stop here and continue. Before we continue to for each loop, we need to uncover arrays. So in this session and few more upcoming sessions, we will try to uncover arrays. And some people also call it as array data structure. So what are arrays? For example, I have int w equal to 10. And let's say I have to declare one more variable called x equal to 20. And let's say if I have to declare one more variable called y equal to 30. And let's say if I have to declare one more variable called z equal to 40. Let's say if I have to declare maybe 50 variables, so on and so forth, a 50. And then I need to maybe calculate the sum of these a1 to a50. So instead of declaring so many variables and assigning so many values to individual variables, we can utilize arrays to overcome these multiple variable declarations. we should go for arrays. So what is an array? An array is an indexed collection of fixed number of homogeneous data elements. So indexed collection. So in an array, the elements are indexed from 0, 1, 2, 3, 4, 5, so on and so forth. And what is homogeneous? Homogeneous is similar type of data. And the next one is its fixed number. Fixed number is essentially fixed in size. The main advantage of arrays is we can represent multiple values with the same name so that readability of the code will be improved. But there are some disadvantages. The main disadvantage is, or the main disadvantages are one, fixed number of elements. And the second disadvantage is homogeneous objects. Are only allowed. So to overcome these above problems, we should go for collections, which we will uncover as we progress. So variables, and then whatever challenges we have, we will overcome using arrays. And whatever challenges we have with arrays, we will overcome with collections. So now let's look at array declaration. How do we declare an array? We can declare an array in Java by using the following syntax. So the syntax is data type, square braces, and then array name. This is the syntax for an array. Let's see example. Int square brace A. This is one-dimensional array. Similarly, we will have two-dimensional arrays like int two square braces and then the name of the array. We can also have three-dimensional arrays. So let's look at how do we create an array creation. Every array in Java is treated as an object. Remember, Java is an object-oriented programming. Hence, we must create an array by using new keyword. Let's say, for example, we have a student class. Student S is equal to new student. Let's say we have another class called employee E equal to new employee. And say, for example, I have an array. I have another class called customer. C equal to new customer. So likewise, we create an array. So int A, then A equal to new int of size 3. This is one way to create an array. Or just in single step, int square braces space A is equal to new int of size 3. And this is the recommended way to create an array. So like student has a class student, array has its own class. Like for A, it is an integer class or uppercase I wrapper class. So if you have a byte array, its class name will be uppercase B. If we have a short, its class will be uppercase S. If we have an int, then its class will be uppercase I. If we have a long, then it will be uppercase L. If you have a float array, then its class will be uppercase F. Then if you have double array, then you will have uppercase B. And if you have a char array, then you will have uppercase C. And if you have a Boolean array, then you will have, we have already taken uppercase B in byte, so Boolean will be uppercase C. And for example, you have one dimensional integer array, then you can have uppercase I. Similarly, if you have two-dimensional integer array, then you have to use two open square braces I. If you have three, then you will have three open brace I. So the most recommended way to create an array is int a equal to new int o square brace, and you can specify size of the array. Let's say n. This is more easier to read. Let's go for a program. So let's say I have a class student, then I have a class employee, then I have a class called, say, customer. So let me create an object called student s equal to new student. Likewise, I'll create employee e object. Then I will also create customer c customer, and I'll create an integer array called a and new int of size 4 and Boolean two-dimensional array b is equal to new Boolean and size 2 by 2. So let's try to print the name of the class name for student. So s dot get class. We will explore these detail in object-oriented programming concepts. Get name. Let me try to compile this program and execute it. So you will get the student class name. Let me do the same for employee E, then for customer C, and then let me get the class name for integer variable A, and also get the class name for Boolean variable B. Let me compile and rerun. So, like we've discussed, the class name for integer array will be open brace I, and for Boolean it will be open brace Z, and it's a two-dimensional, it's two open braces and a Z. I will stop here and continue next. This is arrays part 2. Let's try to draw some conclusions what we have discussed the last session. At the time of creating an array, it is mandatory to provide the size of the array. Else we will get compilation error. So for example, int a is equal to new int of 3. This is a valid array creation. For example, if you say int a new int of nothing, no size, then this is an invalid way of creating an array. Let's go to the next conclusion. Next note, we can create an array with size 0. There is no issue or error because 0 is an integer. So let's take some example here. Int a is equal to new int of 0. Try to compile and then execute. So there is no error. So size 0 an arrays is allowed. So similarly, let's take another note. What if I say maybe -8? Is it allowed? Let's try to compile. It's successfully compiled, but execute. Let's see if it gets executed. It says negative array size exception -8. So we cannot declare negative size array. So we cannot create an array with negative size. If we are creating, we won't get any compilation error, but during execution, we will get runtime error saying negative array size exception. continue to the next note. We only allowed data types for size of an array are byte, short, int, and char. You cannot use long or double or any other data type because it's not effective because the long size is too large and the arrays will not be created with that base size. Let's move on to another example. Say, for example, int a, int, and let's say we will take character a. So is it allowed? Let's try to compile and execute. You don't see any issues. And character a, the integer ASCII value is 97, so the size will be 97. And let's say, for example, if I declare the size as 3.4f, which is floating point, is it allowed? It's not allowed. Let's compile. It says possible lossy conversion of float to int. So we cannot take float as the size of an array. Only allowed data types are int, byte, short, and char. Now let's take a look at two-dimensional arrays. In Java, 2D arrays are not created using matrix style. Let's take a look. For example, I have an array, say 3 by 3. Then what is the matrix style of arrays? For 3 by 3, it will look like this. This is 0, this is 1, this is 2, this is 0, this is 1, this is 2. But in Java, arrays will not be created in this style. So let's say, for example, I have an array of size 3, which is 0, 1, 2. Then this will again have another array of size 0, 1, 2. And this will have another array of size 0, 1, 2. Again, this will have an array of size 3 with positions 0, 1, 2. So this is the style which is used in Java for arrays. And this matrix style is used in C language. And this is also called as array of arrays. So it follows array of array style. Let's take an example. Int student array A is equal to new int O size 3 by 3. Now let's look at array initialization. Once if an array got created, we should provide initial values. Otherwise, JVM will assign default values. So what are the default values? For integers, it is 0. For double, it is 0.0. For characters, it is an empty character. For Boolean, the default value is false. And for objects, the default value is null. Let's take an example to understand how the default values gets assigned. Let's import Java.println package. And for example, say let's create an array int A with size 5, then double B with size 5 again, and then char C with size 5 char, then Boolean D with size, say, for example, 3. And let's create a student E is equal to new student with size 6. Declare class student. And then let's try to print System.out.println uh, arrays to string. A. Let's try to compile and then execute. So we did not assign any values to the array A, so it has taken default values of integer type. Let's do same thing for B, C, D, E. Compile and execute. So we have A all zeros, B all double 0.0 defaults, character empty characters, Boolean false, and object all null students. Let's take another example. So int a equal to new int of 5. Then let's try to assign a of 2 as, say, for example, 1, 1, 1. Then assign a of 4 as 2, 2, 2. And we do not assign remaining values. So let's try to print how the array would look like. Compile, then execute. So it has taken default values for the remaining ones except the ones which we have defined. Let's say we have an array of size 4 and let's assign A0 with 10, A1 with 20, A2 with 30, A4, A3 with 40. And let's add another additional element, A4 with, and try to compile and execute. If you see here, we see array index out of bounds exception. Index is 4, the length is 4, but we have 1, 2, 3, 4, 5 elements. So that's the exception we get if we define more array values than the size. Let's look at array declaration, creation, and initialization in single line. How do we do that? So, for example, int array A, then A is equal to new int of size 3, then A of 0 is equal to 1, 1, 1, then A of 1 is equal to 2, then A of 2 is equal to 3, 3. So we do not need these many lines to declare an array. We can just simply declare int two-dimensional array A is equal to flower braces 11, comma 22, comma 33. So this way we declare an array, create an array, and initialize an array in single line. So where is the new keyword? So it's taken automatically. Likewise, where is the size? It is also taken automatically based on how many array elements are there. Another example, for example, character array and variable name or array name is vowels, and you can just say A, E, I, O, U. You just declare in a single line. So let's see some examples. For example, int A equal to 111, comma 222, comma 333. So now let's print System.out.println A of 0. Similarly, System.out.println A of 1. Similarly, System.out.println A of 2. Let's try to run this example. We have 111, 222, 333. Let's look at another two-dimensional array this time. A equal to, say for example, 10, comma 20, comma 30, comma then 40, comma 50. This is a two-dimensional array. So let's try to draw the array first. So we have 1 and 2. 1, and 2. 0, 1. Then we have 0, 1, 2. We have 10, comma, 20, comma, 30. Then this is array A. And here we have 0, comma 1 with 40 and 50. So let's try to print A of 0, 0. What is this? So A of 0 and 0 is 10. A of 0, 1 is 20. A of 0, 2 is 30. A of 1, 0 is 40. A of 1, 1 is 50. So this is going to be 10. Then A of 0, 1 is going to be 20. Then A of 1, comma 1, 0 will be, we have to find A of 0, 2 will be 30. Then we have A of 1, 0 will be 40. Then we have A of 1 and 1, which is 50. Let's try to compile and execute. 10, 20, 30, 40, 50. This is how you can access two-dimensional array. Let's take another example, which is three-dimensional array. For example, int three-dimensional array A, let's say 10, 20, 30, 40, 50, then just close and so we have another 60, say for example, then we have 70, comma 80, then we have another array, which will be like 90, 100, 1, 1, 110. So this is a three-dimensional array, and we have to print A of 0, 0, 0. Let's try to draw this array so that we will have a better understanding. On the top level, we have 1 and 2 elements. So 0 and 1. Then inside that we have 1 and 2. So we have 0, 1. And then inside 0 we have three more. 0, 1, 2. And we have 10 here, 20 here, 30 here. And then here we have two more, 0 and 1, 40 here and 50 here. Then here we have one, two, three, 0, 1, 2. And at 0 we have 1, which is 60. And at 1 we have 2, 0, 1, we have a 70, we have a 80. And at 2 we have three more elements, 0, 1, 2, we have a 90, 100, and a 110. So now we have to print A00, which is 10. And say, for example, if we want to print A11, what do we have here? A11, we have 50 or 50. Say, for example, if I want to print A102, A10, we only have 00, not 2. So this will create an arrays index out of bounds exception. Say, for example, if I have to print A100, A100 will print 60. Say, for example, if I want to print A120, A120, which will be 90. Say, for example, I want to print A121, then I'll have 100. Say, for example, if I want to print A122, then I'll have 110. Let's try to save this and compile. And execute. So, like I said, this third line is out of scope, or array index out of bounds exception. Let me comment that out to validate the rest of them. So I have got 10, 50, 60, 90, 100, and 110. I'll stop here and continue. In this session, we will try to uncover length and also another function called length. Let's try to look at length first. It is a final variable or identifier applicable only for arrays. It returns number of elements present that array, or also known as size of array. Let's look at length function. It is a method which is present in predefined string class. It returns number of elements present in that string, or also known as size of the string. Let's look at some examples. For example, I have an integer, say a, and new int of size, sorry, and if I do a dot length, then I need to get the size of that array. Let's compile. Execute. I got the size of the array as 3. For example, if I use the length method, I would get compilation error. Let's try to compile. Yeah, it says cannot find a length method for array A. For example, if I have to use the length method, I would declare a string s and say new, like say for example. And if I have to get the length, it should return how many elements are present in that string. Let's try to compile this. I need to change the variable name to as distinct with the previous example, variable name A. And let me execute this. It's 4. So that's the difference between length and length method. Let's try to see both cases let's say if I change this to string array A and I declare, say for example, your name's here, Mike. Amy. And John Doe. And try to get the length of this array. We have 4 elements. The size of this array is 4. And let's say, for example, I need to get the length of first element in that array, A of 0, which is Mike, and I have to use length method for the string, and it's going to be 4 again. Let's do one more. Say that the length of Amy, it's going to be 3. Let's try to compile and execute. 4, 4, 3. That is all about length versus length function. Let's uncover what's called anonymous arrays. What are anonymous arrays? Sometimes we can create an array without name, such type of nameless arrays are called anonymous arrays. The main objective of anonymous arrays is just used for instant purposes. We can create anonymous arrays by using the syntax. So new int temp week 30 is, for example, one dimensional. For example, 2-dimensional new int of then open parenthesis, open first one-dimensional array 10, 20, 30, 10, comma maybe 40. This is how we can declare anonymous arrays. Let's see some examples. For example, I'll write one class to add sum of all the elements present in an anonymous array. So sum of A, call it A, whatever is sent to this class and declare int sum is equal to 0, and for each int item, which is the element in that array, then sum is equal to sum plus item, the current item or current element. Then we have to return sum from this class. So here I'll take few anonymous arrays. Say for example, sum of new and 10 comma 20 comma 30. So it should give us 60. And say for example, I have another anonymous array like 40, 50. It should give us 90. That's another one. For example, 60, 70, 80, 90. 90, 70, 150, 90, 60, 150, and 80, 70, 150, total 300. Let's try to compile. Execute. We have 60, 90, and 300. Let's move on to next topic, which is array element assignment. So let's see some cases, like case 1. In the case of primitive arrays as element, any type is allowed. To be promoted to the declared type. Let's see with some examples. What does this mean? So let's say I have a byte v1 is equal to 10. And then say for example, I have a short v2 is equal to 20. Then let's say I have an integer and v3 is equal to 30. And let's say I have a log v4 is equal to 4. And then let's say I have a byte array called a new byte of length or size 4. Then a of 0, I can assign v1 because v1 is a byte. This is a valid example or a valid entry. If I have A of 1 is equal to V2, this is not allowed. Even if the value fits in the byte range, the data type of V2 is short, and you cannot assign short to a byte array. So let's try to compile to see. So it says possible lossy conversion from short to byte. So V2, it's invalid. So now let's make this array to short. So we can assign byte, we can assign short, but let's try to assign element A2 with V3. And V3 is integer, so this is invalid. So let's try to compile this. It says incompatible, byte cannot be converted to short. It's possible lossy conversion from int to short. For example, I change this to int, then v3 will become valid. But let's say I have a3 and assign v4, which is invalid because you cannot assign long to an integer array. So let's try to compile this. It says byte cannot be converted to int, lossy conversion from long to int. So from all these examples, what we can conclude is we can assign byte to a byte. We can assign a byte and a short. We can assign byte, short, and int to an integer. And then we can assign byte, short, int, and long to a long. Then we can assign byte, short, int, long, and float to a float. Then we can assign byte, short, int, long, float, and double to a double. For Boolean, you just have to assign Boolean, and for char, you can assign byte, short, int, and char. Okay, now let's move on to case 2. So in the case of object type arrays as array elements, we can provide either declared type objects or its child class objects. Let's look at what this means exactly using an example. So let's say I have a class called student and another class test. We already have it. So for example, I have an object array A. We've got a new object of size 4. So A of 0, I can assign new object itself, which is fine. Say for example, A of 1, I can assign student class. I can assign test class itself to the next element. And I can also assign, say, for example, new string, say ABC. These are all allowed for an object array. So let me try to print System.out.println arrays to string of A. Compile. I misspelled the string, string string. Compile. And then execute. So it's printing the object address for object, and for student, it prints the student class address, and then it prints the test class address, and then it prints the string itself. So all these are allowed for object array. Let's take another example. For example, I have array number, the A, and new member of 4. A0, I can take it as new integer, says, say example 10. It is allowed because integer falls under numbers. And A1, I can take a double, that also falls under the numbers. And for A2, for example, if I take test, it's not allowed. And for string, that is also not allowed. Now let's move on to case 3. Case 3 is related to the interfaces. In case of interface type arrays, interfaces we will cover as we progress, but let's just for the sake of noting it down, giving it here. In case of interface type arrays as array elements, we can provide its implemented class objects. So for example, let's take a runnable interface R is equal to new runnable of size 3. Then R out 0, I can take a new thread. We'll obviously uncover these in interfaces. Then R of 1, say for example, I wanted to take a string for interface array ABC, that's not allowed. This is invalid. So let's try to summarize what we have covered so far. For primitives, any type of values which can be promoted to declared type. For objects, either declared type and its style as objects. For interface, implemented class objects. For abstract class, its style class objects are allowed. We'll get more clarity as we progress and cover interfaces. So let's move on to the next topic. It is array variable assignments. Element level promotions are not applicable at array object level. So for example, char, a value, can be promoted to int type. But character array cannot be promoted to int array. So this is valid. This is valid. Let's see this with an example. For example, I have an integer array a, and I have 10 comma 20 comma 30. And say for example, I have a character array called B, and let's say I have A, B, C. So int new array int C, for example, I can assign A to it, which is totally fine. And let's try to say print arrays to string A, comma, B, not B and C. So this should work perfectly fine. Let's compile and execute. I have 10, 20, 30, B, A, B, C, and then C, I have A in it, so 10, 20, 30. So if I try to assign B to this C, I will not be able to assign because I cannot assign char to an int. So let's compile and see. So it says char array cannot be converted to int. So let's try to conclude some conversions here. So char to int, it's valid. But if it is from char array to int array, it's not valid, so it's invalid. So next, let's see, for example, int to long is valid, but int array to long array, it's invalid. For example, let's say double load. That's not allowed. It's invalid. Likewise, double array to float array is also not allowed. Now let's say, for example, string to an object. It's allowed. And even string array to object array is also valid. So in case of object type arrays, child type array can be assigned their type array variable. So, for example, I have a string array A, which is equal to, let's say, A, B. And if I assign this to object array called B is equal to A, this is allowed, this is valid. I'll stop here and continue. We will continue to uncover arrays. Let's look at the next case. So whenever we are assigning one array another array, internal elements won't be copied. Just the reference variables will be assigned to be hence the sizes of the arrays are not important. Let's look at with some examples. So for example, I have an int a and 20, 30, and let's say I have an integer b, let's say for example 40 and 50. And if I want to print a, I do arrays to string a and arrays to string b. Then for example, if I assign b to a and try to print a and b after assigning, let's look at what happens when we execute this Java program. Compile, and execute. So for the first time, A printed 10, 20, 30, and B printed 40, 50. After the line 10, we assigned B to A. So now A is equal to 10, 20, 30 is gone, and instead A holds 40 and 50. So even if the size of A is 3 and B is 2, we can still assign. That's the statement we just made here. Copy output of this program here. For example, if I just do the other way around, assign A to B, and now I should print A, B, then A 2 times. Let's see if that happens. Secure. So this time I've got 8 times after I assign B to A. Now let's look at case 3. Whenever we are assigning one array to another array, dimensions must be matched. What that is, that means in place of one-dimensional array, we should provide only one-dimensional array. If not, we will get error. So let's look with some examples. So for example, if I have a two-dimensional array, A int A equal to, int of size 3, and say for example, if I say A of 0 is equal to new int 4 and 5. This is not allowed. So let's try to compile and see what is the error that we get. It says incompatible types. Two-dimensional array cannot be converted to one-dimensional array. So when we assign arrays, the dimensions should be matched. Let's say, for example, if I try to assign integer 10 to A of 0 and try to compile, it says incompatible types int cannot be converted to integer array. So just paste this sample also in my notes and copy the error here. The next one is reading and writing elements from an array. So let's see one example. For example, so for reading, we have scanner class, and for printing, we can utilize any of the loops to write elements from the array, for example, for loop or for each loop. And we'll see using all these loops one by one. So for example, let's say we will take the input from the user. So scanner object equal to. So this is the object name. You can take anything, new scanner, system.in. This means that we take the input from the user. Let's print message for the user System.out.println. Let's do the print because we just take the input from the same line. So print enter size of an array first. Let's say he enters the size of the array first. He decides the size of the array. Then we declare int size is equal to object name dot next in. So this gets the user input, that is size. And then we name the array as new int of size. This is our array which we generated. Now we have to read the elements from the user. So for that, what we will do is I'll ask the user to enter those many elements. For example, he decided the size. So I say enter those many elements. And I'll do the next line, println. So I'll use for loop and index is equal to 0, then index is less than 8 of length. That gives the size of the array. And then we increment the index plus plus. Let's open and close the for loop. And here, a of index is equal to object name dot next int. So once he entered all the elements, we need to print these elements, and I'll be using the while loop here. I'll just give a message, something like array elements R and declare int I is equal to 0. This is my counter, and while I less than a dot length, and open the while loop, and I'll just print ALI, which is the front element. Then I'll increment I. Let's try to execute this program. Compile, execute, enter the size of array. I'll enter 4, and then maybe I'll enter 12, 5, 67, 18. Those are the array elements that I have entered. Let's try to execute it again. This time I'll enter the size of the array as 6, so I have to enter 1, 2, 3, 4, 5, 6 elements. So if you notice here, either you can use spaces to enter the elements, or you can use enter and a new line, and then you can enter your elements. Let me take this example and put it in the notes. Okay, this time, instead of while loops, I will use the for loop to read the elements. So for loop, I don't need to declare the integer. I can just declare it in the for loop itself for int I is equal to 0, I less than a length, and then I plus plus. And here I'll just remove this line and try to file and execute this program. Enter the size of the array 5. Enter 5 elements 1, 2, 3, 4, 5. So the array elements are 5. So you can switch the loop from while for. And now I'll try to change the for loop to for each loop. So for each loop is int element is the element name. You can give it anything, and then print the element. Now let's try to compile and execute. Enter array elements. I'll enter 4, 3, 4, 5, 6, and we got the result. Here's the for loop, for each loop program here, and the result will essentially look the same. This time we will also look at this function called arrays to string to print the array. So I don't need any for loop or for each loop or while loop. I'll just use System.out.println and I'll use this function here, arrays string. And let's try to compile and then execute. Enter the size of the array 5. I'll enter 1, 2, 3, 4, 5. And this is how the array is printed. I'll take the output. So we have seen while, for loop, and for each loop, arrays to string function, print the array. So let's summarize what case we will take each of these. Case 1 for printing, you can take arrays to string. And for example, case 2, you need to access the elements. Then you will go for each loop. And then case 3, you need to access elements index. Then you will go for loop. I demonstrated while loop, but that's not frequently used. You can just go for loop or for each loop. So for example, I have 10 elements, and let's say I need to print, then I do arrays to string. And step 2, maybe I have to sort them. Then again, print the sorted array, then I'll use arrays to string. Let's take another example, sum of even elements and of odd elements in an array. In this case, I'll go for each loop. Then if the element is even, then add some even. And if the element is odd, I'll use some odd, then print it. For example, if I have to swap first and last element, and second and maybe second last element, then I need to go for indexing. So I need to go for loop. So I will have the index. I'll stop here and continue. In this session, we will try to uncover some programs on arrays especially one-dimensional arrays. So in the last session, we have seen some programs on how to read and write array elements. Let's try to look at that example. So for reading the arrays, we are using scanner class, and we can use any name. I've taken object name new scanner system.in to take the input from the user, and then system.out.println and enter the size of an array. And then the user will enter the size of an array, and we'll take that size and assign it to the new integer and of size whatever user has entered. And to read the elements, we use System.out.println enter size these many elements, and for loop we will using index, and a.length will give the size of the array, and then index plus plus, and then we keep on assigning the array elements. And for printing the array elements, we use System.out.println and use the arrays.toString of a, which we have discussed in the last session. I'll try to compile this program and execute, enter the size of an array as 4, and I'll enter. So if you see here, I can use space between the elements, and also I can use a new line to enter the array elements. Both are just works fine. I'll capture this program, save it here, and the output. So now let's see, for example, have to add all the elements that are present in that area. So the steps are similar. We will try to read the array size, then read the elements from the user, then print the array elements. Then we have to implement a logic to add the elements of the array. For that, I'll just declare int sum variable and initialize it to 0. And then I'll use for each loop, and for each element that is present in that array, I'll add it to the sum. So sum is equal to sum plus element. And once I do this, I'll try to print the sum of the array elements is, let's use the variable sum. So let's try to see how this works. An example. For example, the user has entered 10, 20, 30, and 40. So the sum is 0 first, then for each element, we'll get the first one, and then sum will be 10. Then we will take the second one, then add it to the first one, which will be 30. Then in the element, we will have 30 this time, and the sum is 30 already. This will be 60 total. And then for the last element, we will have 40. So the sum will be 100, and we will print some of the array elements as 100. Let me compile this. Execute, and I'll enter size as 4. I'll enter 10, 20, 30, 40. And the sum of the array elements is 100. Hit this program and also paste the output. Now let's move on. This time I'll try to get the max of the elements of the array. So for getting the max, we will just reuse reading the size of the array, then reading the elements from the user, then printing the elements from the user, and then we will try to implement max of the elements here. So instead of sum, I'll use something like max element, and here I'll assign the lowest value that it could take, which is like integer of min value, which will be a negative, and a number will be a big one. Then for each element, then I will get the max. Max element is equal to element. What is the condition? We have to see if the element is greater than max element. Then we will assign the max element with that element. And here I'll try to write it as max of the array elements is max element. So let's try to see how this program works with an example. So the max element, like I said, assume we take a large negative number for the first time. Then let's say I have the same 10, 20, 30, 40 array. So now the first element here is 10. 10 greater than this max element, which is true, then the max element now gets assigned with 10. So we do not have this negative number anymore. We have max element as 10 right now. So now the next element is 20. So now check 20 greater than 10, which is true. So the max element will get assigned with 20 this time. And for example, I have 30, and 30 greater than 20, which is true. So then 30 gets assigned in the third iteration. then I look for 40 greater than 30, which is true as well. So now max element will get 40 in it. So finally, the print message will be 40 is the maximum of this array. Let's try to compile and execute this program. Enter the size 4. This time I'll enter -10, 50, 67, 46, minus, maybe I'll use some big number. So here, max of the array elements is 47. Now, let's move on. Let's try to sort the elements present in an array. So we have to sort the elements in the ascending order. So we will reuse the program. We will use the scanner to read the size, then read the elements from the user, then just print the elements as is. So I'll try to change this as array elements before sorting. So that will print as is. Then we have to implement the sorting logic here. So I do not need a for each loop, and I'll not use a max element. Here I'll use I, J, and a temp, and use a for loop which has the iteration element I and initialize it to 0, then I less than the length of the array, and then I plus plus. So open the brace and then close it. So this is the first outer loop, then inner. For inner, I'll use another for loop. And j is equal to I plus 1. We'll see why we are doing this with a sample just in a minute. And then I plus plus. And then open and close. And we have to check if A of I is greater than A of j. If that is true, we need to swap the places because we have to do the ascending. So for that reason, we have to put the smallest value the first, then so on and so forth. So here I'll use temp and assign A of I to retain the value present in the I, then assign A of I is equal to A of j, and then finally A of j, I'll assign the temp, which is the initial A of y, A of I value. So for printing the elements, so I'll reuse the same thing, except the fact that the array elements are now after sorting. So let me save this and try to use a simple example to demonstrate how this is gonna work. For example, I have, say for example, I have 4 elements, 5, 2, 6, and 3. And the 5, 2, 6, and 3. And let's write down the positions of these elements. This is 0th, 1, 2, and 3. And for the first time, we have I equal to 0. And j is equal to I plus 1, which will be 1. And now a of I is a of 0, and a of j is a of 1. So this is 5 greater than 2. This means this if condition is true. So now we have to swap. So this will have 2 now, and this will have 5. So now j is incremented to 2. Then now a of 0 is having 2 in it, and then a of 2 is having 6 in it. And a of 0 greater than a of 2, 2 greater than 6, this is not true. So we don't swap the positions. Then next we have j, I is still 0, and j is 3. And a of 0 is 2, and a of 3 is 3. 2 greater than 3, this is false, and we don't swap anymore. So what we are doing is we are trying to compare it with the second element, then the third element, then the fourth element. So now we will go to the outer loop. Now I is having 1 and j is having 2. So a of I, that is a of 1, greater than a of j, which is a of 2. A of I, a of 1 is 5, greater than a of 2, 6. So this is false. We don't swap it. Next, we have j is equal to 3 this time. So 5 greater than 3. This is true. So we have to swap. So now 3 will come here and 5 will go here. Then j will have 4, and we don't have j of 4, a of 4, so we will go to I is equal to 2 this time, and j is equal to 3. Now a of I, which is a of 2, 6, and greater than a of j, which is 6 is greater than 5, so we swap these two positions. So I'll write it here. We have 2 in the first place, 3 in the second place, Now we are swapping 5 in the third place and 6 in the fourth place. And then I is 3 and J is 4. So we do not have the size J of 4. We have only until position 3. So this loop will come out, and then we are trying to print the arrays after sorting. Let me clean this up and try to compile if this works the same way we wrote this program. Compile and execute, or my elements are like 5, 2, 6, and 3. So now it's sorted 2, 3, 5, 6. Let's take another sample. For example, 3 elements, 1, 2, 3, 656, 233. Yeah, it is sorted. Let me get the result for this program. So let's move on and look at the next program, that is linear search operation. So let's reuse the same program to take the size of the array from the user, read the elements from the user, just print the elements, and I don't need, I'll just say array elements are, then I need to implement the linear search logic. So what does it mean by linear search? For example, let's say if I have an array, something like 10, 20, 30, 40, and I'll ask the user to enter a key element, for example, say 50. So we have to see if this 50 is present in that array or not, and just tell the user. So after I print the array, I'll ask the user to enter the key element. So I'll just type print measure of new line. I'll take as the same line, enter the element, and then read the key element with a variable key and obj name dot next int. So now what I have to do is I have to see if that key element is present in the array or not. For that, I'll use a Boolean result and initialize it to false. Then I'll use a for loop So for I, int I is equal to 0 and I is less than the length of the array and I plus plus. And in the if condition, I'll just see if key is equal to the a of I, which is that current element. And if that is true, I'll just say result is true, which means that the element is present in the array. And I'll use a break and do not check the other elements. Close the if, then close the this is an extra flower bracket. So here, if result is true, then I'll write a statement, something like the, or maybe just say element is present in the array. Else, I'll write element is not present in the array. So let's try to see how this logic works. The example we have entered 10, 20, 30, 40. The first time 10, 20, 30, 40. And let's write down the positions for this. 0, 1, 2, and 3. So the first time I is equal to 0. So A of 0 is going to be 10. Then key is 50. It's not true. Then it will go for the next element A of 1, which is 20. And 50 is false. And A of 2, which is 30. And is equal to 50 is false. Then go to the next one, 40. Then still false, then it will print element is not present. Say for example, if I take the element, key element as 30 and A of 0, 10 compared to 30, 20 compared to 30 false, 30 compared to 30 which is true, then it will go inside the if loop and result is true and then break here and print this message. I missed semicolon here. Let's try to compile, execute this program, and enter size 4, 10, 20, 30, 40. And enter the key element 50. It's not present. Let's rerun it and test it. 4, 10, 20, 30, 40. Key element is 30 this time. Element is present in the array. Let's move on and look at binary search operation. So there is a limitation with linear search operation because if the array size is like, say, for example, 1,000, then linear search, we need to search more number of times. So for example, I have an array of size 1,000 and my key element is, say for example, which is 999, which is at the 999 position. So with linear search, I have to do 1,000 iterations in this loop to find out the key value, whether it is present or not, which is the limitation of the linear search. And just imagine if it is 100,000 elements. For that reason, we can go for binary search. So what happens in binary search? Say, for example, I have 1,000 elements in an array. What we will do is we will divide the 1,000 elements into half, which is like at the 500, and we will see if the key element is present this side or this side. For example, if I have key element on this side, then we will ignore all these 500 elements and we will only consider this 500. And then we will further divide it into half, which is 250 here, and see if the key element is on this side or this side. And for example, it's not there this side and it's there here, then we further divide it into 125 and so on and so forth until we reach to the key element at some midpoint. This way we will decrease the number of iterations. For example, let's count the iterations. Just for the counting sake, I'll take an array of size, say 100. So I have array of size 100, I'll divide it into 50, and then further divide it into 25, then further divide it into half, 12, further divide it into 6, and further divide it into 3, and then further divide it into 1. So 1, 2, 3, 4, 5, 6. So in 6 steps, I'm trying to locate the key element in the binary search. For example, if I have to go for a linear search and the key element is at the 99th position, then I have to do 99 iterations. So to avoid the number of iterations, we will go for binary search. So let's directly see one example program how binary search works. Let's reuse the same program and use the logic to write the binary search. So Boolean result is Boolean result is false. And here I'll declare some integers like low, high, and mid. We'll see why we use this. Low, we will assign a 0, which is like 0th position in any array. And then high, we will use the length of the array that the user enters -1 to get the last position. And then we will use a while loop and see if low is less than or equal to high, then we take the mid as low plus high divided by just to calculate the mid position. And then if the A of mid is equal to key element which user provided, then we will declare that result is equal to true, and that is the key element and the array is present. If not, then else if the key is less than A of mid, then we will assign high is equal to mid minus 1. Then if not, else we will assign low is equal to mid plus 1. So we have to move to the next half. We will see this how it works using an example. And if the result is true, the element is present in the array, and result is false, then the element is not present in the array. For example, let's take one simple array which has, say, for example, 1, 10. Okay, I missed to cover one important aspect in the binary search. For binary search to work, the array should be in the ascending order. Otherwise, the binary search will not work. So as soon as the user enters the array, we need to sort the array. And for sorting the array, we have a special function called sort, and it will sort the array in the ascending order. And this is the limitation of the binary search. So we have to sort it before we start the binary search logic. So this will sort the array whatever user has entered. So for example, user assume that, or maybe user entered the array normally, but after sort, we will get something like 10, 11, 12, 13, 14, and 15. We'll try to take the positions for this array. So 0, 1, 2, 3, 4, and 5. So for the first time, we have low is equal to 0 and high, the length of the array is 6 minus 1, which is 5. So 0 less than or equal to 5. This is true. And here we need to calculate the mid here. So let's write down low is equal to 0, high is equal to 5, and then mid is 0 plus 5 divided by 2, which is an integer division. So we have 2 and of 2.5. So now A of mid, which is A of 2, let's suppose the user entered the key element as, say, 15. So now the low is having 3 and see 3 is less than or equal to 5, which is true. Now the mid is low plus high, which is 4. So now A of mid, which is A of 4, is 14 and is equal to 15, which is false. So it will check if the key, which is 15, is less than A of mid, which is 14. This is also false. And then now the mid is 4 plus 1. So then now low is having 5 in it, high is having 5 in it, and then mid is 5 plus 5, 10 divided by 2, which is 5 again. So now let's see, low is 5 or equal to high, which is 5. This is true. Then it will look for mid, A of 5 this time, which is 15, and is equal to key 15, and the result is true, and then we'll break the loop. And then we'll print element is present in the array. Let's clean this up and try to execute this program here. Compile, execute. I have 6 elements. I have to enter 10, 11, 12, 13, 14, 15, and enter the key element. 15 element is present. Let's rerun it and say I have 6 elements, 10, 11, 12, 13, 14, 15. And this time my key element is 9, element is not present. This is how binary search works. Let me get the sample results. Let's move on. So this time I need to implement a Java program to find some of first, last, and second, second, last, and so on, so forth. So this is the requirement for our next program. So what does that means is, for example, I have 1, 1, 4, 8, 2, 6. Then my output should look like 1 plus 6, that is 7. Then 1 plus 2, that is 3. Then 4 plus 8, that is 12. Let's see another example. 1, 2, 3, 4, 5, 6. So the output should look like 1 plus 6, 7, 2 plus 5, 7, 3 plus 4, 7. So this is the requirement of our program. So let's try to implement this. We will reuse the scanner to enter the size of the array, then enter the elements of the array, then print the array as is. We don't need to read any key element in this case. Also, we don't need to sort the array, and we don't need the binary logic. Remove this and also remove this. So now I will declare int low is equal to 0, and then int high is equal to a dot length minus 1. That's how I'll get the lowest and highest values of the array. Then while low is less than or equal to high, then open and close the while loop. I'll use System.out.println and add a of low plus a of high. Then I'll add a space just to mimic the array. Then I will do the low plus plus. So I'll move to the right, and high minus minus, which will move to the left. Let's take one simple example to demonstrate this logic. For example, I have 1, 2, 3, 4, and try to give the positions for this array: 0, 1, 2, and 3. I have low as 0 and high as the size of the array is 4 minus 1, which is 3. So low is 0, high is 3. So I'll add a of 0, which is 1, plus a of 3, which is 4. This is going to be 7, and then a space. For the next iteration, low will be 1 and high will be 2. So now low is less than or equal to high, and now low is a of 1, which is 2, plus a of 2 is, this is going to be 5, space 5. So it will print 5 space 5. Now low will be 2 and high will be 1. Now low less than or equal to 1, which is false, then the loop will exit. Let's compile and run this program. Size of the array 4. I have 1 space 2 space 3 space 4. So the output is I've just used print ln. I have used print just to make sure it is present in the same line. Compile, execute. 4, 1 space 2 space 3 space 4. The array is 1 2 3 4 and it is 5 and 5. And for example, if I use another sample this time, 6 elements, 1 space 2 space 3 space 4 space 5 space 6. Then we got 7 7 7. That's how we can add the first and last and second last and second last, so on and so forth. So one last program we will see for the wind-up. Let's try to reverse the array elements. So the requirement is straightforward. We have to reverse all the elements that the user enters. So we will use reuse until reading the elements. And what we have to do this time is we'll use low as 0 and high is a length -1, while high less than or equal to low, we will declare an integer temp, which is used to retain the value of a of low, assign a of high to the a of low, and then assign a of high to the temp, which is a of low, which essentially reverses the array elements, and we will move low to the right side and high left side by minus minus. So finally, we use the same print statements to print the array elements after reverse and array elements before the reverse. Let's try to compile and run this program. Array elements, I have 4. I have 1, 2, 3, 4. So 1, 2, 3, 4, 4, 3, 2, 1. Let's take another example. Say, for example, I have 7 and 7 space 6 space 5 space 4 space 3 space 2 space 1. So the reverse is 1, 2, 3, 4, 5, 6, 7. This is how we can reverse the array elements. Let me get the output here. I'll stop here and continue. In this session, we will try to uncover strings in Java. It is also called as string data structure or just string.
String is a collection or group or sequence of characters. String is treated as an object in Java. And it is also the most commonly used object in Java. So for example, let's look at voter management system. Let's call it as VMS. So we will have voter ID and it will be an integer. And you will have name that's going to be a string. Then you will have maybe county, that's going to be a string. You will have, say, for example, city, that's also going to be a string. You will have phone number, that's also going to be a string. You will have address, that's also going to be a string, so on and so forth. So if you look at this example, you might notice that string is the most commonly used object in Java. So I can say 90% of data in any Java application is going to be string. So for strings in Java, predefined string classes are available. We just need to use them. The next point is Java provides strings in 4 forms based on the requirement. So the first one is java.lang.string. Second one is java.lang.string buffer. The third one is java.lang.string builder. The fourth one is java.lang.string tokenizer. We will uncover as we progress. Also note that in Java, there are two types of string objects. What are they? One, immutable string objects. So what are immutable string objects? Modifications are not allowed on these. What is the second type? Second type is mutable string objects, and modifications are allowed. String class objects are immutable objects. So in other words, this class. Mutable objects. If we are trying to perform any modifications, it won't accept those. But with those modifications, a new object will be created. We will see what is this in an example in a while. This concept is called mutability. So let's see an example program so we understand this better. I'll get rid of all of this except, okay, we don't need this class. Class does static public void main string arguments. Let's say string s is equal to new string of a, b, c. And let's try to print this string s. And obviously it will print a, b, c. So let's try to concatenate a new string to it. Concat is used to add new string into existing string. So let's say s dot concat and concat def. So if I try to print s again, it's gonna still print ABC. We will see why. Let's try to execute Java C test dot Java Java test. It's going to print ABC, ABC. We'll see what's going on behind the scenes. So when we create a string object, it will create an object and it will contain the string ABC. And we print and it will print the ABC. And then when we concat DEF, like we discussed, like we discussed here, string is an immutable object. When we try to perform any modifications, a new object will be created. So what happens here is when we concat DEF, it will concat ABC, DEF, and a new object is created. But regardless, our S is still pointing to ABC. So this will be created, but it doesn't have any reference. So when we print S again, it will still print ABC. So now let's suppose what we need to do if we want to print A, B, C, D, E, F. So then we have to go for string buffer class. This is our second class in strings. So you copy this sample example here and also result in our notes. So string buffer class objects are mutable. And if we are trying to perform any modifications, it accepts those modifications, but with those modifications, a new object won't be created. In the string class, it will be created, but in this case, it won't be created. This concept is called mutability. In other words, modifications are allowed. So in the example here, if we just say string buffer, and let me rename this as SB and new string buffer, and then try to print SB before it will print ABC, then instead of concat, we need to use append. Append is used to add a new string to an existing string buffer. So sb.append def, and then if we try to print sb again, this time it will print a b c d e f. Let's try to compile and then execute. So this time we see ABC and ABCDEF. That is the difference between string and string buffer. So we also have string builder. String builder is also same as string buffer. We will see what is the difference in the upcoming advanced Java classes, but for now, string buffer, string builder will also do the same thing. String builder, SB, and string builder ABC. Then let's say A, B, C, D, E, F, D, H, so that we see the difference in the result. So here, the result will be A, B, C, D, E, F, G, H. Let's try to compile this. Execute, and you'll see the result A, B, C, D, E, F, G. Let me take this example result, put it in our notes. So let's move on. String buffer objects are synchronous objects. That is, only one thread is allowed. So Java is a multi-thread programming language. So we have to use string buffer when we have to allow only one thread. So string builder objects are not synchronous objects. That is, multiple threads are allowed. So let's try to see one real-time example where we will use string buffer and where we will use string builder. So string buffer is a single thread situation. So for example, if you are trying to reserve or book a ticket for a movie or a flight or train. So when you try to book and you select a seat, you should not allow other thread to book the same seat. So in that situation, you will go for a string buffer and string builders. Let's say you have given a test and you wanted to check the results on the day of the results. So test results database, it's not single thread. You can, I mean, multiple students can check the results simultaneously. So in that case, multi-threading is allowed and you have to go for string builder. Let's look at the last class, which is string tokenizer. It is used to divide the strings into tokens. So for example, if you have a string something like A, B, C, D, E, F space, I, J, K space, M, N, O, P space, W, X, Y, Z, then when you tokenize, you will see like A, B, C, comma, D, E, F, comma, I, J, K, comma, M, N, O, P, comma, W, X, Y, Z. So we'll see as we progress more samples on string tokenizer. We will move on and uncover heap memory area and SCP memory area. So heap, whenever an object is created, it will create in heap only. What is SCP? SCP is string constant pool. So let's take examples. For example, case 1, if I say string s is equal to new string of, say, John. Let's see how many objects will be created in a heap and how many objects will be created in SCP area. So always remember, whenever we are creating a string object using double quotes, it will create an object in SCP. And whenever we are creating a string object using new, then it will create an object in heap. So in this case, we have heap here, and then we have SCP here. So we have created string s equal to new string of double quotes John. As soon as double quotes is used, it will create an object here, say John. And then here we have used a new keyword. So it will create an object in heap also. So one object is created in heap and one object is created in SCP. Now let's move on and look at case 2. In case 2, what I'll do, I'll use string s equal to directly assign string John this time. So what happens? We do not have a new keyword here. So the heap John will not be created. It will be created in SAP because we used double quotes. So let's see the count here. Heap will be 0 and SAP will be 1. Now let's move on to case 3. Say, for example, I have string s1 is equal to new string of ABC. Then let's say string s2 is equal to new string of ABC. Let's say string s3 is equal to ABC, and then string s4 is equal to ABC. So let's now see how many objects will be created in heap and how many will be created in SCP. So first we have string s1, this one. As soon as you see double quotes, it will create an object here, which is ABC. And then you have a new here, so it will create an object here in the heap as well. The next, you have s2 string and you have double quotes ABC. So pay attention here. Whenever there is an object which is already in SCP, JVM will make sure no duplicate objects are created in this SCP area. So here line 4544 S2 string ABC, it's already there. So both S1 and S2 will refer to the same object. No new object will be created here. But here, as soon as you see the new, it will create another object, A, B, C. And then string S3 is A, B, C. So it's again, there is no new string here, it's already there. So S3 also will be pointed to this, and then S4 also will be pointed to here. So we have two objects created in SCP, and we have one object created in two objects created in heap and one object created in SCP. Now let's see System.out.println let's check if S1 is equal to S2. Let me denote this one. This one is S1 and this one is S2. So if I'm trying to equate S1 and S2, are they equal? No, their reference points are two different objects. And similarly, let's see S3 is equal to S4. Yes, because in SCP we are referring to the same object. So for the first one, it is two different objects, so it's false. For the second one, it's the same SCP area, so it's true. So let's try to execute this in a program. Compile. Uh, this is system out. System.out.println. System.out.println. Compile. I didn't save this. Compile. Execute. So the first one is false and the second one is true. So object creation in SCP is always optional. First, JVM will check if there is any object with same content. Then no new object will be created. Existing object will be reused. So there is no chance of two objects with same content in SCP. Which means that duplicate objects are not allowed in SCP. Now let's move on to case 4. So case 4, let's say string s equal to new string of ABC, and then let's concat DEF. And s equal to s dot concat of x, y, z. And then let's try to first investigate how this is going to work in both heap and SCP areas. So for this case 4, as soon as you see double quotes ABC, it will be creating an object in SCP area which has ABC inside it. And as soon as it sees a new keyword, it will create an object here in the heap area, which is ABC. Then what we are doing is s.concat, and s is a string which is immutable. So if you're doing a modification, it will create a new object, and the new object will have ABC, D, E, F. And remember, S is pointing to this, but this one doesn't have any reference as of yet. Now, in the line 3, as soon as you see double quotes, it will create an object here, X, Y, Z. And you see you're doing a concat here. So it's immutable. So what it will do, A, B, C, X, Y, Z. And here you're trying to reassign S to the new string. So this will be gone and S will be now pointing to A, B, C, X, Y, Z. So also remember there is another double quotes here. So SCP will have DEF object as well. So let's try to count how many objects are present in SCP and heap. 3 objects are there in heap, and we have 3 objects in SCP. Now let's try to print system out. Println and print S. So as we have seen, S is reassigned, which will have now A, B, C, X, Y, Z. Let's try to put this in the program and execute. Save, compile, you'll see ABC XYZ. I'll also put the result here. Now let's move on to, say, case 5. What I'll do, I'll take a string S1 is equal to new string of spring. Then I'll use S1 dot concat, say all. Then I'll use string S2 is equal to S1 dot concat of winter. And then I'll do S2 dot concat summer. And then System.out.println S1 and then System.out.println S2. So let's try to see how this works out both in SCP and so as soon as you see something in the double quotes, it will create an object here in SCP area. And then as soon as you see a new keyword, it will also create an object in heap. And S1 is pointing to this. Then the next one is fall. As soon as you see it in double quotes, it will create an object here in SCP, and string is immutable, so it will create a new object which will have spring fall. And then you see another object in double quotes which is winter, and you're assigning S2. So for example, we have the object created in heap, which is spring concatenated with winter. So this will be created and S2 will be assigned to this. And next, as soon as you see summer, you will see summer will be created here, and S2 is concatenated with summer, and string is immutable, so it will have spring, winter, summer. But still our reference is S2 is still pointing to spring, winter. So when we print S1, we should see spring, and then when we print S2, we should see spring, winter, regardless how many objects got created in SCP and heap. But let's try to put the number here. In heap, we have 1, 2, 3, 4, and SCP area, we have 1, 2, 3, 4. Now let's try to test this program. compile, execute. You'll see spring and spring winter. So let me summarize everything that we have discussed so far. Let's summarize this in case 6. The first point is whenever we are creating a string object using double quotes, an object will be created in SCP. Then whenever we are creating a string object using new keyword, object will be created in heap, and object creation in SCP is always optional. First, JVM will check if there is any object with same content, then no new object will be created. Existing object will be reused. And duplicate objects are not allowed in SCP. We will stop here. So this is string part 1, and we have covered introduction to strings. Then we have covered mutable and immutable. Then we have covered heap and SCP. In this session, we will try to continue to uncover strings in Java. Let's see the difference between double equals and dot equals method. Double equals is meant for reference comparison. It returns true if two objects are pointing to same reference
else it returns false. Dot equals method is meant for content comparison. If it returns true if two objects are having same content, else false. Double equal to is an operator which is used in primitives and objects. Dot equals is method which is used only for objects. We will see different examples. So first, let's take a simple example. Let's say string s1 is equal to new string of say Java. And then let's say we have another string called s2, new string Java again. And we have another string s3. This time let's take uppercase J. So for example, if s1 is equal to s2, let's see what it returns, and s1 is equal to s3. Also, let's try to use the equals method of s2, and then s1 equals s3. So first, string s1 is Java, then string s2 will create another object with Java, then string s3 will also create another object with an uppercase here. So like we discussed, double equals to will try to compare the reference. So s1 is equal to s2, which is false because these are two different references. So we will get a false here, and then string s1 is equal to s3, which is also false, and string s1 dot equals method s2, as we discussed, it will compare the contents. So it is lowercase java, s2 is also lowercase java, this will return a true, and string s1 is lowercase java, s3 is an uppercase java, this will return a false. So let's try to run this to see if we are getting the same result. Compile, execute. So false, false, true, and false. Now let's move on. In Java, all the strings are divided into four types. One, Java dot lang dot uppercase is one. Two, Java dot lang dot string buffer. Three, Java dot lang dot string builder. Four, Java dot lang dot string tokenizer. So let's first explore the first one, Java dot lang dot string class. If the content is fixed and never changes, then we should go for string class. It is immutable and modifications are not allowed. So let's explore constructors. In the string buffer, in the string class. So the first constructor is string s equal to new empty string. Then next one is string literal, in other words, constant. Then we can also use a character array, and we can also use an offset with count.
Next one is we can take a byte array and also we can use an offset with the size. The next one is a string buffer. Next one is string builder. Let's uncover each of these. So the first one, so let's say string s equal to new empty string, and let's try to print s. So this will be an empty string, and then let's say, for example, length of the string. Then let's also say s dot is empty. Is empty, it's gonna be true. Length of the string is 0 because we are using an empty string. Let's try to compile. And run this. So you will not see the empty string. The size length is 0 and it's an empty string, so it's true. Now let's look at the next constructor, which is string literal. For example, if I'm just taking Python, if I print it, I should see Python here. If I print the length, I should see 6. And is it empty? It's going to be false. Let's try to compile. Execute. Also remember, if we declare a string s equal to and assign the string directly, it's gonna save it temporarily in SE. But if we declare
string s equal to new string of Python, then it's gonna save it permanently in the heap. Let's look at the next constructor, which is a character array. So for example, if I have a character array, ch is equal to, let's say, w, comma, e, comma, l, comma, c, comma, o, comma, m, comma, e. And then let me write down the positions of this array: 0, 1, 2, 3, 4, 5, 6. So for example, if I assign string s is equal to new string and assign the array here, and if I try to print string s, it's going to print welcome. Let me compile. Let's look at the next constructor. The reason I have written positions here is to see how it works while using offsets. So for example, if I have string s1 is equal to new string of character array ch, and if I have string ch3 comma 4, and let's say for example if I have 0 comma 2, and then let's say if I have 5 comma 2, and let's try to print each of these strings: s1, s2, s3, and s4, and s1, s2, s3, s4. First one will print the entire string, which is welcome. The second one will print from position 3, and the size should be 4. From position 3, and size is 1, 2, 3, 4, which is until 6. So the second one print come. And the third one is 0 to length 3, length 2. So we should see not position but length. So we should see a V here. And from position 5, length 2, that's going to be ME.
Let's try to execute. See, welcome, come, we, me. Let's move on and see next constructor, which is string s equal to new string byte array. It converts the given byte array into string by using platforms default character set. We'll see what that means in a minute. So for example, if I have a byte array, say 65, 66, 67, 68, 97, 98, 99, 100, 48, 49. So the positions will be 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, for example, what is the string equivalent for 97? What is the string equivalent for 65? That's going to be uppercase A. I mean, character equivalent for 65. And then what is the character equivalent for 48? That's going to be 0. Now let's try to print the string s1 is equal to b. Let's try to compile, execute what this returns. String s1.
What? No.
I have not changed the variable name to be. Compile, execute. So this is the result. We print the byte array. Now Let's use the offset for this. So convert the given byte from given offset value into print.
What? Yeah. Okay. Do you want a thumbstick?
So let's say if string S1 is B and then string S2 is B 0 to 4, then string S3 is 4, 4, and string S4 is 8
Green.
to size 2. So this is gonna return print all the strings S1, S2, S3, and S4. So the first one will print the entire character string. Second one will print from position 4
Girl, I'm doing every round. Because this.
string S1 will print entire character string. S2 position 4 till the next 4 positions. So 1, 2, 3, 4. So this is S2 is 0 to 4. So 0 and we have 4. So S2 will print A, B, C, D uppercase. Then from 4 we have 4 positions, so it's gonna print lowercase a, b, c, d. Then for string S4 from 8, 2 positions, so the last 2, which will be 0 and 1. Let's try to compile. Execute. Now let's look at the next one, which is string buffer. Say, for example, I have string buffer FB is equal to new string buffer is John. And string S is equal to new string SB. Let's print SB. It should print John. And let's print as it should print John. However, this string builder is mutable, but this John or string is immutable. Let's try to compile execute. Like I said, you'll not see the difference, but one is mutable, the second one is immutable. The last one is string builder. What is the difference between string buffer and string builder? String buffer, we allow only single thread, no multi-threading, but string builder SP string builder John, it is multiple threads. Multiple threads is allowed for builder. Here it is single thread. And the output will look the same. So far, we have uncovered constructors in string class. Now let's move on and see methods in class. First one is int of length. So let's say we have string s is equal to say hello. And if I print s, it's going to obviously print hello. And if I print s dot length, it's going to print 5. Let's compile and execute. The next one is Boolean and is empty method. So the first one is string, let's say s1, hello, and string s2, let's take it as an empty string. And let's try to check s dot s1 dot is empty. It's not. So it's gonna be false. And Let's check it for S2, which is an empty string. It should return true. Compile, execute. The first one is false, the second one is true. Let us continue to uncover strings. Let's look at the char at method. So char method returns char present at given index value, and if the index is out of range, then it will generate string index out of bounds exception. So let's see example. So here I have string s equal to new string hello, and if I print s dot char at index 0, then it should print age. If I do it for 1, it will print e. If I do it for 2, it will print L. If I do it for 3, it prints L again. If I do 4, it will print O. Let me compile this. C should be lowercase. Let's compile. Execute. Hello. Now let's move on to the next method, which is string concat. What it does, it concatenates two strings into a third string. Let's see one example, what that means. So I have string s1 is equal to string hello. I make this as uppercase H, and string s2 as word, and Say for example, if I print S1, I should see hello. If I print S2, I should see world. If I print S1 plus S2, I will see hello world. If I do S1 dot concat of S2, that will also essentially do the same, print hello world. If I do S1 plus, I would like to put some space in between and then do S2. This time I'll have a space in between hello world. And if I have to do the same using dot concat method, I will just use space first, then dot concat s2, which will print hello world. Let me save. File. Execute. Now let's move on to the next method, Boolean equals. Method. It will take it string input, returns true if the content of two string objects are same, else false. It compares two strings by considering case. In other words, it's case sensitive comparison. So let's see with example. For example, if I print ABC dot equals of A B C. This should be true. And so let's say take another, which is uppercase, is gonna be false because it's case sensitive comparison. And if I say maybe X, Y, Z, it's gonna be false again. And then, for example, let's say if I compare it with M and O, it's gonna be false again. So let's try to compile, execute, true, false, false. That's what we were expecting. So for example, if I wanted to ignore the case, then we have another method, which is Boolean equals ignore case. So it returns true if the content of the two strings are same. It compares two strings by ignoring the case insensitive. Let's change this to equals ignore case. And let's do same thing for all of these. Save it. File. By the way, this should be true this time. True, true, false, false. And let's move on. For example, if I have a string and make it to lowercase, we have another method called lowercase to lowercase method. So what it does, it converts given string object into lowercase letters. Let's look at one example. For example, if I have A, B, C, D, E, F, and I need to make it lowercase, then I use lowercase method, and I don't need the input. And it will print A, B, C, D, E, F. Let me compile. Execute. If I want to do the uppercase, I have another method called uppercase. Converts the given string object into uppercase characters. So let's change this to uppercase. This will be here, and we just read it with lowercase. Save it. Compile. Execute. Let's move on. We have another method called trim.
it will remove spaces from the beginning and ending of string. So let's take one example. Let's say I have a string S1 is equal to admit, and I have another string S2 is equal to admin with space at end. Then I have another string S3 with space at the beginning. Then I have another string with space at the beginning and the end. And if I try to print S1 string, it will just print as is because we don't have any spaces. If we do the print for S2, we will again print admin. It will, if I have space in the beginning, it will again trim it. If I have space both the beginning and then it will trim again. Let me also take another string S5, and this time I'll have spaces in between just to demonstrate how trim works. It only trims the beginning and the ending spaces. Execute. I forgot to print the last print. It will print something like this. Let me recompile and execute again. Yeah, that's how trim works. It only removes the spaces in the beginning and in the ending. Next, we have string substring. And we should give int and start. Extract a substring from the given start index. We also have end index, say for example, substring, string start, comma, end. Then we extract a substring from the given starting index to the end x -1. Let's see how this works with an example. So if I have a string s, and let's say I have AB space, ABC space, ABCD space, ABCDE. So let me try to give the positions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3.
1, 2, oh, I missed the 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is this one. So I'll remove that. Now let's come from the entire strip. Let's print just S. So it should print the entire thing here. Then, sorry, here. Then I'll print S dot substring and give the start index. So if I say 3, it will print from here till the end, from position 3. And for example, if I give say 12, 12 is this, so it should print from here till the end. And let's say if I give 7, then it should print from here till the end. This time I'll use the start index and the end index. 7 to 11. So it should give index -1, which is 10. This is the part that you will get. Let's compile. What did I miss? I missed closing braces for everything. Let me save this, rerun, recompile, and then execute. That's what we expected. Let's move on. Next method is string replace. And we have to give char and old char, then we have to give the new char to replace. So let's see how it works. It replaces all occurrences of a char into new char. Let's see. Example. Let's say, for example, I have a string called. I don't need any positions here. I'll just print string itself first. Then if I do the replace and I will give the old character replaced with new character. So I essentially print no. Let me file this. And I'll get the new string as no. Let's move on to the next method, which is string replace all. We should give a string regular expression
then string replacement. So it replaces all occurrences of a string using regular expression. So let's see one example how this works. For example, if I have a string, something like welcome to Java, and I'll print the string itself. So it will print welcome to Java. Then if I print replace all and say if I want to replace all the vowels A, E, I, O, U with say star. So what I will be printing is W. E is a vowel, star, L, C, O is a vowel, star, M, star, space, E, star, Ja, star, V, star. This is how my output should look like. Compile. Did I miss here? I missed an additional L. Compile and execute. I'll get the result I've expected. Can also do the inverse. So if I want to retain vowels and replace everything else with stars, it will, let's do for us. Let's execute and see the result. I'll execute. So we will retain all the vowels in this case. And say, for example, if I want to change all the spaces to just hyphen, let me compile and execute this. I missed the regular expression, flower brace, square brace here. Compile, execute. So you'll have hyphen in between the words. Let me save program and also the result. Let's move on. We have Boolean contains string. So it will return true if the given string is existing in the main string, else false. Let's see an example. So I have to use s dot contains. Say for example, if I have Java in the original string, it should be true. So let me also check for another string which is not there in the main string, say for example, Python. And it's gonna be false. Compile, execute. Yeah, Java is present true, Python is not present, so it's false. Next method is Boolean and starts with and print itself. So returns true if the given string starts with specified string, else false. And the other method is ends with. Ends with returns true if it ends with. Let's say, for example, I have a string s, and say Java is very easy. And if I print the string itself, it will print Java is very easy. And if I say starts with Java, then it should be true. And if I do start with Python, it's going to be false. Let me do the ends with. Ends with easy, true, ends with difficult, false. Let me just compile. Execute. Java is very easy, true, and it starts with Python, false, easy, true, difficult, false. Let's move on. The next one is index of. So it returns first occurrence of the given substring. And we also have last index of
last index of, and it returns the last occurrence. So let's say, for example, print AB, ABC, ABCD, AB, D, E, then say index of A, B, C. So 1, 0, 1, 2, and then third position you found an ABC. So you will see 3 here. And let's do ABC, ABCDE index of, for example, M and O. And you don't see anything, so it should return a -1. And for example, if I do the last index for ABC, last index of ABC, then you should see 0, 1, 2, 3, 4, 0, 1. Maybe I'll just position them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you will see at the 12th position the last occurrence of ABC. And you can also do something which is not there. Last index of, say, MNO, it will also return a -1. So let's run this file. What is the mistake? I'm not closing it again. My println statement. That's fine. Compile. Execute. So at the third position, -1, 12th position, -1. The next one is string split, and we should give a delimiter. It divides the given string into tokens based on delimiter. So let's see one example. Say if I have string array s equal to ABC hyphen df hyphen dhi hyphen ijk hyphen lmnop hyphen wxy and dot split with hyphen now let's use for each string print System.out.println ss. So it should print all the string tokens now. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, W, X, Y, Z. Now let's see the next method, which is join, and use a delimiter and s1 comma s2 comma s3 comma s4 comma so on and so forth. So what it does, it creates a new string object by combining all strings with the provider delimiter. So let's say print string dot join, and I will end this also all the time, making that mistake. So string, say for example, space and then Java Python PSA logic based programming. And I'll also use another string join with hyphen as a delimiter. Let me run this, compile, execute. The first one will generate join with a space. The second one will join with hyphen. The next one is a byte array, get bytes method. So it converts given string into byte array. Let's see an example. String s is equal to A, B, C, D, and byte
array E is equal to S dot get bytes and let's print string itself, and then let's also print arrays to string of B. That's file. What did I miss this time? Okay, I have to use the util function import java.util plus file. So it will print the byte equivalent of A, B, C, D as an array. Now let's move on to the next method, which is char array. What it does, it converts given string into char. It converts given string into character array. Let's look at another example. So here we will see char C is equal to two char array. And the C. I'll execute. So you will see the same string characters in a character array. Next, we have compare to method, which is used to compare two strings. It will compare two strings, two string objects, and returns integer value. We also have compares and ignore the case. It will compare two string objects by ignoring case and returns integer value. So how compared to pairs is character by character. So in Java, compares two strings lexicographically. Based on Unicode values of characters. So let's see one example quickly. So println, I have IJK are compare to A, B, C. Let me run this and see how it works. Compile. I'm doing the same mistake again and again. I got to close the println. File. Execute. So how we got this 8? Let's see how we got this 8. So like I said, it compares character by character. The first character in the first string is I, and the Unicode value is 105. The first character in the second string is A, and the Unicode value is 97. So if you subtract 97 from 105, the result is 8. Let's say if I have IJK compared to IJK, then you should see a 0. And we can also use the ignore case, compare to ignore case, uppercase IJK. This should also give us a 0. So that's how compared to ignore case works. Let's look at one last method, which is string formatted. And it is same like string dot format. It was introduced
in Java. So for example, if I have string s string s is equal to my name is, say for example, personnel s, and it is, say, personnel d dot formatted, and I'll give the name as John and age as 6/7. So let me print just s. Let me compile. I did extra this time. Compile, execute. My name is John and age is 6/7. I'll stop here. In this session, let's try to uncover string buffer class. When do we go for string class? If the content is fixed and never changes, we go for a string class. For string buffer, we go when if the content is not fixed and keeps changing. We go for string buffer. Let's uncover some constructors present in string buffer. First constructor is string buffer SB is equal to new of string buffer. So what does it do? It will create a new string buffer object. And the default capacity is 60. Let's try to see an example. String buffer SB is equal to new string buffer, and let's try to print SB. Obviously it is empty, and let's also try to print the length of SB dot length. It will print 0, and
Let's try to check the capacity of this string buffer object. And like I said, the default is 16, so it should print 16. Let's try to run this program. Java C test Java compile Java space test execute. So it printed an empty string, the length is 0, capacity is 60. Let's look at the next constructor. String buffer SB is equal to new string buffer, and we can set the capacity using int and capacity. It will create a new string buffer object with provider capacity. Let's look at one example. For example, string buffer SB string buffer, and let's set the capacity as 55, and the length is 0, and the capacity is going to be 55. Let's try to compile and execute this program. It's going to print 55. Let's move on to the next constructor. String buffer SB is equal to new string buffer of given string. What it does, it will create a new string buffer object with given string literal. So when we give a string literal, the new capacity is not the default anymore. It is going to be 16, which is the default capacity, plus the length of the given string. Let's try to see one example. So for example, if I give string buffer A, B, C, D. If I print string buffer, it will print A, B, C, D. The length is going to be 4, and the capacity is going to be 16 plus 4, which is 20. Let's try to run this, compile, execute. Also, note that in the case of string buffer, the capacity will automatically be increased. So what does that mean? For example, if you have a string which is say for example string length is less than 16, the capacity will be 16. But if the string length is little over 16, say for example 17, then the capacity will be old capacity plus 1 into 2. Let's see some examples so that we get some clarity on this. For example, I have a string buffer SB is equal to new string, and I don't want to put any string as of yet. I'll put the empty string and try to print SB. It's gonna print the empty string, and if I print length, it's gonna be 0, and if I print capacity, then it's gonna be 16. This is the initial capacity, which is default. Now, let's say I have appended a new string to the string of buffer object. Let's say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So let's try to count these characters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I chose 16. So if I print the string itself, it will print string itself. Then if I check the length, it's going to be 16. And if I check the capacity, it's going to be 16. Now, let's say if I append Q to the current string. So it's going to print until Q, the length is going to be 17, but the new capacity is going to be 16 plus 1 into 2, which is 17 into 2, which is 34. So let's see. Let's compile this program and execute. So the new capacity of the string buffer is going to be 34. So that's the formula for the new capacity. New capacity is equal to old capacity plus 1 into 2. Okay, these are all the constructors we have covered so far. Let's see some methods present in string buffer. The first method is string int length, which we have already seen earlier, returns number of characters present in the string buffer. Next, int capacity. This also we have seen. Returns number of characters that it can accommodate. Next, we have Boolean is empty. We have seen this earlier. Returns true if the string buffer is having 0 characters as length, else false. The next method we have is void ensure capacity and new capacity. What does that mean? So it will increase the capacity of the string buffer to the given capacity, new capacity. So let's look at example. For example, string buffer SB is equal to new string buffer, which is empty. If I print it's empty, length is 16, and capacity is going to be 16. So if I say ensure capacity, and let's say 100, and I try to print again, it's going to be empty, the length is going to be 0, but the new capacity is going to be 100. So that's how we can change the capacity using this method. Compile, execute. The new capacity is going to be 100. Next method we have is void set length int and given length. It will set the length of string buffer. Let's see one example. For example, if I have string buffer SB new string buffer, and if I set or if I append welcome and try to print SB, it's gonna be printing welcome, and if I print the length, it's gonna be 7, and if I print capacity, it's gonna be 16. So this time I'll set length and say if I set it to 3, and if I print SB this time, I'll get only 3 characters because the length is only 3. And if I print the length of it, it's going to be 3. And if I print capacity, it's still going to be 16. Let's try to compile, execute. So you see the new length, it's going to be 3 because we set the length at 3. Let's move on to the next method, which is void trim to size. So what it does is it will reduce the capacity of the string object to the length of the string. It reduces the capacity of the string object to the actual size of the string. It does not change the content of the string. What does that mean? For example, if I have the string welcome, the length of the string is 7 and the capacity assigned is 16. So if I do trim to size, in other words, the size of the string is 7, length is going to be 7, the capacity is going to reduce to 7. So it actually saves the memory. So let's compile. Execute. The first capacity is 16. After trim to size, the capacity is 7. Let's move on to the next method, char at, and give the index. It returns character present at given index value. Let's see. For example, string buffer, SB new string buffer, append, or maybe I'll just set the string here itself. I don't use append. So print SB, it will print welcome. If I print char at 0, it will print W. If I print char at 1, it's gonna be E. Let's try to compile. Execute. The next method is void set char at and index char ch. Let's see what it does. It will update the char present at given location with new char. So what does that mean? So let's see one example. String buffer SB new string buffer welcome, and if I print SB, it will print welcome. And if I do SB dot set char at, and let's say 3 comma, A, and print SD again. What it does, 0, 1, 2, 3. Third position, C is going to be replaced by K, so it's going to print WLKOMA, welcome. Let's try to compile. I got an extra closing brace here. Compile. I'm not saving it. Compile. Execute. So that's how set char at works. Let's move on. Void delete char at, which is similar to the previous one. Here it will delete char present at given location. So let's see example. I have welcome and delete char at. So for example, let's say 4, then it's gonna delete 0, 1, 2, 3, fourth character, which is O. So it's gonna print that string right there. Compile, execute. That's how it works. The next one is void append object. It is used to append the given object at the end of string buffer. So for example, if I have string buffer, I will take an empty string for now. If I print, it's gonna print empty string. Then I'll do SB append, say AAA, then space. I'll do another one, BBB, do another one, CCC, and I'll do one easier like 999. And if I print SB now, I'm gonna get AAA space BBB space CCC space 999. Let's try to compile and run this program. Compile, execute.
Let's move on to the next method, which is void insert. And we have to give the index, then we have to give the object to insert. It is used to append the given object at the given location in the string buffer. So in this example, I'll try to do sb.insert and say fourth location 777, and I'll also add a space. So now if I print again SB, I'm gonna see 777 space here. Let's try to compile, execute. Let's move on to the next method, which is void delete and int. We have to give the start index and then the index. Delete all the characters from start, index, and index -1. So let's see how this works. Here I'll add delete, say 8, 12, and if I print the string buffer now, it's gonna delete from 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, from 8, 9, 10, 11. Gonna delete start index 2 and index -1. Let's see how this runs. Compile, execute. For example, if you have to delete all or entire string, so we do not have any function, something like delete all. So what we have to do is we have to apply some logic. So here I can delete from 0, or maybe I'll retain this one and take the next example here. On line 18, I'll set it at 0 to sb dot length. Then it's gonna delete the entire string. Let's try to run this
example, compile, execute. So if you see here, you have an empty string printed there, which means that it deleted all the characters in that string. That's how you can use delete to delete the entire string, as we don't have any such method called delete all. Let's look at a couple more methods. Void reverse. What it does, it reverses the given string buffer. So let's see the example. If I do the reverse here, reverse, and then print. Let's see what it prints. I'll execute. So it's going to reverse from 999 CCC 777 AAA. That's the reverse. The last method before we conclude this session, void replace and in start and give the string the S. So it replaces the string, basically the substring, from start to n-1 with given new string. So let's see one example here. Replace, say for example, 8 till 11 with, say, DDD. So what it does, 0, 1, 2, 3, 4, 5, 6, 7. This is 8. So it's going to change from 8, 9, 10, which is 11 minus 1. So it's going to return DDD instead of CCC. Let's try to run, compile, execute. That's how replace works. That's the end of this session. In this session, we will uncover the next string class, which is string builder. It is same like string buffer. Which was introduced in Java 1.5 version. It is a mutable object, and all constructors and methods present in string buffer are available in string builder also. And if the content is not fixed, keeps changing, use string builder. So if it is similar to string builder, string buffer, so what is the difference? So difference is string buffer is synchronized. Only one thread is allowed. If only one thread is allowed, you can use string buffer. And if multiple threads are allowed, you can use string builder. String builder is not synchronized. Multiple threads are allowed. Everything else is same. So let's move on to the next class, which is string tokenizer. It is process of dividing a string into tokens based on some delimiter. We are dividing string into tokens. Let's see some examples. Say, for example, I have a string called Java is very easy. And if I have to tokenize, it's going to return Java, is, very, easy. So here, default delimiter is space. For example, if I have A, B, C, comma, D, E, F, comma, E, F, J, comma, I, A, L, comma, P, Q, R, comma, W, X, Y, Z. And if we have to tokenize based on comma, then we will get these tokens. Stat space is here. So these are individual tokens. Let's say if I have some date like this, and then if I have to tokenize this based on hyphen, then it's going to give me 12, 31, 2030. So if I have time something like 000000, or maybe for the benefit of clarity, I'll just add like this. Then what I will get 00, comma 01, comma 45. This is how string tokenizer with a delimiter works. Let's look at some constructors under string tokenizer. The first constructor is string tokenizer st is equal to new string tokenizer of string. So it will tokenize based on the default tokenizer, which is space. We have another option to give the tokenizer, that is delimiter. So it will tokenize based on given delimiter. Let's move on to some methods available in tokenizer. First one is int count tokens. So it will count number of tokens. And let's move on. Another method called Boolean has more tokens. What it does, returns true if next token is available, else false. Another method, string next token. Return current token and transfer next token. We'll see some examples around these methods. So the first one is say, for example, if I have a string s is equal to Java is very easy to understand and practice. This is my string. So if I take a string tokenizer, st is equal to new string tokenizer and specify s. And if I count tokens, I get the number of tokens available. If we do not specify delimiter, it's going to be space. So 1, 2, 3, 4, 5, 6, 7, 8. So we should get 8 tokens. Compile, execute.
Now let's look at has more tokens sample. What I'll do, I'll use a while loop and say sd dot has more tokens. This is true. Then I'll print the next token. Next. So it will print all the tokens one by one. Let's look at that example. Compile. Execute. It's going to print the tokens one by one. So for example, if I do tokenize based on say E, which means that it will tokenize until here, then until here, and then until here. So now let's try to count the tokens. It's gonna count. Let's see how many we get. Compile. Execute. So it's gonna take until E, first E, second E, third E, fourth E. So 4 tokens, that's the count of tokens. It's the result here. So for example, let's say I need to develop an application which convert each word to each word in the string to uppercase if length is greater than 4. This is our requirements. So how do we achieve this? Let's see in the example. So I have string tokenizer. I'll use just space as delimiter, and then I'll use a new string buffer and save the result in this new string buffer. So what I'll do, while has more tokens, I'll take string say temp and assign the next token here. And if temp of length is greater than 4, what I'll do, I'll use result dot to uppercase. else I'll use result dot temp as is. And finally, I'll add space in between the tokens, and I'll print the original string S, and then I'll print the result. So let's try to compile and run this program. Compile. I should remove this. Compile. Execute. So if you see the string which is more than 4 characters is in uppercase and everything else is in lowercase. That's how we can achieve this requirement. You put the results in the notes. This completes our string classes. Now let's look at regular expressions. So what is a regular expression? A regular expression is an expression which represents a group of strings according to some particular pattern. So what does that mean? Let's see some examples. We can pair a regular expression to represent, say, credit card PIN number. So usually credit card PIN will be from 0 to 9. So this is a regular expression. Anything else cannot be a credit card PIN number. Similarly, we can prepare a regular expression to represent, say, mobile number. We can prepare regular expressions to represent names as well, etc. So on and so forth. So what are the steps to prepare regular expressions? The first step is to import java.util.regular expressions package. The second step is create an object for pattern class, provide a format.
Number 3, create match object to get matched string. Let's look at one example to get more clarity on this. For example, I will import little.regex package and say my string is something like A1 B space M9 C space H8 I4 uppercase J 6 A3 special symbol W, maybe @ uppercase X and Y star. Now I need to declare a pattern. P is equal to pattern dot compile and I need to look for, say, 0 to 9. Now I need to matcher M is equal to P dot matcher S. So I'll use a while loop and say M dot find and I'll print M dot group. Let's compile and run this. So I'll get all the numbers which are present in my string from 0 to 9. So these are the available numbers in the current string. So that's how I get the regular expression 0 to 9. Say, for example, if I just need uppercase A to uppercase Z. Let me compile and execute. I have uppercase J, uppercase X, and uppercase Z. So that's my result. Say, for example, I need 0 to 9 and uppercase A to Z. Let's see how the result will look like. Compile, execute. So if you see here, this is the only occurrence where you will see 0 to 9, which is 4, and uppercase Z. So here there is an uppercase X, but it is not having a number in front of it. And we have an uppercase Z, but it doesn't have a number in front of it. So this is the only pattern that is available. So that's how you can get another kind of pattern if you define that way. Now, let me change this to lowercase a to lowercase z. Let's see how many such patterns or regular expressions are available. compile, execute. So I have 1B, 9C, 8I, then 6K, then yeah, that's all I have. Get the result here. So we have some predefined character classes. Let's see what are those. If you use lowercase s, then you get spaces. If you use uppercase yes, s, you will get except spaces. So let's see how this works. Uppercase s, compile. Execute. You'll get all the characters without spaces. I'll not paste the result, it's too long. If you use lowercase d, you will get all the digits. If I change this to lowercase d and execute, you'll get all the digits available in that string. And if I do uppercase d, you will get everything except digits. If I use lowercase w, word characters, like A to Z, comma, uppercase A to uppercase Z, comma, 0 to 9. If I use dot, you will get all characters. So if you do lowercase d, then you'll get all digits from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If I don't want some digits, say for example, I need until 5, then I can use a regular expression like 0 to 5. That will only give 0, 1, 2, 3, 4, 5. So this is how you can define a regular expression. So you can use user-defined regular expressions as well. So say for example, you can use A, B, C. What it does, it will get you either A or B or C. Say for example, if I use app, then I'll get except A, B, C, everything else. And say for example, if I use 0 to 9, I'll get all digits from 0 to 9. And if I do cap 0 to 9, I'll get except digits from 0 to 9. And if I do A to Z, lowercase a to Z, then I'll get all lowercase characters. And if I do uppercase A to Z, then I'll get all uppercase characters. Similarly, if I do cap of A lowercase a to Z, I'll get except lowercase characters. If I do cap of uppercase A to Z, then I'll get except uppercase characters. I can also do A to Z and uppercase A to Z. Then I'll get all lowercase and uppercase. And if I do not A to Z, then I'll get except lowercase and uppercase. I can also do A to Z, uppercase A to Z, 0 to 9. Then I'll get lowercase, uppercase, and all digits. So you can define any number of user-defined regular expressions based on your requirements. Let's move on to something called quantifiers. What are these? Let's see some example. If I have a string S and say I have 1AB, then 2AB, then 3AB, then 4AB, then 5AB, then 6AB. And then my pattern match is for A, then try to print the matched pattern. So let's compile and execute. So I have all the A's here. I can also do A plus, so it will print all the patterns that are there instead of single A's. So let's compile and see the result, how it looks. So it will get all the patterns which have at least A and those many A's that are present. And I can also set the size. For example, A of 3. If there are 3 or more A's, just print those regular expressions. So let's compile and execute. I have 1, 2, 3, 4, and 5.
So let me summarize. If I use just A, then exactly 1A is printed. If I use A plus, then 1 or more number of A's. If I print A of M, then I'll get exactly M number of A's. With this, we finished strings of Java. In this session, we will try to continue to uncover loops and finish loops. The last loop that we will uncover is for each loop. It is most enhanced version of for loop. It was introduced in Java 1.5 version. It is used to get the values from an array or collection. So what is the difference? For primitives, we use for loop, and for arrays and collections, we use for each loop. So let's look at the syntax. How does a for each loop looks like? For data type, var name or variable name, then array or collection, and you can write some lines of code in the loop that close the loop. So let's see one example to demonstrate for each loop. Let's say I have an integer array called A, and I have 10, 89, 69, 34, 52, 77. Let's try to put the positions 0, 1, 2, 3, 4, 5. So if we have to use a for loop first, what we will do, int I equal to 0, I less than a dot length, I plus plus, and I'll try to print a of I. Let's compile. And execute. So I'll get all the elements in the array. This is a simple for loop. But if I have to use a for each, it's more straightforward. Int item and array A. Then let's try to run this program, compile. I need to just print the item here. Compile, execute. I'll get the same result, but for each loop is more advanced and less code. Let's see one more example. Say, for example, I have string array and say colors. And I have red, blue, green, say white, and black. I don't need to count the positions here. So for each string, color, and my array is colors, print color. For the sake of clarity, I'll just put uppercase each color. So it should print all the colors in uppercase. Let's try to run this. Compile. Execute. I'll get all the colors in uppercase. So let's summarize loops. While use if we don't know the number of iterations. Do while we don't know the number of iterations, but minimum execute the loop one time. For loop, if we know the number of iterations, use for loop. For each, if we want to get the objects one by one from an array or collection. The next statement is transfer statements.
if we want to transfer the control from one place to another place, first transfer statement is break. It is used to break the loop execution based on some condition. Similarly, we have continue. It is used to stop the loop execution based on some condition and then continue from next iteration. We will see examples to understand these transfer statements. For example, if I have a for loop, say int I is equal to 1, I less than or equal to 10, I plus plus. Let's get rid of this string array. So if I is equal to 3, then break. Else print I. So let's try to compile and execute. So what it does is it will start from 1, and if it is not equal to 3, so it will print the 1, increment to 2, not equal to 3, it will continue to else print 2. It is equal to 3 this time, then break. So the program ends there. So that's how break works. So if I change this to continue, what happens? It will go on I equal to 3 equal to, then it will continue. It will skip the 3 and print all the other numbers. Let's see, compile, execute. It will print everything except 3. So that's how break and continue works. So let's try to summarize the statements so far. Selection statements, simple if else, else if, nested if, and also switch case. The next one, iterative statements, while, do while, for each. The next one, transfer statements, break, and yeah. With this, we have completed loops in Java. Now let's move on to the next important concept called object-oriented programming.
in Java. Some people also call it as hoops concepts. So let's first just look at all the OOPS concepts. First one is a class. Second one is an object. So class is something like a blueprint, and object is the actual or physical, say for example, building. So class is plan for building. Object is a physical building. Third concept is abstraction. So what is this? If you drive a car, you just need to know how to drive it. You do not need how car internally works. So that's the abstraction concept. Fourth one is encapsulation. So you're working on a project, you have to group all related files in the project, say in a capsule. Next, we have inheritance. So you can use one class properties into another class, basically reusability. Then you have polymorphism. If you have data that is represented in more than one form, it's polymorphism. Then we have overloading, different types of overloading. Then we have overriding. Then we have method hiding. Then also we have data hiding. Then we have, say, message passing, also called as injection. Then we have access modifiers. Then we have access specifiers, so on and so forth. We will uncover as we progress. Now, let's look at something important, which is containers. So what are containers? A variable is a container. It can hold only one value at a time. Then we have array. It can hold multiple values, but of same type. To overcome this, we have collections. It can hold multiple values of multiple types with variable size. So what is an object in Java? It is the topmost element in Java. They accommodate and manage all other elements in container. For example, let's say vegetables and fruits. We can put them in a basket or a bag. So the following are the different types of containers available in Java. What are those? First one is class. The second one is an abstract class. Third one is an interface. Fourth one is enum, etc. We will uncover all of these as we progress. Let's see class. What is a class? If we want to represent real world entity in coding format, then we should go for classes. So it's basically a collection of different types of variables and methods. Let's see some examples. So far we have seen so many test classes. Test is a class, demo is a class. Say for example, account is a class, person is a class, savings account is also a class name, product, and we have also seen array, index, out of bound exception is a class name, string is a class name, etc. So on and so forth. So we have predefined classes, something like this string. Also, we can user define classes, like we can declare a class in Java by using class keyword. And we have seen so many programs, the syntax looks like this: class and class name. And then some code inside a class that close it. So after compiling a Java program, .java program, a separate .class file will be created for each class present in Java program. In this session, we will try to uncover access specifiers and constructors. What are access specifiers? To provide security for the variables or methods, we have four types of access specifiers. First one is public. Second one is default. Third one is private. Fourth one is protected. By the end of the object-oriented programming concepts, you'll get the clarity, but for now, I'll explain this in simple terms. For example, I have a neighborhood here, and I have some houses inside the neighborhood. And here I have one big building with 3 floors, and it also has a compound wall around it. So this is a neighborhood, and this is a road. So let's assume there is a tap, water tap here. So who all can take water from here? The people who are in the neighborhood, and also the people who are on the road who are not belong to this neighborhood. So that is public from anywhere we can access it. So for example, let's say if I have another tap inside this neighborhood, who all can access? The people from the road cannot access inside this neighborhood. Obviously, the people who are inside the neighborhood can access the water from this tap. That is basically default. Access from current environment. Now let's suppose I have another tap inside this house. Who all can access the water from this tap? Only the people from this house. No other people can access inside the house of another person. So that is essentially private only within the class. The house is, say for example, class. Now let's say I have different families renting out here in this building in the 3 floors.
1, 2, 3 families are renting out here, and I have another tab inside this. So who all can access? These are all the people who are dependent in this building. So these people can access this tab. So that is basically protected. So only within the class and its dependent classes. We will explore each of these as we progress, but that's a real world example to demonstrate these access specifiers. Now let's move on. Say, for example, adding variables into the class. How do we add variables into a class? We have seen this, but we can declare a variable into the class, just like normal variable declaration. I have seen this so many times, but let me demonstrate using example. For example, let's say I have a class called demo, and I have the main class, which is test. So inside demo, I'll declare variable like integer a, then double b, then char c, then boolean d, then string e, then I'll take the object itself, demo. So if I have to access these variables, I need to create an object for demo. We will uncover as we progress, but this is how we declare an object. And if I have to access those variables, I'll use System.out.println and obj.a. And I'll do the same for the rest of the variables. obj.b, c, e, e, and f. If you see, we have not initiated the values for each of these variables. So if we print, we should get the defaults, which we have already covered. Default value of integer is 0. Default value for a double is 0.0. For character, it's just empty character. For Boolean, it's going to be false. For string, it's going to be null. And for object, it's going to be null again. But let's try to execute and print this Java C test.java, compile Java test, execute. So we get 0, 0.0, empty string, false, and null. So now let's see how to add methods into a class. It is also just like adding variable to the class. But it has some syntax, so methods follow below syntax. It could have a return type, then name of the method, and if there are any arguments, or we can also call it as parameters, and then some lines of code. And it should return value, and then the method. So let's look one simple example how to define a method. For example, I have int a is equal to 10, comma b is equal to 20. And I'm defining a method void. Void, if the return type, there is no return type, then I'll use add as the method name, which is basically adds the integers, system out, println, say for example, petition plus a plus b. Then the method. And then inside the main method, main class and main method, we call the demo object using demo object new demo. And then we just need to call object dot add method. So let's execute this, compile, execute. And plus try is 30, that's the result. Now let's move on and look at setter and getter methods. So what are setter and getter methods? As the name suggests, setter methods are used to set the values for variables. And getter methods are used to get the values of variables. Let's see some examples so we get the clarity on how these methods work. For example, I have a string, say the name, and I'll write the setter method here. Void set name, and I'll take the string argument and say a, open, then name is equal to a, I'm setting it as name is equal to a. Now let's implement a getter method here. For getter method, I need I need a return type because I need to get the value which is string, and the name of the method is get name, and I'll use the return, and I need to return the name here. Those. This is how setter and get methods are defined. Then in our actual class and the main method, I'll use student s1 is equal to new. Let me rename this class as student. So new student, creating another object s2 as new student. So I'll set a name here, set name for s1 student a, and for s2 b, and try to get the names printed up. System out println. How do we get it? Using get name. This is for student 1, this is for student 2. So let me execute this, compile, and execute. We have A and B. Now let's move on to the object creation process. So what is an object? It is a real world entity. It is used to access the data from the class, and it is used to store the data for temporary purpose. So what is the syntax? We have to write the class name, then object name, and new class name. We have seen in the examples just before this. And we can also write it something like class name and reference. So when we use the new keyword, a physical memory will be created. For reference, it's just gonna have the name, no permanent memory. So what happens when a new object gets created? JVM will assign a unique number for that object. We can get that number using the function called hashcode. For any object. So what is hashcode? Hashcode is, or maybe hashcode returns integer representation of object. Let's see some examples so we get the clarity on how it looks like. For example, if I have a class A and I'll just remove everything, just empty class, and I'll create a object A1 is equal to new A. I'll create A2 and also A3. So we created three objects, A1, A2, and A3. So let's try to print the hash code for each of these objects. System.out.println A1 dot hash code, then A2 dot hash code, and then A3 dot hash code. Let's try to compile and execute. So these are the hash code values for A1, A2, A3. Say, for example, if I wanted to know the name also, then I can use A1 toString, A2 toString, A3 toString. Let me compile again and execute. This time I got name at the rate, and this is the hexadecimal representation of this numeric value. Get the results. So the purpose of, say, setar methods is to set the values, and for getter, get the values. But if we have to implement the real business logic, we can use normal methods. Also, if we have, for example, say 5 attributes or variables, we need to have 5 setar methods to set the variables for these attributes, set the values for these attributes. For example, if I have 1,000 attributes or variables, then I have to have 1,000 setar methods to set the values for these variables, which is practically difficult. That's why we go for the next concept, which is constructors. So What are constructors? Constructor is a special method used only for initialization purpose. There are some rules. It is a special method and the main purpose of the constructor is to provide initial values. The name of the constructor and class must be saved. This is important. The name of the class and the constructor must be same. And then return type is not applicable for constructors. The next important concept is this executes automatically we are not required to call explicitly. And per object, only one time it will execute. So let's look at one example. So for example, let's say I have one method void m and I write a print statement here. So what I'll write is this is a general method with some actual business logic. So I'll call class A object new class A, and then I need to call the method m for the actual business logic. Let's try to, I have not included the constructor yet. Let's try to compile and execute. So the actual business logic method got executed. For example, I have a constructor. Like I said, it should be the same name as class, so A, and let me write a print statement. And I'm trying to mimic some initialization logic here. Constructor example, initialization code logic is implemented here. And this is going to execute first before the actual business logic, and no need call this constructor explicitly. So I just defined a constructor and I have not called here. Now let's rerun this program. Compile. Execute. So if you see here, this is the first logic that got executed, then the actual business logic got executed. And in the program, I have not called the constructor, so it will be called by default. You don't need to explicitly call it. So now let's move on. So how many types of constructors we have? We have 3 types of constructors available. So what is the first one? Which is default constructor. Second one is parameterized constructor. Or user-defined constructor. What is the third one? Third one is a copy constructor. Let's look at each of this with an example. First one is default constructor. So what is a default constructor? If we are not writing any constructor in a class, then compiler will automatically create a constructor such type of constructor is called as default constructor. Let's see a simple example. For example, if I have a class called B and I'll just remove everything and also remove everything from the main method. So let me just try to run this program. Compile. It's compiled. So if we want to see the profile of the Java program, we have a command called java p. And for example, I need to check the profile of B. So if you see here, this B constructor, which is a default constructor, I have not created it, but it's there by default. So compiler has created it. That's called a default constructor. And this is also applicable for any other class. So let me look at profile of test. So if you see, there is a constructor for test also, which is a default constructor. Now let's look at parameterized constructor. So the constructor which takes parameters is called a parameterized constructor. Let's see example. For example, class student. And inside student, I have int ID and string name and double percent and let me define a student constructor with parameters as we are looking at parameterized constructor int a string b and double c, and inside this constructor I'll assign int id is equal to a, name is equal to b, and percentage is equal to c. So it doesn't have any return type, so I have to write a method to show the student details. I'll use show method. And there is a System.out.println. System.out.println ID plus I'll add a tab space plus name of the student plus another tab space plus percentage of that student. So now in our main method, I need to create student object. Say for example, one student S1 equal to new student, and parameters are 1, comma, say John, the name of the student, and then percentage is 56.78. And I'll call S1 dot show. I'll do the same for student 2, S2, ID is going to be 2, and then name is Tom, percentage is 67, 7. ID is 3, Mike, 77, 27. Let me run this program, compile. I need to change that to S3. Compile. Execute. So what did I do here? I'm showing S1 everywhere. I need to show S2 and S3 here. Save. Compile. execute. So I got all the student details printed to the console. This is called a parameterized constructor. Now let's move on to the last constructor, which is copy constructor. Copy constructor, it is used to copy the content of one object to another object. As simple as that. So let's see how this works. I'll create another copy constructor, which is student here, and then take the parameter as student temp, and then I need to define ID to temp dot ID, then name is equal to temp dot name, then send is equal to temp dot percent. So here, let's say I have student S4 that's equal to new student, and I'll feed S3 into S4. And then let's show S4. Let's compile. Execute. So I got the fourth student details using a copy constructor. That's how a copy constructor works. I'll stop here, and this is the end of this session. In this session, we will try to uncover instance context. If the data is changing from one object to another object, then we should go for instance. Object to object, these activities are different. So for example, let's say name of any person, it's going to be different. Let's say SSN, it's going to be different. Mobile number, it's going to be different. Email, it's going to be different, etc. So there are three scenarios. Number one, instance variables. Number two, instance methods. Number three, instance blocks. So let's try to uncover each of these one by one. So let's first look at
instance variables. If the value of variable is varied from object to object, then we should declare instance variables. So let's look at a simple example. For example, I have a class A, and let's say I have an instance variable I. I'll remove all of this. And then in my main class or main method, I'll try to call or create an object 1 called new object A. I'll also create 3 more, object 2, 3, 4. Then let me try to print this offering line. Object 1 dot I. And let me do it for all 4 objects, 2, 3, and 4. And I did not initialize instance variable, so it's going to be default value, which is 0. Going to be the same for all the objects. For example, if I assign object 1 I is equal to 1, 1, 1, and do the same thing for rest of the objects, object 2, 2, 2, 2, object 3, 3, 3, 3, 3, object 4, 4, 4, 4. And if I print the instance variables now, we get 1, 1, 1, 2, 2, 2, 3, 3, 3, and 4, 4, 4. Let's try to run this. File, execute. I'll get 0, 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. That's how we declare instance variables. And for each object, the value differs. Now let's look at instance methods this time. So if we want to access instance variables, then we should go for instance methods. Let's look at one example. So here I'll create another method to show the instance variable show method. And here I will print System.out.println. The value of I base plus, and now I don't need to use System.out.println, I'll just use object one dot show I, and I'll do the same for all four. Object 2, 3, 4. Let me file this. Execute. This is how we can create instance methods. Now let's go to instance logs. So it is a block that is a set of instructions. It is a nameless block, and it executes automatically when an object is created. Let me give some example. For example, class A, and I will remove all of this. No name for this block, and I'll just say this is instance block. And I'll just create 4 objects. Let me run this, compile, and execute. So it has created 4 instance blocks. Now let's look at what is the static context. We have seen so far instance context. Now let's look at a static context. For example, if I have 1,000 students, so 1,000 string objects for storing, say, email IDs, which will be unique. So 1,000 objects will be created. For example, I need to create 1,000 string objects for storing country of that student, and it's going to create 1,000 objects. But here, country is fixed. For example, all students are in USA. So the country is going to be USA. So for storing single string, we are trying to create 1,000 objects, which is wasteful resources. That's when we go for static. So what it has, one string object, but shared by all 1,000 students, which makes more sense. So what are different examples where we should go for static context? So for example, country name, as we discussed, or number of students in any particular class or anything like that, which is constant, and counter variables, etc. So there are three types in static context. One is static variables. Two is static methods. Three is static block, which is similar to instance. So let's explore one by one. First, let's look at static variables. A single copy will be created and shared by all objects. Let's go with an example. For example, I have int I and then static int j. And let me create 4 objects and then try to assign object 1 dot I is equal to 1 1 1 and 2 3 4 object 2 2 2 2 object 3 3 3 3 object 4 4 4 4. Then if I create object 1 j, which is static, and I'll assign 7 7 7. And now let me try to print all these values. System.out.println obj1.I, and it's gonna be 1 1 1. Let's do 2 3 4 and then obj dot j. So this is going to be object 2, which is going to be 2 2 2, object 3, which is going to be 3 3 3, object 4, which is going to be 4 4 4. And now I'm printing object 1.j, which is going to be 7 7 7. So if I do print for rest of the objects, like static is shared by all the objects, it should print 777 for all of these. Let's try to compile and execute. So if I change this, or maybe I leave it here, and then in the next, I'll assign it as 888. Now 77 is gone, 888 is assigned, so it's gonna print 888 for all of these 4. Let's try to compile and execute. So for the static instance, we can also try to fetch it using just class name a dot J. That's also gonna give us the same result. Let me file and execute. So we have got 5 triplets this time. Let me get this example. Now let's move on to static methods. For example, if we want to access static data, then we should go for static methods. We can call static methods by using either object or class name. Both are just fine. Let's see an example. For example, if I have void method 1 and let me print say instance method. This is an instance method. So for static, I will use the static keyword void m2 and say static method. And here I'll just create an object, single object, and object dot m1, which will get the instance method, object dot m2, which will get the static instance. I can also use a dot m2 for static instance like we discussed. We can use object name or class name. Let me compile. Execute. So I've called static instance 2 times with object name and class name. That's how we can declare static methods. Now let's uncover static blocks. It will execute automatically when a class is loading. So for example, static and say this is a static block. And in the main method, I'll create object 1, 2, 3, 4, 5. Let me compile. And execute. So it will only get executed when the class is loading. It doesn't execute whenever the object is called. Even if we call 5 objects, it got executed only once. That's when class is loading. Let's move on. This is one important keyword, which is this keyword. With this keyword, in Java is used to refer the current class object, which is executing. So we can use when refer current class variables. Then we can use referring to current class methods. Then we can use refer to current class instructors. Then we can use for current class objects. So let's see each of these with some examples. So to refer to current class variables, for example, I have a class A, and say for example int I is equal to 111, j is equal to 222. Then void method m int I comma int j as parameters. And here System.out.println, let's suppose I value plus I plus j value j. This is what I'll print for now before using this keyword. So here I will just create an object, say A, and try to run this before we use this keyword. Compile, execute. So I have not called any method. So if I call a dot m is equal to 333, 444, then I should get the I and j as 333 and 444. I'll use a space here. So, for example, I need to access these I values. So for that, what I'll do, I'll use this dot I and this dot j. So now if I run it, I'll get oh 333 444, then 111 222. This is how we can refer the current class variables using this keyword. Now let's move on to
current class method. Let me change this class name to demo. And I have int a comma b, and then I'll create a constructor demo with two parameters, int a and int b. Then I'll assign this dot a is equal to a, this dot b is equal to b. I don't need this. So now I'll create another method to get a max of two numbers. So here, return this dot a greater than this dot b question mark a, otherwise b. And let's create another method, show method, to print the result console. So System.out.println a space a plus and b plus b, then max is plus max method. So now I'll create a demo object, new demo, and I'll pass 23, 45 and call object dot show method. Let's try to compile and execute this. So we have got a 23, b 45, max is 45. For example, if I wanted to make this method private and do not show the implementation to the user, then I'll change this to this dot max and try to run this again, compile and execute. That also works perfectly, but we just made the implementation method a private, so we abstracted the logic. The next refer to current class constructors. We have, let's create a constructor.
demo and make this empty, and let's say no args structure. And create another constructor, say int I, then int arg constructor. And let's say next constructor with double arg constructor. And in the main method, we create a new demo object, and we don't need the arguments to call the first one. Let's execute this one. Execute, we got the no arguments constructor. For example, if I give some integer here and then execute, I didn't compile and execute. I got int argument constructor. Let me send a double. Execute, I got double arg constructor. And here, if I wanted to call no argument and int argument, even if we send a double, then what I can do, I can use this keyword, this no argument, and then this some integer value. So even if I send a double, I'll get the compile. Let me take one at a time. I didn't save. Okay. Compile and execute. So I got no argument and the double argument. This time I'll comment no argument one. File. Execute. I got int and double this time. Now let's move on to the last. How to refer to current class objects. Let's look at the demo method one. And here I'll call the demo D itself, new demo. And then return D. And for method two, I'll just use return this keyword. So in the demo object, I'll create in the main method, I'll create demo object and try to print print ln object. then I'll get the hash code. Hash code value of this object. Let me try to file and execute. So I got the name @ hash code value in hex format. For example, if I do the object dot method 1 and object dot method 2, compile and then execute. If you see, the first value and the last value is same because method 2 is using this keyword, which is basically referring to the same object, and that's the reason you will see the same value for the first object and the method 2 object. This is how you can refer to current object using this keyword. I'll stop here. In this session, we will try to uncover where method and also inheritance. So a method which can receive any number of arguments, including 0, is called as where method. See an example. For example, class demo. I will create a method void int 3 dots and a variable, and let me just print where method. And in the main method, I'll call the demo object and try to call the object no arguments, and try to call with 1 argument, try to call with 2 arguments, try to call with 3 arguments, with 4 arguments, with 5 arguments. We compile. And it goes. Let me compile and execute. So I've called 1, 2, 3, 4, 5, 6 times. So 6 times it got executed, and it can take 0 to any number of arguments. That's a where method. let's uncover overloading. Then we will go for inheritance. Overloading, say for example in C language, if we have to find max of two integers, then we create a method or a function. And if we have to find max of a float, then you need to create another method or a function, even if the functionality is same. And if you have to do a max of long, then also you need to create a new method or a function, even if the functionality is same. But in Java, we don't need to do that. We can just create one method or a function, max of int. We can do max of float without having to create a new one. Then we can also do max of long without having to create another function. So having same method name with different parameters is called as overloading. So let me take one example, class demo void m, and I will do the empty arg, and I'll say no argument method. Then create another method. This time I'll take one integer argument. I can say this as one argument method. And then this time I'll take two arguments, int a comma int b, and I'll say two argument method. So I'll create a demo object. I'll just call empty m, then one argument, then two arguments. Let me try to compile and run this. Compile. Yes. So we have called all the three methods using three objects. Copy the result here. Let me try to create a calculator app, for example, method add. And if I send nothing, just return 0. And it's not going to be void, it's going to be int. Maybe I'll return one string print line statement. And for example, the next one, if I get one argument, then I return the argument itself. Then if I get two arguments, int a comma int b, then I'll return a plus b. And finally, if I get three arguments, I'll return a plus b plus c. So let me just put System.out.println around this. Without arguments, then I'll get a 0. And then one argument. then I'll get the same number itself, and 2 arguments, I'll get 10 plus 20, which is 30, and then let's say 3 arguments, which is 60. Let's try to save, compile, and what did I do? Okay, my method name is not M, it's gonna be add. Save, here, compile, execute. So I got the result as expected. Let's maybe look at another example. For example, I have a class student and int ID, comma, string name, comma, double %. Then I'll create a student constructor. This dot, first I'll just use ID as 0 default values, and then name as null, and % as 0.0. Now create another constructor. This time I'll say int ID, and then for ID, then I'll create this dot ID is equal to ID, and leave the rest of them as is, and create another constructor with string name. So this time I'll make it this dot name and assign name to it. Then the last one, I'll create it. This time it will take all 3 double %. And for here, I'll put this dot % and assign %. I'll get rid of this. So what I'll do, I'll create student S1 is equal to new student, and I do not send any arguments. And I also, here I'll create a show method, and I have returned the print statement, but again, that's fine. System.out.println and ID plus tab space plus name plus tab space plus %. So now I'll create student and call show method. And then create student S2
and I'll give the serial number for the first student. And I have to show S2 here. And for the student S3, I will send the ID and the name. And I'll show S3. And for S4, I'll send ID, name, and also percent. 67.67 and show S4. This is essentially constructor overloading. File and first time I got all null, zero default values. For second time I got ID, third time ID and name, fourth time I got all of them. Method overloading. And then we have constructor overloading. I'll stop here and continue inheritance in the next session. In this session, we will try to uncover inheritance. So what is inheritance? Basically extending or extracting properties from one class to another class. What is the keyword used for inheritance is extends. And what is the advantage? Essentially code reusability. So whichever class is sending the data is called a parent class, or some people call it a superclass, or base class, or old class. Similarly, the one which is receiving data is called child class, or subclass, or derived class, or new class. So we have three types of inheritance. One, single inheritance. Two, multi-level inheritance. Three, hierarchical inheritance. So let's uncover each of these one at a time. First one is single inheritance. So let's see a sample example. Class A, and I have a method which is returning void, and let's say print System.out.println a class M1 method. And let me see. I'll declare another class. Maybe I'll copy this, I'll change it. Class B and say M2 method and say it's B class M2 method. And in the main method, what I'll do, I'll just create an object B is equal to new B. And then I'll try to call B dot M2. Let's compile this code, execute. So I got B class M2 method is called. So if I wanted to call M1 method from class A, I need to create an object here. But object creation is a costly operation. For that reason, we can use inheritance. And for inheritance, we need to use your expense and class A. Now, if I try to call B dot M1, it's gonna inherit from class A and call the M1 method. Let's compile and execute. So both methods are called. This is using inheritance. Now, let's look at multi-level inheritance. So for example, for multi-level, I'll create a grandparent class, and here I'll say grandparent, and class C, which is parent class, and it also extends grandparent class, and method M2, and I'll say this is parent class, and I'll use another class, say child class, and it extends the parent class. And I have a method M3, and I will denote it as child class. So here, what I'll do, I'll just create an object for child class, and I can call method M1, method M2, and method M3. So basically, when I create an object, so M3, and it can extend to parent and parent M2, and it also can extend to grandparent. So it will get the M1 also. So let's save and compile. So this is how multi-level inheritance works. Now let's explore or uncover hierarchical inheritance. I'll change this to parent class, make it a parent class, and then make it C1 child 1 and extend the parent class
make this as child 1, then make this as child 2, and extend child 2. Here I'll create an object called C1 and extend class C1. Then I'll call C1 M1. C1 extends parent class M1, then also call M2. I'll use M2 and I'll create another child 2 object C2, new class C2, and C2 dot M1 parent class, C2 dot M3 child 2 class. Let's try to compile. What did I miss here? This is of C2. Save this, compile, execute. So I got parent, child 1, parent, child 2. This is called hierarchical inheritance. I'll stop here and continue. In this session, we will continue to uncover object-oriented programming concepts. And in the last session, we have uncovered inheritance and also method overloading. In this session, we will try to uncover method overriding and a few keywords like super and final, and also we will try to uncover abstraction. So what is method overloading, which we have discussed earlier? Method overloading, we will have same method name with different parameters. So what is method overriding? Method overriding, same method name with same parameters. And how is it possible? For method overriding, we need a parent class and a child class. Let's see some examples for method overriding. So I have a class P, which is parent class, and I'll define a method M and say this is a parent method. And I'll get rid of this second child class from the previous example. I'll define a child class and it extends the parent class. And for now, I'll just get rid of any method in the child class and try to compile and see. I need to get rid of this old programs object. So I'll create an object for child class and define it as, and also call the object method M. Let's try to compile this and execute. So I do not have any methods defined in the class, so it called the parent class method. I have not implemented the method overriding as of yet. Just take the example here first and put the results there. So
Say, for example, I'll define the same method. That's a requirement for method overriding. The method name should match the parent class method, and say child class. Now, the child class is having the method implemented. This time, we are just gonna get the child method execution, not the parent, because this is method overriding and we already have a method the same name as parent. So let's execute. This time the child got executed. And that's method overriding. So what did we learn? For example, if the child is not satisfied with the parent class implementation, then obviously child can define its own implementation for the parent class method. This concept is called as method overriding. So let's summarize what is the difference between method overloading and method overriding. So overloading method name must be same with different parameters. Whereas overriding method name must be same with same parameters. That's the key difference between method overloading and method overriding. So now let's move on to uncover the super and final keywords. Let's begin with super. So if you remember in the earlier sessions, we have covered that parent class is also called as superclass, and child class is also called as subclass. So we can use super keyword to interact with parent class. So how do we do? We can use super with variables, and then we can use super with methods. We can use super with structures. Let's uncover each of these with examples. So for super with variables, what I'll do in the parent class, I'll define an integer a is equal to say 10, and I'll not implement any SOP statements in parent class. And in the child class, we'll find integer a again and assign 20. And say, for example, I'm just summing the numbers a plus a. And if I try to execute, what I'll get, obviously, when we use a, it currently points to the local variable. So it's going to be 20 plus 20, which is 40. I have not used super as of yet. Let me compile and execute, and I got sum 40. I'll just take this program, put it out here for the notes, and also copy the result. Now I have a requirement that I do not want to add 20 two times, but I want to add 20 with the parent class 10. So what I'll do, we have uncovered this keyword in last sessions. So I'll use this dot a and it will point to 20, and I'll use super dot a, which will point to 10 in the parent class. So this time it's gonna be 20 plus 10, which is 30. Let me compile and execute. So this time I got 30. That's how we use super with variables. Now let's move on and uncover super with methods. So for example, let me implement a method inside the parent, and I'll just make it as parent and then get rid of this. And I'll get rid of the integer here. And in the child, I'll implement another method. And try to run this now. I'll get the child class output. That's the expectation. I didn't use super as of yet. I'll just retain the program and results here. Save it. So I have a requirement that I need to implement the method which is inside the parent class, even if I define the same method inside the child class. For that, I'll just do super and m method. And now let's see how this works out. Execute. Now it worked out well. I have executed the method inside the parent class as well as child class. That's how we can use super with methods. We'll get the result and put in the notes. Now let's move on and uncover super with constructors. Constructors we have covered in the previous sessions. What are the requirements for constructors? The constructor name should match the class name, and you do not need to explicitly call constructors because constructors are used for initialization purposes, so they will be executed automatically when the program starts execution. So now let's see an example. Like I said, the name should match. The constructor P should match the class name P, which got matched. And I need to make this as constructor C, which will match the child class C. And I do not need a method dot method here. I'll just use super, and I do not need to explicitly call
constructors, it will be executed automatically. And let me compile this and execute. So this is how super can be used using constructors. Now let's move on to the next keyword, which is final keyword. So if we want to provide some security restrictions, then we can use final keyword. Let's try to uncover final with methods, final with classes, and finally final with variables. We'll see each of these with some examples. Let's uncover final with methods first. So for example, I have a void method m in parent class, and I have void m in my child class. I'll get rid of the super here. And if I want to call the method, I'll call object.m. So this will execute and it has no issues. But for example, if I want some restrictions in my parent class that I don't want anybody to call or override this method, I'll declare this as a final method. Now, when I try to extend this to child class, it should not allow, it should throw an error. It says you cannot override a final method. So if you want to provide any security to your parent class method, then you can use final. Now let's look at final with classes. It is same like method. So here, let's say class doesn't have any implementation. It does want to extend parent class. If I do not want anybody to extend my parent class, then I'll define the final class as final. Then I'll try to compile. I should get an error. So it says cannot inherit from my final class. So that's how you can secure your classes with final keyword. So what is the need for a final to declare in front of a class? For example, you have, say, implemented some 1K plus lines of code, which you do not want other classes to extend. In that case, you can define it as a final class. Let's move on to the final variables. It's again the same thing. I'll just
get rid of all of this. Say, for example, I have an integer x is equal to 10. And if I try to increment let me print the initial value. And if I try to increment and print it again, it's going to print 10 and 11. But for example, in my program, see this x is constant and I do not want anybody to increment it. So then I'll define it as final. And if I define it as final and anybody is trying to increment or change it, what we get an error saying cannot assign a value for a final variable. So what is the use case? For example, in math, you have pi value, which is constant, and you cannot change the value of a pi, right? So let me show you the profile of this java.lang.math. And if you see here, it has the pi value and it is declared as final, which means that it's a constant and you should not change it. So that's the use case of final in variables. Now let's move on to the next concept or keyword, abstract keyword. If we don't want to provide implementation for any method, we can declare that method as abstract method. That is without any implementation. For example, I'm implementing a project for a company called Toyota, which is a car company. So what I'll do, I'll create a Toyota class. And inside that, I will create an abstract method. And say the method name is start engine. So this is the parent class for the Toyota project. And I have one method, which is start engine. And I do not want to give any implementation for this method. And that's the reason I set it to abstract. As soon as I have at least one method in a class, which is abstract, then you have to set the class abstract class. Let me jot it down. If class has at least one abstract method, you need to define that class also as abstract class.
So if we do not want to put any implementation inside an abstract method, then why do we need it? I'll explain here with this simple example. I have a car company called Toyota, and it has so many cars, and each car has this method called start engine. But there are different models in this Toyota company, like RAV4, Sienna. So each car should start, but the way it starts differs. For example, for some cars, you need to put the physical key inside to start the car or start the engine. And for some cars, which are keyless, you just have a button and then just press the button, the car gets started. Regardless of what car you have, you will have this start engine method, and you will not give any implementation, and you will define it as an abstract method. Then after that, for each class, for each car, you will define another child class, and then you will set the implementation for the start engine. So let's see how we can achieve this with an example. So for example, I have the parent class, which is an abstract class because I have one abstract method inside it, which is start engine. Now I have a child class, and say it is RAV4, and then it extends the parent class Toyota. So here I'll implement the start engine method. And how do the RAV4 starts? That's what is implemented here. Let's say, for example, I'll just mimic a SOP statement. And here, what I'll give, RAV4 use physical key to start the engine. Okay, I have extended the child class RAV4 and implemented the logic for the start engine. And in my main method, what I'll do, I'll just create a RAV4 object and say RAV4 new RAV4. Now, how do I start the engine? I'll just RAV4 dot start engine. And let's see if my RAV4 starts. Compile. And start the RAV4. RAV4, you use physical key, and RAV4 start. Now, let's see another child class. Say, for example, I have SCM, and it again is from the Toyota company. But for Sienna start engine method, use button keyless entry to start the engine. For Sienna, you don't need a physical key, so I'll just create an object for Sienna and start this year. But for Sienna, it's gonna have keyless entry and button to start. Let me compile and start both cars. So RAV4 use physical key to start the engine. Sienna use the button or keyless to start the engine. So now you know what's the use of abstraction. So you will just set a method in the parent class, which is absolutely necessary for your child classes, but the child class will decide how to implement that method. That's the abstraction concept. I'll put the result here. I'll summarize. So, what is a concrete class? Concrete class, it's a normal class where all implemented methods which are fully defined. These are normal classes. And what is an abstract class? It will have partially implemented methods. You might have implemented methods plus non-implemented methods, which are abstract methods. I will stop here, and in the next sessions, we will uncover interfaces in Java. In this session, we will try to uncover interfaces in Java. So if you remember in the last session, we have summarized concrete classes and abstract classes. What is a concrete class? It is a normal class where all implemented methods are fully defined, like have bodies. And it is not abstract. Then what is an abstract class? Abstract class at least will have one abstract method inside, which is partially implemented method. In other words, have implemented and non-implemented methods. So that brings to another concept called interface. An interface is 100% pure abstract class, which means that all the methods inside an interface are abstract methods. An interface contains all non-implemented methods. We can create an interface using interface keyword.
and we can use implements keyword to use interfaces. So let's go for an example. So for example, I'll take this as an interface and name it as say I, and I'll declare two methods. And since this is an interface, we don't need to declare the method as abstract because it's the definition itself says that interface will have all the abstract classes. So now let's define a class A which implements I, that is interface. And let me declare method public void m1 and System.out.println and m1 method implemented as A in class A. I'll get rid of this, and in the main method, I'll create an object for A object new of A, and then call object dot m1. Also, when we implement an interface, it's mandatory that we implement all the methods inside that class. So m2 method implemented in class A, and then create another object for m2 method. Now, this is essentially the interface definition. Let me compile. Execute. So I have both m1 and m2 methods executed. Now let's move on to packages in Java. So packages are a collection of different types of classes and interfaces. It's called package. So there will be two types of packages: predefined packages and user-defined packages. So what are predefined packages? Already available in Java. User-defined, we have to create manually. So what are some different types of predefined packages we have seen so far? Java is a package, IO is a package, util is a package, lang is a package, SQL is a package, regex is a package, etc. We'll cover SQL in later sessions, but that's a predefined package. So for user-defined packages, I have some steps to create user-defined packages. So let's try to uncover what are these steps to create user-defined packages. The first step, first statement in Java program for a user-defined package should be package and package name. So let me create one example as we look at the steps. The first step is package and package name dot examples. Say for example, this is the package name. And the next step is define classes and methods based on the requirement. So the third step is we have to compile the Java program using the following syntax so that it creates a package. So Java C space -d dot demo math dot Java package. -d is to create directory structure automatically. And dot is used for current working directory. Then fourth step is we can import the package in any Java program. So let's see some example. How do we create a package and import it to any Java program? So here I have created a package. It's com.example and create a class public class demo package demo. And here I'll create the method as public and say, for example, method 1, and I'll write SOP statement just to mimic some logic for, say, for example, arithmetic operation. M1 arithmetic operations. M2, let me just call it as logical operations. So I have completed the program. Now let's try to create a package for this Java D Java C minus D dot package dot demo.
Java. Package has been created. Now, for example, in my test.java, I wanted to use that package. What I'll do, I'll just use import com.example dot package demo, and in my main method I'll create package demo, say pd, and new package demo, and pd.m1 pd.m2. Let's try to compile and see if we can execute this program. Compile, execute. So I have M1 arithmetic operation, M2 logical operation. So that's how we can use packages in Java. This is package .java, and we can import that in our test.java. And this is the result. So far we have covered abstraction, encapsulation, data hiding, data sharing, and also core reusability. So these are the 5 main pillars of OOPS concepts, and with this we have finished object-oriented programming concepts in Java with examples and results included. I'll stop here and continue. In this session, we will try to uncover exception handling in Java. So to understand what is exception handling, we need to understand some definitions. First one is error. What is an error? Abnormal termination of any program is called as an error. What are the different types of errors? First one is syntax errors. The second one is logical errors. The third one is runtime errors. So what are syntax errors? Syntax errors is some mistake in the program. So the program will give warnings if you have syntax errors in the program. So you can rectify them. Then we have logical errors. Logical errors are logical mistakes in the program. We will understand this as we progress. And then runtime errors are during execution of the program, external sources
For example, some input messages which are invalid will create runtime errors. That also we'll see. Runtime errors are also called as exceptions. Handling these runtime errors is called as exception handling. So there are 5 keywords to handle exceptions in Java. The first one is try. Second one is catch. Third one is throw. Fourth one is throws. And fifth one is finally. Before we uncover each of this, we need to understand the exception hierarchy. In Java. So here I have shown the diagram of exception hierarchy in Java. So we have an object, and under which we have a throwable object, and then we have 2 types of classes, which is exception and error. Exception, you have runtime, IO exception, SQL exception, AWT exception, and then under runtime exception, we have arithmetic exception, null pointer exception, and so on and so forth. And under IO exception, we have file not found and file interrupt, IO exception, and then under errors, we have virtual machine error, assertion error, exception, initialization error, IO error, AWT error, stack overflow error, out of memory error. And runtime exceptions and its subclasses and errors and its subclasses are unchecked exceptions. So we have 2 types of exceptions, which are unchecked and checked. We will explore them. And these are all unchecked exceptions. All other exceptions are checked exceptions. Now let's look at unchecked exceptions and checked exceptions. Let's look at the definitions of unchecked and checked exceptions, and then we will move on to the examples. In Java, some exceptions are raised when we are compiling the Java program. Such type of exceptions are called as checked exceptions. So let's see some example. So here I'll use a file handling object, print writer. We will uncover this in the file handling session. But for now, to create an unchecked exception, I'm using it. So print writer, and let's say abcd.text. What it does, it checks for this abcd.text file in the current working directory. And if it is not available, it will throw an exception. And for this, we need to add java.io package for file handling. Let me compile this. So if you see here,
Java compiler is creating an exception saying file not found. So this is a checked exception. Sorry, this is checked exception. This is unchecked exception. So these are checked exceptions. Some exceptions that are raised when we are compiling the program, we call them as checked exceptions. Let's move on to unchecked exceptions. In Java, some exceptions are not raised when we are compiling the Java program. Such type of exceptions are called as unchecked exceptions. Let's look at an example. For example, I write a system SOP statement, System.out.println, and try to divide 10 by 5. There is no issue with this program to give the result. So it's 2. But now, if I divide it by 0, then it compiled fine. But when I execute, I got an error saying arithmetic exception and division by 0 is not allowed. So this is called as unchecked exception. So in order to handle these kind of exceptions, we can use try catch. So try and catch keywords. It is highly recommended to handle the exceptions using try and catch. So how does the syntax look like? You will have a try block and you will have a catch block. What goes in a try block? You will have some risky code which can generate exceptions. And those exceptions we need to handle using catch block. Let's look at some example. For example, let me import Java little package and I'll create a scanner SE equal a new scanner and take the input from the user System.in. We have uncovered this long back in the previous sessions. And System.out.println, I'll give a prompt for the user, say enter first number. And I'll use print println so user can enter in the same line. Then I'll assign that user entered input to an integer a. Then
I'll also get another number, enter second number, and I'll assign it to B. Now what I'll do, I'll use a try catch block. Try and add some risky code here. What is that? I'll do System.out.println and say division, and A divided by B. And I'll write a catch block, and I need to create exception object. And here I need to write the code to handle the exception. For now, what I'll do, I'll just create a SOP statement saying division by 0 is not possible. That's what I'll print to the console. So let's try to compile and execute this program. Compile fine, execute. First time I'll give first number as 10, second number as 2. I'll get the division as 5. Let me try to divide it by 0. Execute. First number is 10, second number is 0. Then it says division by 0 is not possible. So instead of program erroring out, I handled it nicely, and we get the message, and the user will correct the inputs. This is how we handle the exception. Now let's move on and explore various possible methods to print exception information. You can understand what this means shortly. So if you remember the diagram, we have throwable class defines the following methods to print exception information. One, print stack trace. What it prints: name of exception, description, and stack trace. And then another method, toString method. What it prints: name of exception and description, no stack trace. The next one is get message method. What it does, it's the description. Now let's look at examples for each of these methods. So in the same example, instead of, maybe I'll retain this, or maybe I'll comment it out. And then what I'll do, eobj dot print stack trace. Now let's try to compile and see what it gives us. Compile and execute. I'll enter 10, I'll enter 0. Now it says Java lang arithmetic exception divided by 0 is not allowed. So now let's try to use the next method, which is e object dot toString. I'll try to save this first. This is for print stack trace. Get rid of this, and I'll also get rid of this, and I'll paste the result here. So now this one is for toString method. File. I missed the open and close braces here. Compile and execute. Enter first number 10, second number 0. Then it just printed the name and description. I'll try to paste under toString method. Now I'll change it to get, or I'll retain this and out and change this to get message. Forgot to compile it. Compile. Execute. The first number 10, second number 0. This time I only got the message. Now let's move on to finally block. What does finally block do? It is not recommended to take some cleanup activities inside try block, because if any exception is raised inside try block, automatically the control will transfer to the catch block. For that reason, we have to use finally block. Finally block will execute independent of exceptions. Let's look at one example. So here, if I create finally block and I just mimic some cleanup activities. So this will execute even when try is executed and also when catch is executed. Let's try to compile. I didn't close brace here. Compile, execute. First time I'll give valid ones, 10, 2, 5. I should use 11 here so that I'll get the cleanup activities in the next line. Compile, execute. So enter 10, 2, division is 5, and then cleanup activities. Now let's do the same thing in case of exception, where catch is executed. 10, 0, and then still cleanup activities is executed. So any cleanup activities we need to define in finally block. Now let's move on to throw keyword. So far what we have seen, if some number is divided by 0, then exception will be raised automatically. And if I do division by a valid number, then there is no exception. For example, if I wanted to divide it by the same number, you will not get any exception. But my requirement is I should not allow same number division. So if user inputs the same number, I want to create exception. So that's when we go for throw keyword. We can use throw keyword to throw user defined exceptions manually. So let's look at some examples. For example, in the same example, what I'll do, I'll use if condition A is equal to B, then throw new exception and state that two number must not be same, something like that. To divide, then else I'll divide it, and I don't need any cleanup activities. I will clear this file. I was this one. Compile, then execute. I'll enter 5, 5. And it says two numbers must not be same to divide. I'll do one more time. Compile, execute. Enter 10, 10. Two numbers must not be same to divide. So this is how we can use throw keyword to define user-defined exceptions. Let's move on to the next keyword, which is throws keyword. Throws keyword. So let's do the same file handling example. I'll use print writer PW is equal to new print writer, and I'll write to some xyz.txt. And what I'll do, I'll just write hello. And then close the connection. We will get to understand each of these in file handling. For now, for demonstrating throws keyword, I'm using this. So for using this, I need to use IO package. I'm not using throws keyword as of yet. I'll get an exception when I compile, which is expected. So now, for example, I do not want to get the exceptions in this case. So I'll just paste the exception here. So in the above program, file not found exception is reported. So in order to handle, I can use try catch manually. And programmer is responsible for handling it. The next one is throws keyword. So navigating to default exception handler by JVM. If you are anticipating any exceptions in the program and programmer didn't handle them, you can use throws keyword and define the exception object. So this way you can avoid any exceptions which you might not use try and catch to catch those. Obviously, you have to write some additional logic how to handle those exceptions, but just to demonstrate, I'm using throws exception. I will use try catch to handle the same exception, get rid of throws. Put these two lines inside try block, which is basically code, and then create a catch object, exception, obj, and here I'll write a SOP to get the message. obj dot get message. Compile and execute. Let's summarize the exception handling. First one is try. We put some risky code here. Second one is catch. We put the handling code here. Third one is finally. We put the cleanup activities here. Fourth one is throw. Hand over our created exception object JVM, then throws. Navigate, check exception to default exception. I will stop here and continue. In this session, we will try to uncover file handling in Java. File is a place on secondary storage where information is stored. For that, we need to use java.io package. So we have got several different classes like file, writer, then buffered, writer, print, writer, which we used in the last session. We will try to uncover it in this session. File reader, buffered, reader file input stream file output stream. We will try to uncover each of these one by one. Let's uncover file first. It is not used to write or read content. It is used for file management operations. We have different constructors in file. First one is Boolean create file, then string get name, then get path, then long length, then Boolean access, then Boolean can read, then Boolean can write, then Boolean can execute, then Boolean is file, then Boolean is directory, then Boolean make directory, then Boolean delete, etc., so on and so forth. Let's try to see some examples. We will use java.io package and file f is equal to new file of, say for example, mango 1.txt. And I'll write an SB statement, System.out.println, and see if this file exists. And then create a file. And then check if it exists again. Let me hear this compile. Okay, this throws an exception, so we have to handle it. So I'll use throws exception that we have covered in the last session. Compile, execute. So first time the file doesn't exist, so second time created the file, then the file exists is true second time. Now, for example, let's explore some more functions like get name, then get path, then they can read, then can write,
can execute, then f.exists, then f.length. Let's try to compile and execute. So the file name is get name is mango1.txt, then can read true, can write true, can execute true, exist true, and length is 0. There is no content inside the file. Now let's move on to the next item, that is file output stream. This is used to write information, write binary data from Java application to particular target file. So how do we define it? File output stream FOS is equal to new file output stream and provide a file name. That's the syntax, and FOS dot write, and we can only write in bytes format. So byte, then FOS dot close connection. Close the connection. And I'll change this to file output stream FOS is equal to new output stream, and say for example I'll write it to aaa.text and define a string data is equal to welcome to file handling Java. Or I'll write into the file, and like I said, we have to convert it to byte. B is equal to data dot get bytes method. Then FOS dot write B inside the file, and then FOS dot close connection. Let's compile. At the end, I'll write maybe a message stating file is created. Compile, execute. File is created now. Let me place this here. And now let's uncover file input stream, which is used to read information. So how do we define it? File
input stream FIS is equal to new file input stream file name, and we have methods like available, FIS available, the size of file bytes, and then have FIS dot read byte data. Then we have FIS dot close. Let's try to see one example. So I'll change this to input stream, I'll change this to FIS, change this to input stream, and byte B is equal to new byte Chris dot available. Then FIS dot read, then we only get the output in the byte format. So let's make this into string format or readable format for us. And then before closing the connection, we will print the data from the file into console and then close the connection. Let's try to compile this. And execute. Welcome to file handling in Java. That's what we have written using file writer, file inputs, output stream. Now let's move on to file writer. So we have file writer, file write FW is equal to new file writer, file name, and you also have file writer, file name is true. Then we have file FW write, int. Then we have FW char. Then we have FW write string. Then we have FW dot flush. And then we have FW dot close. We'll use each of these in one example and see how it works. So file writer FW is equal to file writer, let's say BBB text, and FW dot write
say for example 75. Then say for example FW write Java, and then character array ch, I'll define a character, F I L E. Then I'll write this character ch, then I'll use a new line, then fw.flush, and fw close. Let me try to compile, execute. It got executed successfully. We will see the output in the following examples. So there are limitations with this file write. Number one is we have to insert new line characters separately. Next, the new line is OS level concept, so it can differ OS to OS. And the next limitation is we can only write hair data. So to overcome these issues, we have the next concept, which is buffered writer. So how do we write a buffer writer? Buffer writer BW is equal to new buffered writer new file writer. Oh, file name close. So we have functions bw.write int, we have string, we have char, then bw flush, then bw close. And we have a new line method. Let's see one example buffered writer. buffer writer PW is equal to new buffer writer and new file writer. Say let's take CCC this time and PW write say 97. Then I'll add a new line, PW dot new line. Then I'll add string a new line, then write a string bcc, then bw flush, then bw close. Let's try to compile this. Compile and I'll execute. Let's move on to next one, print writer. So I'll directly take an example, print writer PW is equal to new print writer, say text. Now pw.println 111, then print character a, then print the boolean true, then print the string a, then print a double 47.67, then print pw flush, then pw close. Execute. So all of these output files you can verify on your own in your present working directory. Next one is file reader. File reader fr is equal to new file reader and give the file name and fr.read it will give int value. If it is -1, then it's end of file, and then fr.close. Let's see one example. Let's make this as file reader fr is equal to new file reader, and let me try to read the same test.java file itself. And
int ch is equal to fr dot read, and we have seen that at the end of the file it will be -1. So when it is not equal to -1, then we try to System.out.println console. So this is going to be in binary format. I'll try to change it to character, and then ch equal to fr dot read should assign the output of fr dot read. Then after this, I'll close fr dot close. Let me compile, and there shouldn't be a space here. Compile, execute. So it's printing all the lines, one for each line. So in order to get rid of this, we can go for buffered reader. So instead of file reader, I'll change this to buffered reader br is equal to buffer reader as dot new file reader and we'll read each line at a time. String line is equal to buffer reader read line, and while line is null, then print line and then br read line, then close the br. This will print the content of the file line by line. Compile. I have to change this to line. Compile. Execute. This way we got the program what we have just written line by line. I'll stop here.